Imagine everyone watching this video has been told at least once that Python doesn't have private attributes. But what if I told you that it did? And then what if I told you that it didn't? It's a very confusing and complicated issue, and it's thrown off a number of people, both thinking that it doesn't have private attributes and that it does, because it does have this special syntax to do it, but that's not really what it's designed for. So in this video, I'm going to be explaining what the confusion is all about. I'm going to be showing you the implementation of it, and I'm going to be talking you through what it's actually designed to be used for. Of course, if you found this video helpful at any point, then consider liking it to let me know, and maybe subscribing if you want to see more videos like it. If you're feeling extra generous and want to support the channel further, you can do so by becoming a member or a patron. All the information you need is in the description below. With that out of the way, let's talk about Python's private attributes. So to start, I'm going to create a class just called test, and we're going to create a class attribute, and we're just going to call this class attribute. But we're going to have this double underscore syntax here, and then we're going to create an instance method. Let's say we take x, which is an int, or like a string or something, and then we do instance attribute like here, and then we do say like instance, and then whatever string you pass through. And this syntax works exactly the same on instance attributes as it does on class attributes. It also works exactly the same on methods. So if I were to do this, for example, and then have it return self.instance attribute, that would function exactly the same. So if we come down here and we do our run guard main, there we go. I forgot how that worked then for a second. And then we do print, let's do test.class attribute to begin with. And then we could do t equals test, and then just hello, I guess. And then we can do print t.instance attribute. And if we were to run this now, we could see the begin error saying type object test has no attribute class attribute. Did you mean class? If we then get rid of this, we can see that we get the same error, though we get a slightly spoilery error. Attribute error test object is no attribute instance attra. Did you mean underscore test double underscore instance attra? And this error kind of spoils the surprise of what's going on under the hood there. And if we try and run the method, so t.method, whoopsie, t.method like that, we'll get the same error, test as no object as no attribute method. So what's going on here is when you define anything with a double underscore syntax like this, Python takes it upon itself to make it harder for others outside of the class to access it. So it will append an underscore and then the name of the class in front of the variable name, but only if you're running it outside. If you're running it inside, so if I just do this and then do this, I'm running the method, but you can see actually if I print it, that would be a bit better, that it's actually able to access this attribute internally. So in a way, it sort of does work like private attributes, but also not so much, because you can still access them. They still appear in messages, and if I were to do dear t, they would still appear. I need to print that as well, don't I? They would still appear here, and not only that, they would appear at the start. You can actually get around this last thing, this dear. If you wanted to throw people off a little bit more, you could do like define a dunder dear and then take self, and that returns an iterable of string that we need to import from typing import iterable, and then come down here. If we do return filter, when I can type, that would be nice. Lambda x, not x dot starts with, and then you could do something like self dot class dot name if you wanted it to be portable. If you didn't want it to be portable, you could just put the class name in here and it would be fine. That's not what I wanted to do at all. And if we do that around super dot dir like that, If we then run dir of t, we then get rid of those things, so they don't actually appear in the directory. So if you wanted to throw people off using that, you could, but obviously the errors from 3.11 question mark onwards, maybe 3.10, will give away the game anyway. Now to actually show you real quick that that does actually work, so if we did print test underscore test class attribute, and then if we did print t dot underscore test double underscore instance attra, and then if we did print t underscore test double underscore method, if you run all those, it will still complain, which is interesting. Why is that complaining? Oh yeah, because I removed the double underscore, didn't I? Yeah, okay, that makes more sense now. So if I do then this again, that should know. I thought I'd uncovered something that I'd missed then. And then this won't work anymore. Yeah, there we go. Cool. Well, fine. That's good enough. It shows it is accessing it. I forgot to call it because it's a method. You will see that MyPy does complain. So it says that type test has no attribute test class attra because it's not defined up here, and the type system doesn't know that these exist because these get created at runtime. So if you use these, they're not statically type safe. So if you want to create type safe code, then I guess you could say they are actually private. But yeah, it's a weird one. You may be wondering what the actual point of these attributes and methods actually is, and the idea is it's not private per se. It's done to avoid name collisions. So to demonstrate that, if I were to create a second class called test2, and then that inherits from test, if I were to specify a class attra here and have it be new class attribute, and then if I were to go down to the bottom here and get rid of all this because it's really horrid, and then print test2 dot underscore test class attra, and then if I were to do the same but have test2 class attra, you'll see that it actually print different things. So this underscore test prints the attribute from this class, but underscore test2 then prints the attribute from this class. But because test2 inherits from test, it inherits this test dunder. No, it's not dunder technically, is it? Underscore class attra, but then it also has its own one for reasons that are beyond me. I don't really understand why you would need these. In all complete honesty, I can't really think of a use case for name collision logic like this. I feel like if you're doing something that requires this to be a thing, you should probably do it differently, or find some other way to do it. Ideally as well, if you did want to provide private attributes, then you should really follow the naming convention of just using a single underscore, and then get rid of all this crap. And then you'd have a property here that did def instance attra self, and then return string, and then return self dot underscore instance attra. And then you could set a setter if you wanted to, and that would take value, and then it would you would then define your setting logic from there. Sort of like maybe because that's a decorator. Yeah, that's not how you do it at all. And then that would be instance. Might as well complete this example while we're here, and then that would be, I suppose, technically an object, but you could do it however you wanted. And then you could just have self equals value. You could do some other validation, yada yada yada. So this would be the way you would ideally want to do it. If you wanted a read-only, you just do this. If you wanted something that was completely private, you wouldn't have properties at all, and you just have it like this. I'm very much a proponent of if people break something by doing something they're not supposed to be doing, that's their fault, not yours. So if they break something by accessing this, and that's their own problem. But yeah, it's worth keeping in mind that nothing is truly private in Python, even though things may seem to be on the surface. But yeah, that's everything I wanted to talk about with regards. This is probably the most colourful shirt I own. A lot of people, like colors. And I don't blame them. I like colors too. I like spending a lot of time creating really fancy terminal interfaces with all different colorful bits all over the place. Something that's not traditionally colored in Python are error tracebacks. If you use something like IPython, and you do get some nice little error tracebacks with all sorts of colors, but if you just use normal C Python, or I think most implementations don't bother changing this, then you just get this block of white text that can sometimes be a little difficult to get your head around. Or for those people that thought that errors were a little difficult to read, or those people that just wanted an injection of color into their errors, Python has finally answered you. And from Python 3.13, error tracebacks are now colorful. It's not just the colors of the errors that have changed though. So in this video, I'm going to be taking you through that, obviously, but I'm also going to be taking you through the other changes that have made errors more verbose, but have also made them a little bit more intelligent. And for those of you that don't like colors or can't use them in your terminals for whatever reason, I'm also going to be showing you how you can turn them off. Of course, if you find the video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more like this. If you're feeling particularly generous, then you can become either a member or a patron. All the information you need is in the description below. But I know you're just itching to see these colored tracebacks in action, so let's just get on with it. So we're loaded in the terminal here. I have Python 3.13.0 Alpha 2 Plus installed. This plus just denotes that it's the development version. I got it from PyEnv. I think this might be the latest Git release at the time, or the latest Git like commit at the time that I downloaded it. But yeah, this is Alpha 2. So what I'm about to show you, and I will say this before we say, might change slightly between now and when it's released. If it does, I will say in the release video when it all comes out. But for the most part, all the things that I want to talk about are at least present. So I'm going to get your hype up now. So I'm in just the interpreter because this is really easy to show off because I could just do a zero division error. So I think everyone knows what Python errors normally look like. You have the traceback, most recent call loss, etc., etc., etc. But it's notably all in one color. Until now, because now this is a very bright purple in this terminal. Wow. But we have the error actually in red. We have the actual exception in purple, and this is a much lighter purple in VS Code. And you have the file in purple, the line number, and the module in purple. So purple and red are the two main colors. I think I've seen blue before, but I am going to be showing more complicated real-world errors using this color scheme in a bit. But on top of it being colorized, we have this arrow here. Now this arrow in stuff like this, I believe has been present since Python 3.11, though I have noticed in other errors that this sort of, point at the error system has actually been slightly improved. But yeah, we have that. If I were to do something like, string, string.lower, just, an undefined string, it will actually say that the name string is not defined, and then because it's a standard in module, it will tell us, did you forget to import string? But it actually knows that it was this bit that caused the problem, and then it has all the different errors and stuff. So if I now go into an actual project, this is my project Analytics. I've talked about this a few times on the channel, but this is kind of a development file that I use to just run various situations. And the important thing to know, I'm not going to explain how this all works, but the important thing to know is that start index equals 0 is not valid. There is a validation step that checks to make sure that the start index is at least 1. So if it's 0, it will throw an error. And that's all you need to know about this file, really. So I'm going to show you what the error looks like in Python 3.12 first, just so we have a point of reference, because they are very different. So if I run this, ignore this warning up here. This is just because I'm using a dev version. But you see, we have this traceback here, starting from, actually, I might pull the terminal down to get rid of all the stuff we don't care about. There we go. So we have the traceback, most recent call last, and then it does a good job at pointing to the lines that are problematic. So we have, pointing to this, and then pointing to shard.fetch report, which is the internal thing. And then inside this fetch report, we have a query.validate, which is the validator. And then inside this, there is a check, which then raises invalid request. And then we have invalid request, the start index should be positive. Whether or not 0 is positive is a debate for another day. I personally am of the opinion that it's not. It's neither positive nor negative. It is 0, but, do what you will with that. But if we were to set my local to my 3.13 one, and I already have Analytics and everything installed, if you run this again, we'll see that the error looks much, much different. So I'm going to pull this up quite a way because the error is quite a bit more verbose here. So now you can see that this section, this statement is colored, but it's now pointing at the actual parameters themselves. Now it's not smart enough at the moment to be able to figure out which parameter exactly is causing the problem. That might change as Python 3.13 develops. This is a very early alpha version, as I said. But then it comes down here and it actually does the same thing. So on these multi-line ones, it has this slightly awkward syntax of pointing to all of them, and then this has this 8 lines here. I'm not sure this is entirely necessary. Maybe if they do figure out a system to identify exactly which argument is causing the problem, that will be omitted. And then you have the same thing here with the self.scopes. And then the error at the bottom is in purple here. If I were to do something like this actually spits out an even more complicated error. You'll see it does largely the same thing. So it points at dimensions in the country, or the day in the country, sorry. Points here, query.validate. It then goes further into self.rtype.validate and does all this stuff. Self.dimensions.validate dimensions, and then it comes up with invalid request dimensions, country and day cannot be used together. Error. But you see again that purple, maybe I was imagining things when I saw blue. I'm sure I saw blue, but maybe it was something in this terminal that I saw. But purple and red are the color schemes that they have used so far. Whether that will change or whether that will be able to be changed, I don't know. One thing you can do, if you really don't like the colors, you can set, I'm just going to do it like this, set Python colors equals 0 before launching the Python interpreter. And what that'll do, if I do 1 divided by 0 now, is it will disable all the colors. So it will keep all the extra pointing stuff, but it will disable all the colors. And yeah, just keep in mind that it is the American spelling of colors, not the British spelling of colors, like I did the first time I tried to do that. On top of the Python colors envar, there is also the no color and force color variables, which this makes it sound like they were already present. So maybe they were already a thing in Python, I just didn't know about them before. But you can use this to force colorization or force no colorization. Or you could just use Python colors equals 1 or 0 to do it. I think if Python colors equals 1, it will only colorize them if the terminal supports it. Whereas if you use force color, it will try and do it regardless. Don't quote me on that, but that's my understanding of it at the very least. But yeah, that's all I wanted to talk about in this video. If you have any questions... Python deprecated the package resources module when it deprecated setup tools in 3.12. And if, like me, you use that package resources to maybe output some debugging information in your library, for example, where it was installed, or whatever, then that's probably a little bit of a problem for you. While you can continue using package resources from 3.12 if you install setup tools manually, that's not the recommended way to do that anymore. And the new way, I said a new way, it's been around for a while, but a newly recommended way of doing it, not only, in my opinion, is actually easier, but it's also backwards compatible because it's not brand new. The importlib module has been around for a while, and so this package resources deprecation isn't actually that big of a problem, even if you need backwards compatibility with old Python versions. So in this video, I'm going to be showing you how to use the importlib module in place of where you would have used package resources previously. Of course, if you find this video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. If you're feeling particularly generous, you could support this channel further by becoming a Patreon member. All the information you need is in the description below. But with all that out of the way, out with package resources and in with importlib. So I'm going to start off by showing you how you would do it in the old package resources way. So if we do from package resources import get distribution, and then if we had say dist equals get distribution, and then I have my project analytics installed, and then we could do something like print dist.version. And you'll see we get this warning saying that the package resource is deprecated, but we also get this version number at 5.1.0. That's the version I have installed. Also happens to be the latest version of Analytics. And I do already have setup tools installed. This won't work unless you have it. Although you will still get deprecation warnings both in your IDE, or this is actually saying the library stubs aren't installed. But you will get deprecation warnings in the console if you continue to use package resources. So package resources has been replaced. I say replaced, these things have existed for a while. But the recommended way to do it now is using from importlib import metadata and from importlib import resources. So if I just get rid of all this, and then I will import them one at a time and then kind of show you how to use them one at a time. So metadata is how to get information about a distribution. Resources is actually manipulating the files, or at least being able to open them, being able to view what files are part of the distribution and such. It does appear when you're looking through some like methods and that there's some overlap between metadata and resources, and I do believe there is, but certain things are different between the two. So I will kind of point those out. But to do what we did before, to get the version, you would do print metadata dot version analytics, and this just gets the version of the analytics package. If you wanted, say, the entry points, you could do, if I could double click, there we go. You could do that, although the entry points, I believe, I'm just going to test this, yeah, it needs a named argument for this one, which is a bit weird. But you can see this comes up as an empty tuple because analytics doesn't have any. If we provide black, oops, we have our entry point as black there using the console script. So the entry point is the entry points part of the setup .py, and this is what the metadata really handles. There's not much else to it. If I quickly just show you, so metadata dot, and then you get these. So distribution is a little bit closer to the package resources distribution. I'm not too sure what it does differently because it just seems to be a lesser version of metadata, but I don't know. If anyone does know, then let me know. You also have files, which returns a list of files for the name package, which this is one of the things that's actually different because resources has this too. But this returns literally everything that is part of it, including, weirdly, the tests. I feel like those shouldn't be in there. Maybe I've messed something up in analytics, but yeah, that does that. So if we now move on to the resources side of things, so if I just commented this out so it doesn't get in the way, and we import resources from importlib. And this is more the file handling per se. It allows you to look into a distribution, see what files it has. It allows you to see where it's installed. And you can actually read and open the files and probably write to the files as well, however you want, which is certainly an interesting way to use it. But to get the main install location, what you would do is you would print metadata dot, not metadata, print resources dot files analytics. And you'll notice that we have files here for metadata and files in resources. But you'll also notice when I run this that the two do very different things. So files in metadata, as you saw, outputs all the files in the distribution. Files in resources outputs the root directory of the distribution. So in this case, it's in users, my name, pym version, cbr resources lib, 3.12, site packages, analytics. So this is where it's actually installed. And if I were to go here, yeah, sure. Yeah, here we go. That's not what I was expecting it to do. I was expecting it to do it in a new tab, but I suppose we're doing a new window. But you can see this is analytics. I can open the client and it's all there. And if we do say, .glob style.py, we can see we can get a list of if we do a list around that, and then my terminal. There we go. We can get a list of all the files within all the Python files that I've done within that directory. So that's how you can start scanning things. If you wanted to actually read a file, of course, it's just a Python or it's just a pathlib object. So you can do resources.open text or open binary analytics, and then provide the name of the file, so say client.py. And if we do .read, and if we just print that, it will just print the contents of the file out to the desktop, or not the desktop, the terminal. I'm getting all my words confused today. But this is just the file as it is in the installed distribution. So this is one way you could look at the source code if you wanted to. You could also use the write if you really wanted to write things. I don't necessarily know why you would in this context, but that's available to you. Some other things in the resources. As file, so this calls it a traversable object in the files as well. You then have contents, which is deprecated. You then also have a number of things that are also deprecated. The path, this is the file path to a specific file. So if you wanted to, get the actual file path to client.py, then you can do so from there. Or you can do read text and read binary as well. Okay, I went the long way around. But you get the idea with how you use these things. So that's all I wanted to talk about in today's video. If you have any questions. In this video, we're going to be talking about something I've talked about on the channel before, but surprisingly not in a huge amount of detail, and that is Deques. Deques are part of the collections module, so I would have talked about them a little bit, maybe like 2 years ago or something, but they are actually really useful. They have a lot of cool features. They're incredibly performant, especially in pop and insert operations, as I'm going to be showing you later. And they really are something you need to know if you're going to master Python. The performance isn't the only thing I want to focus on today though. I want to take you on a little bit of a tour of Deques, kind of show you what they do, how they work. They are very similar to lists in a lot of ways, but you can append to and pop to the left as well as the right. And it also has a few nice little extra features that I want to show you as well. Of course, if you find this video helpful at any point, then consider liking to let me know, and maybe subscribe if you want to see more videos like it. If you're feeling particularly generous, you could become either a member or a patron by using the information in the description below. But with that out of the way, let's finally talk about Deques. Before we start, a few things. So I've got a whole new setup. I've got a new microphone, a new way of recording. So hopefully everything sounds okay, fingers crossed. Second thing, there's going to be a lot of jump cuts. I've been ill over the last week and a bit, and I've still got a bit of a cough, so sorry about that. But before we get into the actual meat of the video in terms of the title, I want to show you how Deques work and a few cool little features with Deques. So Deques are short, and yes, they are pronounced like that, short for double-ended queue. And what that means is that you can append to either the left or the right and pop from the left or the right. So if we do from collections import, there we go, Dec. And if we use our run guard, we could do fruits as an example. Is a Dec, say, of an empty list. And then, yeah, it can take any collection. MyPy is going to complain because when you do this, it says it needs a type annotation. So we're going to give it one. You could just do a Deques string like that because we're just going to have a series of fruits. And you could say append fruits. Well, actually, let's give it some. Let's give it apple, an orange, and a banana. And say fruits.append. Let's use a tomato as an example. Not typically considered a fruit, but technically is one. But you can also do fruits.append left, say mango, and append it to the left of the list as well. And then if you were to print fruits as it currently stands, you would get mango, apple, orange, banana, and tomato. Apple, orange, and banana were what we started out with, and then mango is what we appended to the left, and tomato is what we appended to the right, which is the default. You can also pop from the left and the right. So if you do fruits.pop, well, actually, if I do print, and then pop left, and then print fruits, you'll see that we pop from the right by default, so we get tomato. We pop left, we get a mango, and then we can see that we are left with our original Dec. Much like lists, you can also remove things. So if we wanted to do fruits.remove apple, we could. We can also del or delete items from the list. So if we wanted to delete orange, we could do that. If we then bring back fruits, we could see that we just have a Dec of banana left. The one thing we can't do is we can't pop at a specific index. So if we were to do fruits.pop again, we can see that it doesn't take any arguments. And this is what I want to talk about later, because Deques actually have a much more efficient way to do that than something like lists do. We'll talk about that in a bit, because I first want to show how I found out about Deques to begin with. And that is the maxlen property, which can turn out to be quite helpful. So if I create a new file, maxlen.py from collections, import Dec like that, do the run guard, it's always good practice. There we go. And then we create a new Dec, not called that, say belt. And then we have a Dec, that's an empty list, let's say, or let's say an empty tuple, let's mix it up. And we could do a max len of, say, 5. We'll say 5. And this means that the Dec can only be 5 elements long. If I just give it its type in there to get MyPy to shut up. So what this means is that when you append to the Dec, if the Dec is already 5 elements in length, length, you'll get a pop left effect. If you append to the left, you'll get a pop effect if it's already at 5 elements. And this is particularly useful in certain situations. One that I'm going to show you today is about simulating a conveyor belt. So conveyor belts are only so long. So if we had a series of components, say that was just a list A, B, if I could type, and X, and do from random import choice. And if we say for I, well, just do an underscore in range 50, we then choose to append a choice of components like that. And if we print the belt, it's called max length, this one, we can see that the length of the deck never exceeds 5. So if we go up here, we start, oh my God, it did 3 A's in a row. That's interesting. Random generation. You see it's element 1, we have 2 elements, 3 elements, 4 elements, 5 elements, and now it has 5 elements, it can't exceed that. So when it adds this extra B, you'll see this series of 3 A's becomes a series of 2 A's, because this A has been taken off the end of the belt. And when I say it's a pop left behavior, I don't believe it returns the value that's been popped, though we could always check, I suppose, because I genuinely don't know. No, it doesn't. Okay, so it's not a pop left, it's more like a delete off the deck. And the reason it's able to do all this, including being able to pop left, pop right, append left, append right, feeds very nicely into why decks are so much faster than lists when it comes to popping and inserting. It's because of the way that decks operate. So lists hold all their values sequentially in memory. So say if the first element of a list was in memory address 0, the next element will always be memory address 1, the element after that would always be memory address 2, etc, 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 until you get to the end of the list. With decks, that's not true. Decks have their elements spread all over the place, and they're connected by a series of pointers. Anyone that knows what a linked list is, you've got the right idea. Now, the difference is here is that when a list pops an element, let's say element number 2, all of the elements after it have to be shifted over in memory, which is a very expensive operation. When decks do it, all they have to do is update the pointers, so the one preceding and the one after both point to each other instead of the one that was popped. I'm not 100% sure why exactly this is, but that means that you can only pop from the left and the right, despite the fact that you can delete from anywhere. So if you were to pop an element by its index, you would need to rotate it first. And this is going to seem somewhat unnecessary, and it's going to seem like it's a lot slower than doing it by list. But while I'm doing this, remember that it is genuinely faster, and I'm going to prove it. So if we have our run guard in here, and then we have our, I'm just going to copy paste this. I don't particularly want to type it out all over again. And say if we wanted to get the second element, we could do, if we didn't want to remove it, we could do something like this, and it would get orange. But if we wanted to pop it, what we would need to do is we need to do fruits.rotate minus the index, and then we can print fruits. You don't need to print it, we just want to show that it is popping the correct element. And then if we wanted to restore the original order, that we would need to return the deck back by giving it the same index again. And if we print fruits, we can see that if I'll just run the file again, we can see that we get orange, so we printed orange again, but we're popping orange the second time round, and our deck is in the same order as it was, just without the orange. So we have mango, apple, banana. If we were to follow this, it'd be mango, apple, and banana. The orange isn't there. So this is a 3-line operation to perform a pop. But if I were to go into our benchmarks and do benchmark pop, this is a particularly weird and complicated thing, but it is programmed properly. So 2 very important things before I run these. 1, the collection being used is quite large, 250,000 in this case. Obviously, the effects or the performance difference is going to be reduced on a smaller collection. The second thing to keep in mind is that due to the way the benchmark is programmed, there are always 250 pop operations for both the list and the deck. And then the list and the deck, I don't think it would matter in this case, but they have exactly the same numbers. The deck is just created through the numbers list. So if we were to run by benchmarks and then benchmarks pop, we will see that Deques are an awful lot faster. And you'll also see something quite strange in that Deques get slower, or as Deques get slower, lists actually get slightly faster. And that's because the further along the list you have to go, the less items you have to move into place. So if you had a list that was 100 elements long, if you pop the second thing, you would have to move the other 97 elements across. If you pop the 98th thing, you'd only need to pop 2. Or you'd only need to move 2, sorry, not pop. So that's why lists speed up over time, but even in the Deques worst case, it's still significantly faster than a list. The effect is actually even more pronounced if you do insert. So I will show the benchmark off very quick. It's just the same thing, we're just inserting the number into the particular position, and you would do your rotate and append left, or you could append right if you wanted to, but you'd need to do some extra maths on the number to get it in the right place. And you'll be able to see that the effect is actually even greater with inserts than it is with pops. I'm not entirely sure why this is. I guess insertion operations are more complicated than pop operations, but everything is having to be moved out of the way before something can be inserted in a list. With a Deque, you're just saying, all right, this points to this and this points to this. And this final thing here for index 25,000, so this will be the absolute final element of the list. So even when there's nothing to move, lists are still quite a bit slower than their Deque counterparts. I don't know why that is, but that's true. If we then run the append benchmarks, we'll see this is a slightly weirder benchmark, but lists are actually faster when it comes to appends. So if you're only ever going to be appending stuff to the right of the collection, then lists may be the way to go. But in pretty much any other situation, Deques are faster. But that's everything I wanted to discuss with Deques. If you have any questions. If you're looking to get into the world of data science in Python, there are a few things you absolutely have to know. And one of them is Jupyter Notebooks. Jupyter Notebooks allow you ultimate control over what you do. You have an interactive series of cells that you can edit and modify as you go along. You can perform non-destructive editing using these cells as well, using the advanced preview features. On top of all that, it actually provides really nice error messages for you to quickly debug your code. In this video, I'm going to assume you've never seen a Jupyter Notebook in your life, and walk you through how to create your first notebook, how to create markdown and code cells, teach you how to use all the different parts of the interface, as well as cool things like magic commands and graph rendering. Of course, if you find this video helpful at any point, then consider liking it to let me know, and maybe subscribe if you want to see more videos like this. If you're feeling particularly generous, you can support me further by becoming a member or a patron. All the information you need is in the description below. With all that out of the way, let's learn how to use Jupyter Notebooks. So to get started with Jupyter, what you need is a notebook interface. And you could do so on Jupyter's website. You come to jupyter.org and then they have their own interactive notebook environments. What I'm going to do instead is use Visual Studio Code instead. It has built-in Jupyter kernel support. I imagine a lot of other IDEs do as well. I'd be very, very surprised if PyCharm didn't, for example. So you can use your preferred IDE if you want, but I'm going to be using Visual Studio Code. The differences between all of them are extremely minimal, if there are really any at all. It all works the same. It's all the same standard, so it's all fine. So what we're going to do is we're going to go over here and create a file. I'm just going to call it notebook.ipynb, and that is the extension, so IPython notebook. Jupyter runs on top of something called IPython, which itself runs on top of CPython. It's not an implementation of sorts. It's simply just an interactive Python shell that sits on top of it. And it provides some nice little features as well that are, very useful for something like this. So we get given a cell by default, but before we even do that, we need to install our kernel. So if you're on Visual Studio Code, well, if you're on the Jupyter Online Editor, you don't need to do this. If you're on Visual Studio Code, you can come into the terminal, and I've already got a virtual environment and everything set up. You do pip install ipykernel, like that, and it's kernel with an E at the end, not an A. I kept getting confused with that for a long time. And it'll install everything it needs, including IPython, as you can see, including all sorts of other stuff that it wants as well. And then we can go up to the corner here. Yours might say select interpreter or select kernel. And come in here. And then yours might have like environments or something. I'm getting one called select. Oh yeah, this is the menu you get. So you get Python environments will exist in Jupyter Server. You want Python environments, and then you want to set your Python version. So I'm going to set it to CBR Jupyter, which is the virtual environment I set up for this video, and that will then allow you to, containerize all your things. Again, on the Jupyter notebook, you'll be given a Python version. I'm not really sure if you can select your Python version straight up. That's one of the nice things about an IDE is you can use whatever installed on your system. So the first thing we're going to do is show the markdown. So I'm actually going to get rid of this cell, and I'm going to create a new markdown cell here, because in notebooks, your cells can either be code or they can be text. And this is particularly useful for education settings or research settings, or even just something to put notes in. So this supports full markdown, so I can have a title saying this is the title of my notebook. If we save that, and then if we run it here, it will connect to the kernel. It should then render it. Nope, it's this tick. There we go. I'm getting ahead of myself. So we can see that this title is rendered. I believe it does like tables and all sorts. I think it's like fully markdown compatible. So you can put whatever you want, and you can have as many code and markdown cells as you like. So that's pretty nice. If you ever want to edit it, you can come up here to this pencil button for edit cell, and you could just edit what's in here. So I could have like a little subheader that said, and this is a subheader. And then you can click this tick, and it will save it there. All good. Then we can create a code cell by clicking this button here. And you may need to install some things before you want to do stuff. So if you want to use pandas, you might want to install that. You might want to install Seaborn, which sits on top of matplotlib. And you could do that in the terminal if you want, or if you want to make sure that other people can run this notebook as you'd want to, you can use something called magic commands. So magic commands start with a %sign. And then the one we're going to do is pip install, and I'm going to install pandas. I'm going to install PyArrow to prevent a deprecation warning from coming up. And then I'm going to install Seaborn as well. If you don't know what Seaborn is, I made a video about it a long time ago. But it's basically just matplotlib, but nicer, really. And then to either run the cell, we have a few options. So we have this execute above cells, which will execute everything above. We have this one here, which executes this cell and everything below. This one, which splits the cell, which I don't find very useful. We have delete the cell, and we have a few other options here. And on the side, we can just run the cell like this. Or as you can see, we have a little keyboard shortcut. I'm pointing to the screen as though you can see that. So you could either, on Windows, it'd be Control-Enter. On Mac, it would be Command-Enter. On Linux, it would probably be Control-Enter. Or it would be, what would it be? I forget if it's Super-Enter or Meta-Enter. I forget the terminology. But I'm just going to run it like that. And now that will install all of these libraries into our virtual environment that we've selected. So it'll install it into the environment, whichever has the kernel in it. And once that's all done, I'll be able to show you in the terminal. It's taken a little while to do. There we go. It's just finished. You can do pip show pandas, and it's here. So we already have it installed. So that's how you can install packages within the notebook, which is particularly useful. If we get another code cell, we can do another magic command. Another one that's particularly useful is matplotlib inline. This is more just a standard thing. It just makes sure that the graphs and stuff that you use in matplotlib are rendered properly. There are other options to this as well, but a lot of them don't seem to work with Visual Studio Code for whatever reason. I'm not sure if that's a problem with this or just a problem with Jupyter. I believe it's a problem with VS Code. So that's something to keep in mind when you're choosing which editor to use. And then we're going to run that as well. And then while that's running, we are going to import pandas as PD, and then import Seaborn as SNS. And again, we can run that. If we ever wanted to run, everything at once, we can come up here and then we can click this button and then everything will run at once. I'll show that off a bit more a little bit later. When we're talking about running these cells, though, you will notice that these numbers are appearing next to the cell. Not sure how easy that's going to be to see. I might zoom in. We have this number 2 in square brackets here, and you have this number 3 in square brackets here. If I run this again, we can see that this goes to number 4, and this has the execution order. So we can see that this ran first, and then we ran this one afterwards. So that's just useful to keep in mind. You also have the time it took to run. You also have some more detailed stats there. I didn't know you could do that. So you have the time it took to run the cell, which is always quite nice to have, actually. So if we just load a data set in, I'm going to use one of Seaborn's kind of pre-installed ones. This is why I wanted to use Seaborn. So we do sns.load dataset, and then we're going to load the iris dataset. And then we are going to do df.head, which prints the first 5 rows. And then we're going to run that, and we'll see that the result is actually printed for us. Not only is it printed for us, but it's printed in a nice fashion. And that's because the last line of any cell within a Jupyter notebook is output out. And we could change the output mode. So if we come to these 3 dots here and we click change presentation, we can have it in plain text if we want. And this is now the raw pandas output. What I would recommend is having the built-in notebook, well, having text HTML, which then outputs things a little bit nicer. If you want to suppress the output, you can use a semicolon, and it will no longer output what was in the cell. I don't find this particularly useful, but sometimes it could be useful. But we'll leave that out for now so we can see what we're doing. But this also opens the door to do a few nice things. So because pandas doesn't do anything in place unless you tell it to, what you could do is you can use this output to preview some changes. So if we create another code cell, and then if we wanted to do df.drop, let's say we wanted to drop the species column, and then we need to provide axis equals 1, you could use this to actually preview changes. So df.drop returns a data frame, and so the data frame is printed out to us. But you can see the species is gone. But if I was to create another code and do df.head, because pandas hasn't done anything in place, it's still there. So we've done some non-destructive editing, and we've then previewed what was going to happen. So we could do petal width in here instead, and we can see that species comes back. If you want to save these changes, we could do df equals, and then we can preview them with df.head, and we'll see that the petal width column is now totally gone. If we create another code cell and I demonstrate some graphing, the Seaborn is quite nice like this, because you could do just sns.line plot, and we provide df, and then we'll have x equals, say, cpol length, and then y equals cpol width. If you run that cell, then we get a figure that isn't going to display today. Why is that happening? There we go. So you can change the presentation mode to image. It must have selected the wrong mode. Okay, if that happens, just go to change presentation, and then I guess, select the Jupyter Notebook one. That's the one that should have been the default. I'm not sure why it wasn't. Maybe I changed it at some point and didn't change it back. But the Jupyter Notebook renderer should be the default. So if that ever happens to you, that's how you go and change it. But that will then display your graph here. And then if you want to open it in more detail, you can click that button there, and then you can start moving stuff around, zooming stuff in, and all that jazz. The only thing that VS Code does not support is interactive plots using matplotlib. So if you were to select the notebook mode here, if I were to do this, and then run everything again, in a Jupyter, I believe in the online notebook, that will have an interactive plot, and I believe if you do it in a VS Code script, it'll do an interactive plot as well. On this, for some reason, it won't, and I'm not really sure why. So that's something to keep in mind. And as you can see, we're running the cell and below, and it goes and runs everything in order, and then we get the graph back. Before we finish up here, I just want to go over the rest of this top row for you. So this run all will run every single cell every single Python cell in the notebook. So it'll run all this pip install stuff, and then it will run everything down here. As you can see, it's going, and it's already finished because all these operations are quite quick. Sometimes when it says, no, you may need to restart the kernel to use updated packages, I find this isn't always the case, but I do find it is sometimes the case. You could just do that by clicking this restart button, and you'll see it has restarting down there. And now when you run, say, this last one, it will give you an error saying SNS is not defined because of restarted the kernel, so all the memory has gone. It's not super clear about that because these numbers don't disappear, but there you go. The same thing happens when you click clear all outputs. So this will clear all the outputs. It will clear the numbers this time, but it will also restart the kernel. So now if we were to do this again, SNS is not defined, but all our libraries are still installed because they were installed to the virtual environment and not specifically to the kernel. You also have these variables up here, which if I run everything, that might have a slightly more useful output. Yeah, so you can see just your variables. I don't really use this too much, but this is actually quite a useful view. So you can actually see the data frame in one view. Oh, that is quite nice. Okay, I might have to use that more. And then you have this outline as well, which just brings another tab up here. And this is more for your markdown stuff. So if you had, multiple subheadings or like an actual document in here, then you can, jump to specific parts using this. And then you have this 3 dots here. So you have export, customize notebook layout, which just takes you to some settings, I guess. And then you have your breadcrumbs, which are, I'm not sure what those are actually. Oh, it's just this top bar up here. Okay, so that's all that controls. All right, fine. And you have toggle notebook line numbers as well. So you could put line numbers within your cells if you choose to. If you have any questions about what you've seen here or any ideas, if you've ever wanted to build an API and weren't sure how to go about doing that, then this video might just be for you. We'll be talking about FastAPI specifically, which is a library designed to make API creation easy and quick in Python. In fact, in this video, we'll be talking about how to create an API, how to do get, create, and post requests, and set up a DB all in 20 minutes. Of course, if you find this video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. With all that out of the way, let's create your first API. To be absolutely clear, the duration in the title of the video refers to the amount of time I spent programming, not the overall length of the video, before anyone gets smart in the comments. But to install FastAPI, all you need to do is do pip install FastAPI. And this will install FastAPI, also install Pydantic, which I made a video about before if you want to learn how that works. FastAPI is very heavily reliant on Pydantic, and while I want to keep this as much like just FastAPI as possible, so we don't get distracted by SQL alchemy, all that stuff, Pydantic is pretty vital, so we will be using that. And then we also need a way to run our API, and FastAPI doesn't provide a way to do that. And there are 2 things it recommends in the docs. The first one on the list was UVcorn, and then I actually do quotes here because I'm on ZSH, and then just standard will install the standard stuff. I already have everything installed, but you can see that FastAPI is actually built on Starlet, for those of you that have heard of that. And then we have Pydantic here as well. And I'm not actually sure what versions of of things we have. So Pydantic 2.6.3, we have FastAPI 0.110.0, and then we have UVcorn 0.27.1. For all those that are curious. So I'm going to create a directory over here just called app, and inside this directory we need to create an init.py file. This app can be called whatever you want. I'd recommend you name that the name of your app rather than just app. But for the purposes of a tutorial, we're just calling it app. This init can stay any, it just needs to be a package for everything to work. And then we create a file just called main.py. And this would be pretty much where all of our logic goes in terms of this video anyway. So to actually create an API, you just need to do from FastAPI import FastAPI app equals FastAPI. And then we're going to give it a title, so I'm going to call it just Carbra app, and you'll see what that does in a second. And then I'm going to give it a version as well. This defaults to 0.1.0. I'm going to do 1.0.0 just to be different. And then we can do app.get/. So this will be, a get request against our index. And then once someone does that, we can run this function, and that's going to return a dict of string. And then we're going to return a dictionary saying message hello world, and this is our API. We're done. I will be doing more advanced stuff, but I do want to show you that this works. So if I do UVcorn, what is it? Let me go in my history. There we go. App .main and then app reload. So this is the name of the module. So app is the name of the package, main is the name of the file, and then colon app is the name of the actual app itself. If you run that, we'll see that we get the server running on our localhost. If we click that, it should. There we go. And then I'm going to have to zoom very far in. There we go. 400%. That should be fine. Or maybe 500. There we go. We can always zoom out if we need to. See, we have message hello world, and we are just on 1.7.0.0.1 port 8000. And we have our thing here. If we go to raw data, then we can see that we have just a normal JSON object, which is cool. So we have an API that works. Now what to do with it? I'm going to create just a really simple fact API, and we're going to be doing some GET requests, some creates, and some deletes. We don't need to do an edit because Twitter lasted God knows how many years, almost 20 without an edit button. So quite frankly, we don't need one either. So first I want to model what a fact is going to look like. And for that, I'm going to come up to the top again and do from Pydantic import base. Oh God, not that. Base model. And we're going to create a class called fact. We're going to inherit from base model. And then it's going to have an ID, which is an integer, a body, which is a string. And then we're actually just going to leave it at that. And this is what each fact is going to look like. So it will return a JSON object with just an ID and a body. And then when we actually get it to use it within FastAPI, it will be a Pydantic model. So now is as good a time as any to create our database. So I'm going to come in here and I'm going to create a new file called schema.sql. We are just going to use raw SQL today. You can use SQL Alchemy if you prefer, but again, as I said at the start, I don't really want to pollute this with other technologies that people just have to learn. So yeah, we're doing it like this. So create table if not exists. We'll need to give it a name. There we go, facts. And then we are going to have an ID, which is an integer and a primary key. And in SQLite, if you have an integer primary key, it will auto increment on its own, which is pretty cool. And then we're going to have body text not null, which basically means that facts have to have a body in order to be inserted. And then we'll leave that for now. And what we're going to do now is we're going to create something called a dependency, which will fetch a database connection when we require it. And this will make a little bit more sense once we actually start doing creating and getting. But for now, if we just do get db as a function, and that takes nothing, and then it returns an iterator of connection, and I need to do from typing import iterator, there we go, and from SQLite 3 import connection, like that. And we can do with, oh, I need to import SQLite 3, don't I? With SQLite 3.connect. And we're just going to have db.sqlite3. And we do actually need to do check same thread equals false. This is recommended in the FastAPI documentation. Basically what this means is that you can have multiple open connections at once and they don't conflict with one another. In reality, you'd probably want to have some sort of additional checking to make sure that things aren't going wrong. But at that point, you probably want to use Postgres, and we're getting way off topic again. So we're just going to leave it like that for now. And we're going to call that connection. And then we're going to do connection.execute script. And then we're going to have a script path. So we're going to do from pathlib import path. And then we're going to define some constants up here. So we're going to have db path equals path db.sqlite3. Whoops. And then we're going to have script path equals path, and then app slash schema.sql. And this is basically just the path to our database and a path to our script. So I can actually replace this with db path now. db path. And then we just want to execute script path dot read text. Now in its current state, this will execute the script every single time. For an example's sake, I'm going to say I'm not worrying about that, but you know, if you were to do something with SQL Alchemy, you'd do something a different way. Maybe I'll do a video on that at some point. But for now, again, don't want to pollute it, so we're just doing it like that. We do want to do connection.rowFactory equals SQLite3.row. And this will, instead of returning a list of tuples, what it will do is it will return effectively a list of dictionaries. They don't, and it's not quite the same, but you access them in the same way. And that will be essential to what we're doing. And then we just want to do yield connection like that. So this is yielding the connection, and then once we're finished with the connection, it comes back into this function and it closes out this with statement here. And that's also why we're returning an iterator. This is how you would type hint anything to do with yielding. And this will be used to get our database whenever we need it. So now we can actually start creating things. So if I do app.post, and a post request is what creates things, I'm going to do /fact, and I'm going to set the status code equals 201. This is, generally the status code you would expect to see when you've successfully created something. And then we're going to set response model equals fact. And I'll show off what this is doing a little bit later, because this is doing something internally to help FastAPI. And we're going to do def create fact. And then we're going to take the body, which is a string. And this is treated as a request parameter. And then we're going to have DB, which is a connection. And then we're going to go up to the top actually and import something. So we're going to do from FastAPI import depends, like that. And then we do connection equals depends get DB. Then we return fact. And I'm just going to pause here for a second while I explain what's going on. So our body is our, request parameter. When we send a request, we will need to provide a body, and that will be of type string, obviously. Our DB is set to our SQLite connection, and this depends is essentially a class, or I think it's a function, but it's rendered as a class in terms of its naming structure, which is a bit odd. And then we pass the callable in here, and what that does is it basically runs that function, gets the DB connection from here, and then assigns that to DB. It's sort of a little bit of, I guess it's dependency injection, but it's a little bit of magic that goes on. And this is why we call getDB a dependency, because we use depends to then call this function to assign to DB. Now from here we can simply just do db.execute, insert into facts, and then we just want to insert into body values, and we use a prepared statement. I did a video a long time ago on the basics of SQL. I don't know how relevant that still is or how good that video is. I'll link it in the cards, and we'll see if it's still any good, because that was a very old video of mine. And then we're just going to return a fact. So we're going to return a Pydantic model, and then we're going to get execute, and then we're going to select the facts. So this is, I guess, optional, but I would say it was good practice. Order by ID, descending limits 1 dot fetch 1. There we go. If you're using something like SQL Alchemy, you'll probably avoid some race conditions, but this is basically just getting the last fact in the list, or the fact you just created, and then returning that back out to you. So if you then, it's already running. So if you come back over here, and if we go to /docs, this is really cool. You'll see that we actually get some cool little documentation. And from here, you can actually run things in the API. So we ran this and we got hello world back. If we create a fact, we click this try it out button here. We can put something in here. So Cabra started in 2019, which is an actual real fact. That's very true. Click execute. And we can see that we get our response body back. So we get a 201 code. We get ID equals 1, and then a body of a fact there. And if we go back over, we can see in the logs that, everything worked okay. But we don't have any way to actually get that fact yet. So we could do app.get /fact. So this would be now a get request to fact. And then we want to response model equals fact, like that. And if we do get fact ID, so again, this is another request parameter, and we do the same thing with our database. So I'm just going to copy and paste it, so we're not typing it all out again. And this will return a fact much in the same way. And then we run fact equals db.execute select star from facts where ID equals that. And that'd be fact ID. Don't forget the trailing comma. And we do a fetch 1. And we actually want to do some error validation here. So before we do that, we want to come up and we want to import HTTP exception from FastAPI. Come back down here, if not fact. So if the fact doesn't exist, it won't error, it will just return none. So we can use this. So if something is none, then we raise HTTP exception, the status of 404, saying that the fact's not found. And that's all you really need to do. And then beyond that, you just need to return fact and unpack fact into it like that. And now if we refresh this page, close that, we can see we have this get fact in there now. And if we were to get fact number 1, we can see that we get the fact back. If we do fact number 2, or fact number 21, error not found, detail fact not found, and we have our 404 here. So before we move on, something I've realized I've forgotten to do, but it actually still worked, which is really strange, was to do this. So we have /fact/ and then this represents the fact that there is a root parameter in here. So I guess at this point it's taken fact ID as a query parameter. If we wanted to do it as a root instead, then we pass fact ID into here. If we then do this, we can see that we have fact ID, and then the request actually looks slightly different. So if I were to do 1 there, we can see that it's now fact/1 instead of fact fact ID equals 1. So it depends what you want to do. If you don't provide roots in here, then these will be treated as query parameters. If you do provide roots in here, they'll be provided as root, and these names do need to match, otherwise it won't match up. So yeah, that was something I forgot to do, and it worked, and I wasn't expecting it to, but there you go. Final thing I want to do before we finish up is do some deleting. So we can do app.delete. It was fact/ and this is actually what prompted me, because my notes have fact ID in the get, but yeah, I just saw it in the delete and realized I hadn't done it. And we want a status code equals 204. So this will be the same thing. We use fact/ and then the number rather than a query parameter. And if we do def delete fact, we pass fact ID as int again, and then we do our database. Is it the same? Yes, that's still on the paste buffer. Awesome. And then we were going to return none out of this. And you can actually do something fancy with raw SQL here that you can't do in SQL Alchemy, as far as I know. And that is by performing the deletion and then retroactively raising an error if it didn't work. So if you do row count equals db.execute delete from facts where, whoopsie daisies, where ID equals that, and then we pass fact ID here, and then .row count. This row count is the number of rows that were inserted, updated, or deleted from the database in this query. So selects, it will always be 0. Actually, I think it's always none. I forget if it's 0 or none. But essentially what this will do is if a fact was deleted from the database, this will be 1. Otherwise, it will be 0. And then we think, oh, nothing was deleted. That fact couldn't have existed because it doesn't error on its own. So we can then do if not row count, raise HTTP exception 404 fact not found, and then retroactively say, from a user experience perspective, we do want to let them know that the ID didn't exist. So we can do that here. So if you then come back over, and then we have our red delete fact. If we then delete fact number 1, then we get a 204 back, which I believe is 204 no content. Yeah, because we don't need to send any content back because we've just deleted the content that we would potentially want to. If we run that again, we will get an error saying, fact not found, because it tried to. It didn't error. It just returned none. And so we can retroactively raise the fact. So yeah, that's all I wanted to show in this video. As a little bit of homework, see if you can work out how to list all the facts. And I'll give you a hint. It's very similar to getFact. It's actually even simpler than getFact. So see if you can list all the facts stored within the database. And if you really want to, you can add an edit as well. A little bit of a thing for that. It would be either app.put or app.patch, depending on what you wanted to do. This is part of the reason why I didn't really want to talk about it, because there are two different things for edit. But I'm going to leave that as homework for you. If people really want me to talk about it, I will make another video about it. But for now, I just wanted to keep things really simple so you sort of understood what was going on within FastAPI, how the status codes work, how the response models work. And yeah, this response model is actually responsible, if I go back here, for what have I done? I'm not sure what I've done here actually. Oh, there we go. I'll just click that. For rendering all of this. So in these examples here, you have your responses, and this is this. Let me know in the comments what you plan to build using. A few weeks ago, I made a video talking about Easter eggs in Python, and one of those was a From Done the Future Easter egg that talked about the idea that Python is never going to have braces in it. But it turns out that you can actually use Python with braces with a little help from an external library. A few years ago, someone made a project called Python, which is available on the Python package index, which allows you to use Python with braces and not having to worry about indentation. So in this video, we're going to be having a look at that and seeing if you can genuinely get rid of colons and indentations altogether. Of course, if you like the video at any point, then consider liking it to let me know, and maybe subscribing if you want to see more videos like this. If you're feeling particularly generous, you can become either a member or a patron using the links in the description below. With all that out of the way, out with indentation and in with braces. To get started with Python, first you need to install it, and thankfully that's pretty easy because you can just do it with pip. So you could do pip install Python, although actually using the correct command would be good. I already have it installed. You can see we're using version 0.8 today, and I imagine you probably will as well because this package hasn't been updated since 2018. So I feel like a lot of people have heard about this recently because I've heard it come up quite a few times. But this isn't a new thing. This hasn't been updated for about 6 years. So yeah, worth keeping that in mind. And to start using it, you need to create a file. You don't have to use the by extension if you don't want to, but that's just what's recommended in the docs. So that's what I'm doing. And I'm going to show you a really simple example, and then I'm going to go over a bit more of a complicated one and show you how to convert between the two. So I'll go to the example in their README for this. So we have a print message, and you'll see kind of immediately that there's a bit of a problem with this in that you can't have like code linting on while you're doing this, because of course if you use Python, it's going to complain about you using curly brackets instead of, well, colons and indentations and stuff. So that's one thing you're going to have to get used to. Thankfully on VS Code, at least, if you have plain text, if I just do this, if you do curly brackets like that, it will actually automatically indent for you, which does put into question how useful Python actually is if you are using an editor. But you know, we can skip aside that for now, and then we do for I in range num of times, and you do get a little bit of autocomplete. You get like Sublime style autocomplete. Python is awesome, like that. And then we could do the semicolon. You don't have to, but it's just a little bit of flair. So if name equals main, and do the, I almost did a colon there, print message, and then 10, and then like that. This is our really simple program. In order to run it, we could just do Python and then the name of the file, so script.py, and you'll see it runs. So what it does is it transpiles the Python code into Python code, and then runs that Python code in the Python interpreter. And if you want to see what the code is that it's made, you could do Python-C and then script.py. And this will simply compile the code rather than run it. You could open script.py and you can see what it's done. So by default, there's a lot of white space around. I think the way it like gets rid of it like just, you know, clears these lines out and replaces this with colons, and then it actually gets rid of semicolons weirdly, even though they use semicolons in the thing. But yeah, you can see there's not a huge amount of changes that have taken place. It's mainly just pretty much find and replace, to be completely honest. And we'll see examples of the implementation of this not exactly being the most complex a little bit later, but I do want to go over a few other things first. So we have Python-H, and then we can see the full thing. So we can keep the generated Python files. I believe what that does is if I do this, it will run it, and then it will output the file. Yeah, there you go. So it's basically compile and run, which is kind of a nice thing to have. And then you got compile there. You got some other like verbose things. Lower true, what's that? Add support for lowercase Oh, true for, oh, so you can add support for lowercase true and false. Okay, that's cool. I didn't know you could do that until this. And then you could also run it with Python 2 if you want by using -2 or /Python 2. And if you're compiling and you don't want your file to be called, you know, the file name.py, you can also supply a -o to compile it too. So if you want to give it a custom name, you can do that as well. So that's all the basics of Python. I have made a little guessing game using it. So you can see I've gone kind of a little bit full or a little bit extra, I guess. I don't know what you want to call it, but I've done kind of everything. So I've done the semicolons, I've done the brackets, and I've done using brackets around if statements or while statements and all that. Actually, I could probably do while true there, but I didn't know it was a thing. And this is just like a really simple game. So you guess a number between 1 and 10 with 3 tries, and it uses various while loops and conditionals and while else's and stuff like that to do it. And if you run this, it works. Nope, Python. It works fine, or it doesn't. Of course it doesn't. Why doesn't that work? Okay, so this is one of the problems I was having earlier. I thought I'd fixed it, but I guess not. So the issue we're getting is an indentation error expected, an indentation block after the else statement on line 32, which is this here. If we look at the compiled code, we can see that it hasn't compiled this properly at all. And I'm not entirely sure why it hasn't properly compiled it. I think it's something to do with this in here. Although actually no, it's clearly in the indentations, but I think that's something to do with it. So what I was doing before, I did try and do something like this to see how competent it was, and I did something like this as well to see if it could handle this, because I didn't know how it was implemented. If you run that now, then we'll get the same thing. If I comment, can I comment it out for a second? No. Plain text, the comment thing doesn't work. Okay, fine. But yeah, if we do this like this, I can probably compile it and you'll see. We can see that it just, completely breaks. So it is very much a not a try, except, what am I calling it? Find replace job, where it just replaces open parenthesis or open curly brackets with colons. And you can actually see that's what it's done here in the string as well. And then it replaces or just like removes the closing brackets completely. The problem is it doesn't seem to be very smart about how it does this. So the way I managed to get it to work before is by doing that. And then, well, obviously you doing this, and that just kind of worked previously. So if I do, the thing is I can't even do this string dot format. If I get rid of this, and then if I do and then close that, and then brackets number like that, that should be a bit better. Oh, hang on, I've got to close the thing, that would probably help. That should be a bit better. It should be able to handle that part. Oh, and it looks as though it's actually going to be run fine now. If I do that, there we go, it runs fine now. I think it was this string formatting thing. Yeah, so F strings are off the table. I did manage to get it to work once with F strings. It was working previously. I don't know why it's not anymore. Before on a game, oh, I won. That was simple. Yes, I do want to try again. Too low, too high. Yay, I won again. And then if we do like hello, we can see that it's an invalid guess. Okay, I'm gonna like not win one. Actively trying not to win. There we go. So no more guesses. The number is 3 if you do it again. So it all works fine. It's all able to run okay. Obviously the exact code isn't formatted. It doesn't get rid of, like, it's not really like a C style thing. It is more just brackets. You did get a lot of white space because of that. But you can see that you do have to take care when moving things from Python to Python. I wonder now I've fixed that, will this work? I want to do it one more time. Oh, it does! I think it actually is going to work now. Okay, there you go. So you can do slightly more advanced things, provided that your F-string expressions aren't breaking everything. So yeah, you are limited to this, which is a bit unfortunate. but you know, it is what it is, I suppose. I also have not tried it with a dictionary. Let's see how it handles this. It might not actually handle it at all. 1 and then 2, something like that. Just a really simple one. And it breaks. It can't do dictionaries. Oh, that's really unfortunate, actually. I suppose you can do dictionaries because you can do dict 1 equals 1, 2 equals 2, and then that'll work fine. But then you have to do a function call, and it's not really readable. Wow, yeah, I didn't even try and test it. Yeah, that's not good, is it? I did not even try and do that before this. And, yeah, that's an interesting one you have to keep in mind. So you can't use f-strings. You can't use dictionaries in their raw form. But at the very least, you don't have to worry about indentation. And yeah, just to prove, I've done this here. I've unindented this here. If you run it, it compiles and it's indented over. Woo! So the other thing I wanted to show you in this video was converting from a Python file to a Python file, because that's also possible. So I have this conversion.py, which is exactly the same thing. I just wanted to name it distinctly. So it was kind of obvious what was going on the sidebar. But if you use py2by, and this is also available when you pip install Python, so it exposes 2 separate commands. And then I don't know if I loaded the help for this. Okay, there's not much you can do. You can kind of input something and that's about it. So if we do py2by and then conversion.py, we will then get this conversion.by file out. And you can see it's more or less done what we wanted it to do. So you can see, yeah, the brackets around if statements or while statements are optional. The semicolons are optional. I guess it just treats them the same. Actually, no, it doesn't treat them the same even, because it gets rid of them when you translate from Python to Python. But yeah, Python can handle semicolons just fine, so I suppose it doesn't really bother. But it just puts stuff within curly brackets. It doesn't kind of make use of more advanced syntaxes, which is sort of annoying. But I suppose it does it based on the white space within the file rather than anything else. Again, probably another find and replace job. To be honest, I haven't actually looked at the source code, so I might be not giving the author enough credit. But yeah, that does seem like that's what it is to me. Let me know in the comments what you think of this. I think it's probably a little bit too limited to really use, though I don't think it's really intended to be used in production. I think it's just a bit of fun. You know, I've sort of been ripping it apart a bit, but I don't think it's a serious attempt to actually change the dynamics of Python. I think it's just a fun little experiment and a fun little cool thing to say, hey, I can use Python with braces, which is cool in another sense. But yeah, it has its issues for sure. I'd like to say a huge thank you to my amazing patrons and members on screen now. For those looking to have some sort of persistent cache within that application, Redis is often the first place people look. It's incredibly easy to use, it's considered the fastest caching implementation out there, and it has SDKs in a lot of languages, including Python. It's particularly useful for those that just want a simple key value caching system without having to do something fancy with the database, as well as those looking to have a persistent cache. Unlike just simple in-memory caches, as while Redis does work in memory, it dumps its cache out onto the disk when it's done. And this means that the cache state persists between startups of your program. Then there have been some dramas surrounding changes in the way that Redis is licensed. I'll talk about that a little more once we get into it, but there are ways around that. And I do show those off in the video as well for those that are concerned about that. Of course, if you like the video, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. If you're feeling particularly generous, you can become a member or a patron by using the links in the description below. With all that out of the way, let's get caching. As I alluded to in the intro, there is currently some dramas going on with Redis and its dual licensing. I'm not going to go into a huge amount of details about that because that's not what this video is about. But for those that are affected or don't particularly like the new changes with the licensing, there is an open source fork called Redict, which is what we're actually going to be using in this video. I just wanted to use it to show how that could be used, but also to appease probably a lot of people in the comments that would leave comments about Redis if I didn't do it this way. The installation is pretty much exactly the same, at least if you do it through Docker, which we will be in this video. But the usage of it is completely identical. So just to let you know, that's what I'm going to be doing. But this will be perfectly fine for those that just want to use Redis as well. But yeah, to get started, all you need to do is, well, to use Docker, you would use docker pull. And then if you wanted to pull down Redis, you would just do Redis like that. If you wanted to pull down Redict, you would use registry.redict.io/Redict, like that. I already have it, so I'm not going to be pulling it down, but you would do either way. If you want to install it locally, I'll leave you to find the instructions yourself, because there are many different ways depending on the operating system that you use, and Redis and Redict I think have slightly different ways of doing things. So I'm not going to be talking about that here, but I would recommend using Docker anyway, just because it works everywhere. The database itself is stored in a Docker volume, which just seems a little bit cleaner to me. It's better for deployments, and it's just better for a few different reasons. But if you don't have Docker, or if you don't want Docker, you can install this locally and it works pretty much the same way. To actually run it on Docker, you would just do docker run --rm --cache, or sorry, --name Redict or Redis cache. I mean, that's just my name. You can name it whatever you want. We need to expose port 6379 because this is the port that Redis uses. And then we need to provide the name of the image, which will be exactly the same argument you provided to pull. So if you did Redis like that, you would do that. If you specifically got the Alpine version, for security reasons, you do that. If you're doing Redict, you would do registry.redict.io/Redict. If you want to use an Alpine version of Redict, that's also available. Should point that out. But if you run that, we can see that am I already using this? All fixed. Yeah, that was my bad. I'm doing this part of the video again. So I've actually done the rest of it, but I left the previous image running because I'm an idiot. So if we just run that, we'll see that we get this nice display. We'll see we have Redict is starting. It will give you the version, a few little things, tell you about the configuration files, which we don't have at the moment, but I'll talk about that later. And this is pretty much all the logs it will give you. I think the only other logs it will do is errors, unless you can activate some sort of verbose mode. I'm actually not sure. I will quickly, before we move on, I will show you how to start it if you haven't done it over Docker. So we can do Redis. I don't have Redict, but I do have Redis installed locally. If you do Redis-server, then we get this nice little thing here. And then if we quit that, then we can see that we have this dump.rdb, and this is the persistent file storage. So whenever Redis or Redict shuts down, it will dump this file out into whatever directory. If you're doing it in Docker, it will dump it in the Docker volume, so you won't see it. But that will be where everything goes. And then when you load it back up, it will load that file, and then you'll be good to go. So we can go back to our terminal, and we can install the Python package that's going to help us with this. And to do that, we can just do pip install Redis. Like this. I already have it. As you can see, I have version 5.0.1. Is there an upgrade? There is. There we go, 5.0.3. Then we could do from Redis, import Redis, like that. And this Redis object is our client. So to create a client, once I've done the run guard, we can simply just do Redis equals Redis like that. And my Codium extension is giving us spoilers there. But this will create the client. You don't actually need it to do particularly anything out of the box. There are a number of options. See if I can get the tooltip up. Yeah, so you can set all these options as you want. You can change the port if you didn't want to use 6379 for whatever reason. I'm not going to deal with any of this because I just want to do some of the more simple stuff. But yeah, that's the basic idea. And you might actually, what I've done in my plan and what I think I'm going to do here is call this cache. And this means that you could do is when you're setting the cache, you do cache.set, and that's a little bit more explicit about what you want to do. But this is how you would set something in the cache in Redis. So you would have cache.set, and you'd set the key, so hello, and then the value, world. So you don't pass a dictionary or anything, you just pass the key as one argument and the value as another. If we then print cache.get, which is how we get something out of the cache, hello, like this, we can see that it returns out. And you'll notice that it returns out in bytes. And this is because the Redis cache always works in bytes. Even if you pass in a string, it will convert it to bytes for you. And the keys are also in bytes too, so that's worth keeping in mind. It is also possible to create caches using integers. So if you want to do cache set 5 alive like this, and then we can print cache.get5. And I will actually show you real quick that our cache is preserved. So you can see we're printing it before we're setting it. So world is already there. And then we have, we set the five alive, we get a typing error. I think it doesn't really like it. I think, yeah, if you want to use like static typing, then you might want to do it as a byte string instead. I think it converts this to a byte string, but you see the idea. You get, cache got to get 5, and then the alive is down there, so it's all worked. To delete something out of the cache, all you would need to do is cache.delete hello, like that. And if we print, here we go. And we can see that the key has been deleted, the value has been deleted as well. And when we get it, we don't get an error, we just get none. So if you ever get none out of a get, that means that it doesn't exist in the cache. By default, Redis creates cache keys and values permanently, so it won't actually set a timeout for them. If you do want to set a timeout for them, then what you need to do is use cache.expire. And then you provide a key. So I guess if we get rid of this, so we actually, we'll get rid of this, we'll get rid of all this. Just, it's a bit easier to read. And then if we set our, move this around as well, our hello key to expire in 10 seconds like that. So this is always done in seconds. So if you want it to expire for 10 seconds, we can do that. If we then print, we know it's already there. If we do like import time, just to kind of show this off, and then we do a time.sleep, say for 11 seconds, just to make sure it is actually deleted. I realize now I probably shouldn't have done 10 seconds, but we'll see that the key will have expired by the time it gets there, because it's been 10 seconds since. And you can see we get none back here showing that the key is no longer there. You can call expire on a key as many times as you like, and it will update it. So if we called it again after 5 seconds, for example, with a 30-second timeout, then that would override the previous one. So the previous one would be deleted, and it would now get a brand new 30-second timer on that. So you can update them as in when you please. You can also, if you want to get rid of the expiration timer and just keep it, you can use persist, and this will delete the expire, and it will revert the key to the the normal default behavior where it stays around forever. Now, because Redis stores all of its cache entries as bytes, it is possible to store pretty much whatever you want in there. You can put an image in a Redis cache, you can put a music file in a Redis cache, you can put an entire program, you could put the script, you could put Redis in the Redis cache if you really wanted to. But this does also mean that you can put pickled objects in the cache. And I will prefix this with an asterisk that you might instead want to do marshalling instead. I might do a video on marshalling at some point. But just to kind of prove a point, we could do from data classes import data class, and then we can do at data class here. And then if we do class profile, we do the one I always do, which is name equals string. Is it gonna age equals int? It's probably not gonna get the rest of it. No, I don't think it is. Is it? No. Wasn't sure whether it remembered the script before. It's a brand new extension. It's basically free ChatGPT. Interesting. I'm trying it out. So if we do profile equals profile, how many tangents can I go on before I finish this example? Sure, that'll work. And then cache.set. Oh, I also need to import pickle in here as well. Cache.set, and then my name, why not? And then use pickle.dumps profile. So if you're not familiar with what pickle is, that will create essentially just a byte string. We can print it out for people that aren't sure what it is. It creates just a byte string of the object, and you can then load it later on. And actually we can do if value cache.get and then print pickle.loads value. So what this is doing now is checking if the cache entry exists, and if it does, then we load it back in using pickle. For whatever reason, this will always give a typing error, because I think Redis has synchronous and asynchronous APIs, and as far as I could tell, there is no way around that. at all, which is really annoying. So if you are doing a type project, like I have it on at the moment, we have to do type ignore arg-type like that. But if you then, oh actually, if I get rid of this, get rid of that, Pydantic, we can see this is what pickle has done to the object. So it just stores it as a series of byte strings. This /x and then the two digits after are a single byte as represented in Python byte strings. So there are some here, and then you get this Z. This is just, you know, happens to be the byte that, you know, maps to Z in ASCII. Yeah, this is the object as bytes, and you can see that we've loaded it back out of the cache and turned it into a data class like it was previously. So that's everything I wanted to talk about with the SDK. I am aware I have been yabbering on a bit, so I'll be quick with the config stuff, but I did want to show you some you know, quick config things. If you're using Redis, you would do redis.conf. If you're using Redict, you do redict.conf as your file, and this just exists, you know, wherever. You can specify it specifically. But yeah, I'm only going to talk about a few config options, some of the kind of the main ones I think would be particularly useful. So you remember at the start of the video where we had that dump.rdb file after I ran Redis server, you can actually change that file name if you want to. So you can set db file name and then we'll say cache.rdb. And now it will save it as cache.rdb. If you want to save it in a particular directory, you can specify the dir and then we'll do /redict, I guess. And now it will save it in redict/cache.rdb. So if you want to change the behavior behind the file names, then this is how you can go about doing that. The next two I want to show you concern memory. So you can change, I don't actually know what the defaults for these are. I might have looked it up at the time, but I've forgotten. So we could do max memory as 1024 megabytes. And this will mean that Redis or Redict will only be allowed to use 1 gigabyte of RAM. I think by default it uses far less than that, so that will probably serve you quite well. And then you can set a policy for when the memory runs out. So keys will start getting evicted once the memory has, or once the memory limit has been exceeded. But there are different ways of doing it. One particular way is all keys -LRU, which essentially turns Redis into an LRU cache. So the most used keys will stick around and the least used keys will be, you know, evicted. If you're unsure, LRU stands for least recently used. So the least recently used key will be the one that's evicted first. The final config option I want to show you is the timeout option. And if we set this to 300, for example, this will mean that Redis or Redict will shut down after 5 minutes of inactivity. So if you did want to, you know, create a cache that did shut down on its own for whatever reason, then you could supply this timeout. It is not like a different way of setting the expiration for the keys. I did look into that and I don't think that actually exists by default, which is really strange. So you might, if you did want to do that, create like a wrapper function around set, or maybe, you know, you could do, you could subclass the Redis and have it so it also calls expire when it calls set as well, if you wanted to do something like that. But yeah, that's that's getting into more advanced stuff, I think. Let me know in the comments how you plan to use Redis. I really want to know. I recently spent some time researching what sort of biometric support Python had. So, you know, sort of things like fingerprints, you know, sensors and whatever. And I found some stuff I was looking for, but not quite everything. So there is Touch ID support. There is passkey support, which I'll probably talk about another time, but there wasn't anything like Windows Hello support, and various other fingerprint sensors had various different libraries that only catered for certain things. So the world of Python biometrics is a bit weird at the moment. So this video is going to focus quite heavily on the Touch ID side of things because that's what I was able to find. But I do spend some time at the end talking about a potential implementation for Windows Hello fingerprint style stuff using something called PythonNet. So if you're interested in that stuff, then potentially stick around to the end. Of course, if you find this video helpful at any point, then consider liking it to let me know, and maybe subscribing if you want to see more videos like this. If you're feeling particularly generous, you can become either a member or a patron using the links in the description below. With all that out of the way, let's put this to use. So to install the library on our system, all we need to do is pip install, and then we need to install it from a GitHub repository because it's not on the Python package index at the moment. So we could do git plus https //github.com/parafoxia /python-touch-id. The most eagle-eyed among you will notice that this is actually my GitHub profile. This is not my project. I do want to stress that. I simply forked it and made a few updates to it. The original version hadn't been updated in 7 years. Amazingly enough, it still worked perfectly. So I just changed a few calls and optimized a few things, added typing to it and stuff like that. But the original project is no longer on the Python package index, and I don't want to put it back up without asking if it's okay first. I could probably do it fine, but in good faith, I don't want to do that because he took it down for a reason. So yeah, but we can install that, and that will install from the GitHub repository. And then we will install also some PyObjective-C stuff, because that's what this is built on. And I will show the implementation in a bit. But basically, PyObjective-C is a bridge between Python and Objective-C. So it's not even really a wrapper. It is just a bridge for it. I imagine that's all handled in here. And then you have these different frameworks that just wrap the different things. And Objective-C is an Apple technology. So that's how this has been gotten to work. And that's also why this is kind of a macOS/iOS. Well, actually, not anymore. Yeah, like any Apple computer with a fingerprint sensor will work with this. Pretty much is what I'm saying. So to actually use it, we just need to do import touch ID like that. And if we do if name equals main, we can print touch ID dot is available, and this will tell us if the touch ID system is available on our computer. And if we do a script like that, we can see that it is, because I'm running this on a MacBook. Once we've done that, we can simply do touchid.authenticate. And we run that, and we'll see it's quite small, so I have to zoom it in, but it is actually asking us for authentication with our touch ID. And if I were to do that, it works. So the true indicates that the authentication was successful and that everything was fully authenticated just fine. And that pretty much covers the entire public API for this package. The only other thing you can do is that you can actually change the reason for it. So we can set reason here, and then we can do for the memes. And if we run the script again, we'll see that Python 3.12 is trying to for the memes, because I've done that well. So yeah, it appends it after is trying to. So the reason will go here. If we then cancel it as well, we'll get an error saying the authentication was cancelled. So if we head over to a Firefox window, this is the fork that I've done. So as you can see, I've made it typed, and this is the entire code for it. So I would be lying if I said I understood what everything in this did. I might actually bring up the blame just so you can see how much I actually, well, actually I changed quite a bit in terms of styling and stuff. I won't do that. But we have our local authentication stuff. So this is all from the PyObjective-C framework. And then we create a DLL of none, which I tried to look up what that did. There were answers. I don't understand them. If someone understands what the hell this does, then do let me know. I did actually have to change this because there are two ways to do this, and one of them throws a typing error, so that's fun. It does all this semaphore stuff. This is necessary, otherwise Objective-C will have an absolute fit. We then have some stuff for typing here. We have our is available, which just evaluates the policy. Our authentication, we check if it's available first. We create a new context, a new semaphore, and we have this callback. So this evaluate policy, localize reason reply, takes our KTouch ID policy, which is essentially, our touch ID thing. And the evaluate policy runs our touch ID stuff, I guess. And then we pass in a reason, and this is just a string. And then we pass in a callback, which is this, which takes a success and an error. So this will be either true or false, and then the error will be, an error. I couldn't figure out the exact type, but the only thing we need on the error is a localized description, so I just created a protocol for that. Hooray for typing. So we create a result here with our success and our error. And the reason we can't just error straight away is because we need to dispatch this semaphore, and then we need to wait for it. Otherwise, you'll get the equivalent. Well, I was going to say the equivalent of a kernel panic. That's not true. You'll get an unhandled error from Objective-C directly, and it's really unclean. So we just wait for the semaphore to be dispatched, and then if there was an error, we raise the error at this point. So there's actually not an awful lot of code to it, really, surprisingly enough. It is just a bit weird to understand, and the person who wrote this knows an awful lot about this stuff, or an awful lot more about this stuff than I do. But the main reason I actually wanted to fork it, I mean, all this stuff about the typing and stuff was just niceties. The main reason I wanted to fork it was this setup.py file. So previously the install required just PyObjective-C, and there are a lot of frameworks for this. So if I do PyPI and do PyObjective, oh my god, let's actually be able to type. I'll zoom in a wee second. There we go. We can see is we have the core, and then we have these frameworks, and you can see just how many frameworks there are. And if you pip install PyObjective-C, you install all of them. And I do mean all 153, 154 of them. There's a lot. So changing it to just, require the local authentication framework, installs the core, it installs all of its dependencies. Everything is like properly dependency mapped, but it reduces the number of dependencies to 4 instead of 154, which is the main reason I wanted to do this. The other reason I wanted to do this as well is because this code works fine. If I go into the commits, you'll see that the last commit that wasn't me, can I just go into the commit history, please? Was 7 years ago. It hasn't been updated in 7 years, and it still works. And it was archived on that as well. So I just wanted to show that it still worked, and it was really cool. My original plan for this video was to have a Windows Hello in here as well for Windows computers. Apparently that doesn't exist. No one has made a Python package for Windows Hello fingerprint sensors yet. The closest I can find is just various different libraries for like fingerprint sensors. There's this one, Finger Reader, that has been tested on like the R3OX. There's this one that's been tested on Pydantic ZFM sensors. There's all these different ones, and there's another one for, I forget what the bloody company's called now. But there's a company that makes them. Let me see if I can actually find it. This Adafruit one. So there's this Adafruit one that's sold and you can buy, and there is actually a PyPI package to be able to link into this thing, which is kind of cool. I'm not sure if you can like just put this into any computer or whether or not it's it's like a Raspberry Pi thing, but you can do that. But I could not find any way to do it just in pure Python. What I did find was that the Windows Hello API is a thing. So there is a Windows Hello API, and it sucks as far as I can tell. It looks, I mean, this is all just nonsense, really. There's like an awful lot of stuff. I don't know, like, yeah. I don't know, maybe this one. I hadn't actually looked at this one. Oh, this one looks as though it'd actually be a bit... Oh, this one looks more useful, actually. But this is a C# API, which, of course, Python doesn't support until you install Python.Net, which is a C#, or, well, specifically a .NET and a mono... it's not a wrapper. Is it a wrapper? I don't know. It just kind of installs the entire .NET system into Python, and then you can start importing stuff from here. So I think the cleanest option to be able to import or implement something for Windows Hello, is to do it. Is to work out what calls you need, and then do it in Python.Net, and then that will probably be fine. I think. I am planning on trying to do this. I can't guarantee I'm going to have the time to do it because I do have a full-time job and everything. But I do want to see if I can get this to work, even though I have literally just binned off Windows. I have a MacBook and a Linux computer, and that's pretty much all I use now. So the perfect time to build a Windows Hello system. Let me know in the comments if you plan to use this in your own project, and if so. OAuth 2 is the de facto standard for web authorization, and while there are plenty of libraries in Python that can do it for you, sometimes it's better to know something from scratch. especially when it comes to your online security. So in this video, we are going to be going over the full OAuth 2 workflow, and then we're going to be implementing it in Python from scratch using the request library. So we're going to be authorizing to request an access token. We're going to be checking that access token's validity, and we're going to be refreshing that access token. And once all that's done, we are going to be optimizing the workflow to make our solution even smarter. Of course, if you found the video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. And if you want to see them earlier than anyone else, then consider becoming a member or a patron by using the links in the description below. But with all that out of the way, let's go over how OAuth 2 authorization works. So before we get into the meat of the code, I'm going to create a little diagram to help kind of explain what the OAuth 2 process is and what we need to map into code. I've already got the AI prompt set up, and hopefully it will generate the right thing, and then we can just edit it as necessary. Just a bit easier than typing it all out. Yeah, so we start with, and let me just wait until it's all done and I can zoom in to it. Okay, there we go. So if I just zoom in, there we go. So in our OAuth 2 flow, we have 4 entities. We have our user, we have our client, we have our authorization server, and we have our resource server. So the resource server is just the normal server. Once you're authorized, you can access it and get resource back down. Authorization servers sit in the middle. They are the things that handle the authorization. The client is just your application, and the user is you. So first you access the application, and then the client redirects to the authorization server. It then asks you to authenticate yourself. You provide authentication credentials, such as a username or password or something. And then it will request authorization, and then you can grant authorization. So this is just saying, do you want to actually allow this service to use your data, basically. And then once you say yes, the authorization server will give an authorization code. Now you can have it send the code to the user. You might have seen that before, and then the user passes it in. We're not going to be doing that here. We're going to be doing as the diagram suggests, and we're going to be using something called loopback IP addressing, or at least that's how Google calls it, sending the authorization code to the client, which will then request the access token using it, and then it gets the access token and refresh token back. And then you can use these tokens to then request access to protected resources. So that's the general flow of how everything works. If we go into our window, we can see that I already have a secrets.json file. And this is an actual Google project of mine that I'm going to have to invalidate once I'm done here, but that's fine. Your secrets might look slightly different because there's no standard as to how secrets are provided, though you do need at least the client ID, the client secret, the redirect URLs, and then you might have an authorization token URI in here, or it might be given to you in some other way. But you need the client ID, the auth URI, the token URI, the client secrets, and the redirect URI in full. These 2 things here are just Google stuff and they're not actually important for us. So if we go into our script, we need to import actually quite a few things, and I'm going to import everything at once. So we need to import #lib. Oh God, I've already screwed that up. We need to import JSON. We need to import OS. We need to import web browser. We need to from http.server import base HTTP request handler and HTTP server. We need to from pathlib import path, and we need to do from URL lib.parse import parse QSL, and then URL in code. And then we also need to go into here. We need to do pip install requests. If you don't have it already, we're just going to be using requests for this. You can use AO, HTTP, or whatever if you like. We're using requests, and then we need to import that as well. So that's a lot of things to import straight off the bat. We'll talk about how we use each as we go through it. But that just saves me having to scroll up to the top and kind of scrolling manically around the place. So we're going to start by defining a series of scopes that we want to authorize with. I'm going to be using Google scopes because Google is what I know. And I did try and find something that would have let me do this without any accounts or whatever. The OAuth 2 playground is the closest I got. I'd recommend that if you do want to learn more, but you can't go through the full workflow programmatically with it, which is really annoying. So we'll start with Google. So I'm actually going to copy these in for my notes. So in this case, we have scopes. So basically, YouTube Analytics read-only and YouTube Analytics monitoring.read-only. They don't have to be URLs. Google just tends to make them URLs. You can put as many scopes or as few scopes as you like in here, but these will be dependent on the API you're connecting to. And we want to set a host, which in this case is going to be localhost. And this will be important later. And we're going to do a port 8080, and that will also be important later. And we are going to now do our run guard if name double equals main. And then we're going to load our secrets in using json.loads, and it might actually do the rest. There we go. So we're loading our secrets.json file. We're reading the text and loading into JSON. I am then going to get the secrets out because you'll see it's nested inside this installed thing, and we don't want that. So we're just going to get it out of there. And then we're going to do our tokens equals authorize, which is a method we're going to, or a function, sorry, we're going to create. We're going to pass the secrets in, and then we're going to print the tokens out to the terminal. So coming up here, we create our authorize function. I can't talk. I've just done a full day of work and my brain is apparently mush. So this is going to go really well. And we're going to have secrets, and this is going to be a dict of string to string. And then this is going to return a dict string to string, which is our tokens. And then we want to set the redirect URI manually to be, in this case, the redirect URI in our secrets file, the first one, because Google provides multiple. And then we also want to stick a port on the end of it. And this is important. You don't have to do this if it's actually hosted online. So if you're hosting it on a website, you can use port 80 and that would be the default. We can't use that with localhost, so we're actually having to specify a port. And I'm going to get my Python to shut up for a second. Yeah, Google has multiple redirect URIs in its secrets, so you might just need to do secrets, redirect URI. And then we're going to provide a series of parameters that we want to pass as query parameters. And we're going to do this as a dict. So we can do params, and then response type is code. So this code is our authorization code that we're getting back. And this will let us get the token. We also need to provide the client ID, which could just be secrets client ID. We also need to provide the redirect URI, which we can just set as redirect URI. We need to provide the scopes, which in Google's case is space separated. I've seen them plus separated as well. So you may need to check your specific API to work out whether you need to put a plus or a space here. But you could just join all the scopes in like this and it'll be fine. We also want to provide a state token. And this is going to be hashlib.sha256 os.u. It had it for a second, and I think urandom 1024.hexdigest. So this state can be anything you want. It doesn't have to be this. I'm just using this because this is how Google did it in their documentation. But this state will allow us to prevent something called cross-site request forgery attacks. And that's where someone can intercept a request in the middle and then send a request back that looks legit, but actually isn't. So we can pass this state up, and then if this state matches, then we know that it's come from the same place. And then for Google exclusively, we need to do access type offline. You don't need to do that normally. Google requires it, I think anyway. It doesn't require it, but it's a setting that you sort of have to do, sort of. I don't know, I don't fully understand that bit. But it's not important anyway. So we can build our URL using this. So we could do secrets, our authorization URI. If it's not in a secrets file, you can define it as a constant up the top, and that's fine as well. And then we want to use our URL in code params. And what this URL encode does is it turns a dictionary of parameters into a query string. It misses out the question mark at the start, which is why we do this. But yeah, this basically allows you to build a full URL. And then we want to use the web browser library to open the URL. So we could do if not web browser dot open URL like that, and then raise runtime error. And this will happen if the web browser failed to load. So if we couldn't open it for whatever reason, then you'll get this error. If you're following on with WSL, this won't work. You'll either need to print the thing into the terminal, or you'll need to install WSLU and go through those instructions, but I'm not talking about that right now. But you'll need to do that. So after that, we need to create a HTTP server that will run locally to listen out for a request that comes back. And to do that, we do server equals server, which we're going to create. And then we're going to pass host and port in. And then we're going to try server.handle requests. And then we're going to finally server.server close. You can put error handling in here if you want. Like so for keyboard interrupts, you can have it exit a bit more gracefully, but we're not going to do that here. So to go at the top, to actually define our server, we first need to define a request handler. And this will inherit from base HTTP request handler. Then we need to define this do get, and that is actually pretty much what we want. Yeah, okay. Yeah, we'll just leave it as hello world. Before that, though, we do actually need to provide self-server, and that'll be server and then self.server.query params equals dict parse, and then we need to do .split. I'm doing this all, and I'll explain it all in one go because that's the only way it's going to make sense, and then do like that. So what we're doing here is we're handling our get requests. And yes, it does have to be this, which is really annoying because it's not PEP8 or whatever. So we send a response 200. We then send a header to say that we want to pass a HTML document through. We then end the headers. We then provide a server instance so we can set the query parameters on the server. So we actually have something to reference back to on the other side. And then we simply just write some HTML in here, and this might actually, I'll do a H1 in here just to show that it's HTML, and we'll set this to authorized so it's a bit clearer what's going on. So this will be written out to the page. To actually define our server, we need to do this, and then we need to inherit from HTTP server. We then need to initialize it with a host and a port. That's fine, and that will return none, like that. And then we want to do that. Yeah, so we want to pass the host and the port through as a tuple. And then we want to pass our request handler class through. And this will be used to handle the request. I believe if you don't pass this through, it will use the base one. And then we want to define query params to be dict of string to string, which is going to equal an empty dictionary for now. And then we just want to, actually, we don't need to do anything else. So this is all our server's doing. All our logic is really in our request handler up here. And we're using parse QSL instead of parse QS. So parse QS returns a dict of the query parameter and a list of its values, which we don't want. And it's just easier to create a dict out of QSL, which returns a list of tuples instead. So if we come back down here, we've already done this code down here. So that's fine. That is our web server sorted. From there, I'm just finding where I am in my notes. There we go. So from there, we can assume at this point that we have our query parameters back. So we first need to check if our state that we created in our params is not equal to server.queryParam state. And if that's not the case, then we need to raise a runtime error, say invalid state, because if these two don't equal each other, there has been cross-site request forgery happening. If they do equal each other, then you can trust the response. So that's why we want to check that. The other thing we get back is the code. So we can do server.queryParameters code. And this is why we define query parameters on the server. And this is why we wrote the query parameters directly to this attribute so we could get it back. So now we need to fetch the access token. And yes, this is a lot of steps. It's security for you. So we need to set the grant type equal to authorization code, and this will tell the endpoint to send back our authorization code here. So we're now on this section here. We're requesting the access token and then getting it back. So we want our client ID again. We also now want our client secret. We also want our redirect URI, and we want to pass the code through. And then we can do with request.post, and it is a post. Secrets token URI, data params, that's all fine. As response, if response, oh my god, okay. I think that's fine. Actually, we can just return, that directly. So what we're doing here is we are loading our token URI through. So this is different from our authorization URI. We send the data through as params, so here, and we're sending that through as an xwww form URL encoded thing. I don't know if you can send it through as JSON or not. I don't know if you'd really want to either, because well, yeah, it says encoded. I think it's probably just URL encoded rather than anything. But this is how I've always done it. So you could try with JSON if you want. We can then make sure that the response is 200, and if it isn't, then we just raise. You can probably raise something better than a runtime error, but I'm going to leave that as it is. And then we just want to return our response.json at the end, which are our tokens. So if we run this now, 20 odd minutes in, if we run this now, we will be kicked out into the browser, and I will load this up. Just had a bit of a cut for that zoom because I do want to censor a number of these email addresses. So we can click on this, and then we can click on this. So this is just the normal Google, YouTube authorization flow. Select all, continue, and then you can see we get flashbanged. If we look in the corner, we have this authorized up here. So it's all worked. If we come back to our code, we get a bit of a log to say what happened. We also get our tokens here. So we have our access token, and then it's this great big long thing here. We also get an expires in, which is always an hour minus a second. We get our refresh token, which will be important later. We then get a series of our scopes that the token is able to use. And then we get the token type, which is always bearer. Once we actually have the token, we can then check that the token is okay. And we can get some info about it. So if you do token info equals, and then we'll do check access token, which is something else we're going to be creating. And we just need to send through the access token. And then we can print the token info like that. And if we define our function here, check access token, and then we want that. Yeah, that's fine. That's also, and that's not fine at all. I'm going to rewrite that. Oh, the fun of AI. So with request.get, and then stop doing that. Oh my god. One small fight with an AI over. We could do with requests. Still trying to do it. .post, and then I'm actually going to copy and paste this entire URL in. I don't have a constant for it. You probably would want to define that. Oh, we don't want to do that. But I'm not going to here. And then we can just return response.json there. So we're just posting to that, and you do have to post to it. You don't have to send any data to it, but you do have to post to it. We can then check to see if the response status code is 200, and then we can return our token info. If we do that, and I'm going to quickly go through the authorization process again off camera, we can see this token info down here, and I'll highlight it so it's a bit easy to see. So we have various attributes to it. We have this AZP, AUD, scope, expiry time, expires in, and then the access type. You can use this to detect if a token is still valid. So at least for Google, if this returns a failure, then, or if it returns anything other than a 200, or it doesn't return anything at all, then the token needs to be refreshed. The access token isn't valid anymore. So you can use that. Basically, if you just get a normal response, it's fine. You can check it if you want, but a normal response is all right. But if you do want to refresh it, then we can refresh it like so. So we can do refreshed tokens equals refresh token. And this is another function we're going to do. And we want to pass the secrets, and we want to pass our refresh token through. And then we'll do that. See, the AI is sometimes helpful. And then we can create a new function, def refresh token. That looks fine. I'm not going to trust it anymore with the contents. So we could do params once again. We want our grant type to be refresh token. So we're actually sending this off the token endpoint again. Before, where it was a grant type with authorization code, we're now saying that the grant type is refresh token. So we're now saying we don't want a new token, we want to refresh an existing one. And then we need to pass our client ID, we need to pass our client secret, and we need to pass our refresh token through. Once we've done that, we could do request.post, post the token URI, and then that's fine. So we do the same thing as we did before, where we send through our data as params, or our params as data, and we pass this content type to say we want it as a URL encoded, as response, and then that's fine, get rid of that bracket. So again, we're checking to see if the response type was 200 or not, and then we're just returning our response.json, which will be our refreshed tokens. So if I go through one more time, and I'm going to do this here so it's a bit clearer, we can see that we have our refresh tokens here. So you have our access token, we have our expiry time, we have our scopes, and we have our token type. And you'll notice that it doesn't return the refresh token with it. So you do need to store the refresh token if you do plan to use it, because when you actually refresh your token, you don't get the refresh token back. I guess probably for security reasons, I would imagine, but you do need to store that if you do want to refresh it. So what I haven't done here is I haven't made this smart. So you can use the token info to check if an access token is still valid. If it's not still valid, you can use the refresh token, or you can refresh your access token to get a new one. If you can't refresh it, you'll need to reauthorize from scratch. And this is how you can make it a bit smarter. So you can put this check in, say, is it valid? Yes. I'm just going to skip the rest of it, so you don't have to authorize every time like I just did. And you can use your refreshing and your existing tokens to authorize yourself. Generally, access tokens last an hour, and refresh tokens can last however long the token provider wants. For Google, that's 7 days. For other services, that could be longer, that could be 30 days, or it could even be infinite. But generally speaking, OAuth tokens last an hour. I don't know if there's a way to customize that. Either way, they don't last very long, and they're not designed to last for very long. One very quick thing before we end the video is that these scopes aren't the only scopes you can do. If you want something a bit more comprehensive, then you can use OpenID Connect. And the only difference between OAuth 2 normal and OpenID Connect are the scopes that you pass through. So again, these are slightly Googlified. Normally, you could just pass profile and email through in the same way that I'm passing OpenID here. With Google, I think you have to pass the full URLs. But if you pass OpenID and email, at the very least, then you get what's called a JWT user token back along with your other tokens. And then profile, I think, is a Google exclusive thing. So if you run through all that again, and you'll see actually on this page, we are asking for more details. So we're asking for info on our Google account, asking for personal information, and we're asking for the primary email. If we then continue that, we get flashbanged again, and you'll see our token is a lot longer. So it's still saying oh, actually, the ID token comes back in the refresh tokens. I generally didn't know that. But if I come back up here, the tokens, you see it's a lot longer, and that's because we have this ID token. Now this is a JWT that I'm not going to talk about in this video because I've already done a video talking about JWTs before. So if you want to know about this, then go and watch that. But that is how you could get an ID token, and this is how you can get people's email. And I forget what else actually is included in that. I know the email is, and there's some other stuff in there as well. I don't remember. But yeah, let me know in the comments how you plan to use this. What sort of project? Decorators are a really cool part about Python that allow you to extend functions beyond their original functionality. They allow you to remove code duplication. But I mean, they could be used to do all sorts of crazy things. But they are also something that tends to trip people up quite a lot, especially people coming into Python for the first time. They look at a decorator and think, what the hell does that do? So in this video, I'm going to be going over the process of creating a decorator from the ground up. So we're going to be starting by creating a simple decorator, then we're going to type in that decorator, Then we're going to create a parameterized decorator, and we're also going to learn how to type in that as well. So you get the fundamentals of how they're built and also how to type hint them, because type hinting them is a challenge in and of itself. Of course, if you find the video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. But with that out of the way, let's get decorating. So we already have some test code on the screen. This is just a little function for factorial, and then running the factorial function. I'm actually going to change that to 100, not 1000, because the factorial of 1000 is quite a lot, and that'll prove problematic. And we can do a print there like that. And this just provides some context to create a decorator. So what we're going to do is we're going to create a timing decorator. This is quite a simple one to create. All it does is essentially time how long the function takes to run, and then print that to the console, and then everything else is completely unmodified. So it's a good one to start with. So first we need to import time, and this will have our actual time utilities. And then we could do from functools import wraps, and we'll talk about what that does in a second. But to begin creating our decorator, you just need to know that they are normal functions. So we could do def timer, and then we pass a function through. So our decorator takes a function, and then we define another function inside that takes args and quargs. So in this instance, the function will be our factorial function, and our args and quargs will be the args and quargs of the factorial function. In this case, there's only the n, so the n will get passed to args and quargs will be empty. But that's the general idea. So we can do start equals time dot perf counter ns. Perf counter ns just gets the number of nanoseconds since the start of the program's execution. Outside of timer, it's the best thing to use. And then result equals func args quargs. So we're now calling the function within inside our wrapper. We then end. We basically just get the same again. And then we can do, actually you could probably do, no, we'll do delta equals time dot perf counter ns minus start. That seems a bit cleaner to read to me. And then we can simply print that our function dot name, there we go, took delta, and then bam, 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 just some string formatting, nanoseconds, because this is nanoseconds. And then we can return the result of the function. So this result will be the same as this result down here. And then from the timer, we can return our wrapper. And then from there, we can simply just decorate our factorial function with the timer decorator, and we are good to go. If I run this, ignore that. That was previous Deques that I've abandoned in this video. And we can see that our factorial took 7,875 nanoseconds, and that the factorial of 100 is this. So a quick recap of what's going on. When we decorate this function, when it's called, the timer function is executed, and the factorial function is passed in as this, which we've called func. You can call that whatever you want. We then define a wrapper in here, and again, you can call this whatever you want. I just always saw this as wrapper when I was learning about decorators. I think that's the most commonly used. You could use inner if that makes most sense to you, or you could completely troll everyone and call it something crazy. It's your prerogative. It's up to you. But inside this wrapper, we simply just do some time stuffs. We also run the function within it and then get the result out of it. We then just print the amount of time it took, and we return the result. And then this return wrapper sets our factorial function to the wrapper. So that's the important thing about decorators. You're not actually executing this function. You're now executing this function here, which then calls our original function internally. So you could create a decorator that just didn't call the function if you really wanted to. But you can actually prove that it calls the wrapper by printing, print factorial.name. And when we do that, we can see that it comes out with wrapper. So we are actually getting this function's name back out. If you don't want that to happen, we can use the wraps that I said I'd talk about earlier. So we can decorate our wrapper, and yes, it does get a bit introspective at this point. You can do wraps func. And what this will do is it will give our wrapper function the name and the docstring and probably various other attributes to the wrapper function. So now when we print factorial dot name, we will print factorial instead. And if you were to print factorial dot dunder doc, it would print the factorial's docstring and not either none or whatever you set this docstring to, if you happen to set it. So that's the basics of how decorators work and how to create them. I'm now going to type hint this. If you don't want to see type hinting and you just want to move on to the parameterized decorators, I have left timestamps in the description for you to skip forward and backwards. But type hinting decorators is kind of an art in and of itself. So I thought I'd cover it and make this a comprehensive video of sorts. We are not going to be using Python 3.12's generics. One, because I think they're harder to parse, especially when you're trying to learn something new. And two, because MyPy doesn't support them. So we're going to be doing it the old way. Yay! So we could do from typing import callable paramspec and then type var. And then we can create p, which is a paramspec name p, and r, sorry, which is a type var of type r. So our p or our paramspec will represent the args and the quags, and then our r will represent the return value for the function. So actually typing decorators, I tend to type them inside out. So I start with the inner function and then go out because I find that a bit easier. But for our args, we could do p.args and then p.quags, and then we can return out r. And what doing this allows us to do is it allows us to essentially inherit the type signature from, or inherit the function signature from the original function. So much like wraps allows us to use the original function name, paramspec and then type vars allow us to use the original function signatures. So it will now realize, or statically typed, it will realize that we are passing in an integer and we're returning an integer. As you can see from this type hint, it still understands that. Actually type hint in this function, we can simply just use what we have here. So we could do callable, and then we take a paramspec, and then we return a return value, and then we return a callable that takes the same paramspec and returns the same return value, because we're simply just running the function with the same inputs and we're returning the same output. We're just doing stuff around it. So we can share a function signature here. And now this is all fully typed. So if I were to do mypy strict simple.py, we will see that we have no issues in one source file. So that's a simple decorator. Now moving on to the parameterized one. I don't know what I've done there. We can just copy this and paste this over to here. So what I mean by a parameterized decorator is a decorator that you can pass arguments to. So if you wanted to set the units to something different, so say if we wanted to have it emit milliseconds instead of nanoseconds, and what if we wanted to set the precision of our output? We can do that to 3, for example. And a parameterized decorator, also known as a decorator factory, will allow us to do that. So to actually do that, we need to first rename this to decorator, or you can rename this anything you want. Again, this is a sort of pseudo standard, I'll call it. We need to indent this over. We need to wrap the whole thing in another function called timer. And then we want to, if I bring my notes up, we want to set unit here, string, and then we're going to set that as a default to nanoseconds. And then we also want to set our precision as a keyword only argument to an integer, and we'll default that to 0. Like that. And then in our delta, what we want to do, we actually want to define a series of units first up here. So if we set units here, and then we set in a very specific order, nanoseconds, microseconds, milliseconds, and then seconds, and we can use that order to our advantage later. We can, in our delta, we can change this. So we can divide by 1,000 to the power of units dot index unit. And what this will do, so if we pass nanoseconds, it will divide it by 1. So you get the same amount. If we want to pass
microseconds, it will divide it by 1,000 because there are 1,000 nanoseconds in a microsecond, etc., etc., etc. And we can use the units.index to come up with a smarter way of doing that. And then we can simply just pass the unit here. And then we can also pass the precision here. So that's a funky thing you can do in f-strings. You can put an expression within the format expression, or a variable within the format expression, or however you want to talk about that. And then actually within our timer decorator, we then need to return, or our timer function, sorry, we need to return the decorator. So if we were to run that, if I were to run this without these keyword arguments, actually, we would get the exact same result as we did before, where it does it in nanoseconds. If we were to say we want it in milliseconds and we want the precision to be 3, we now get it in the form of 0.007 milliseconds. So we can see that our arguments are taking effect. And what's happening here is that we pass the timer up and then we give it these arguments. So we're actually calling this function as soon as it's evaluated. So unit and precision are set internally. And then we have our decorator here. And this decorator is then returned out the function immediately. So our factorial function is actually in a very similar state to it was here, where you have a decorated actual function. And then when it's run, the exact same process as before takes place, where the function is replaced with this wrapper. And that's the only real difference, that something is executed immediately and then this decorator just returns this essentially, and then you can track the logic back from there. If you wanted to type this, it's really kind of annoying to do because it looks very weird. So I'm actually going to do this. No, we'll do it on the same line for now. We'll let the auto formatter sort it out. So going from inside out, so we have this callable PR, that is our wrapper, and callable PR, a callable PR is our function, and the same thing for the wrapper. So this timer is returning a callable that takes a callable and returns a callable. So we can do that by doing callable, and then within our brackets, you'd say it's taking a callable of PR, and then the return type is a callable of PR. And this looks awful, but it is how you type parameterized decorators, unfortunately. Anthony Wright's Code recently made a good video talking about an easier way of doing this, or a slightly less messy way of doing this. That I watched, I was like, whoa, that's mental. So I'll link that somewhere in the cards or whatever. But this is how you would do it in its raw form. And that is pretty much the ins and outs of decorators. Let me know in the comments if this helped you out at all. And also, functools.partial is a relatively little known part of Python that allows you to create partial functions instead of lambdas or named functions that are based on other functions. There are a number of cases where partial functions are more readable than the alternatives, and actually they can be quite a bit faster as well to execute. And while they are very simple, you can do some pretty crazy things with them too. If you like this video, then make sure to leave a like to let me know, and maybe subscribe if you want to see more videos like this. But with all that out of the way, let's see what these partials are all about. So to actually start using partial, we can do from func_tools import partial. And then I'm going to use a doubling function to show this off. But I'm going to have def mult here that takes x, and we're going to keep it simple and just use integers. And then we're going to return x multiplied by y. I'm fully aware that I can import mul from operator to do the same thing, but I want to be a bit more explicit when I'm explaining certain things. So we're defining it ourselves. So we could, if we wanted to, create a double function that took x as an int and returned an int that returned mult x2. And what this will do is it will multiply our input number by 2, essentially doubling it. So if we were to do if name double equals main, like that, and then we print double 5, we will get, as the terminal kind of spoiled there, we get 10 because it just multiplies the thing by 2. It's not a difficult concept to understand. But if you didn't want to define a whole new function for that, you could use partials instead. So we could do a double equals partial, and then we provide a function, so mult, and then we provide any number of arguments. So we're going to provide 2. And what this will do is it will create a partial function, you can think of it as. So it creates a function with 2 already passed to it. So when we call the double function, 2 will be set to x, and then we're just passing something to y. So you can sort of think of it like, if I undo this one and then reverse the logic, you can sort of think of it as exactly the same as this. So if we were to then run it, we would see we get 10 back. And this just saves you from having to create a whole new function with type signatures and everything, and then do all this when you can just do a single line thing. And it actually preserves the type hints. You can see it registers as a partial that returns an integer. If I were to get rid of all this and do it again, you could see that it recognizes that not only is it an integer, but it's the parameter y. So it's actually able to use malt's function signature to generate its own function signature for the partially initialized function, which is really cool. On top of being more readable, in my opinion, and certainly a lot more convenient in a number of instances, it's actually a little bit quicker to create a partial function than it is to create a brand new function. And I've created this benchmark to show that off. So in our first test here, we have our double file. It's exactly the same thing as before, but we have a lambda x, and then you know what, for the sake of full full parity, I guess, we will do it in the same way that a partial would. So we create a lambda function, and then we multiply 2 by y, and in this case we are importing operator or mul from operator. In this case, down here for the partial, we are importing partial, and then we create a partial function much like we did in the other script, and then we just print the results down here. And then if I do that benchmark, we can see that partial is about 1.6 times faster to run. I will say it is a little bit slower to create a partial function than it is to create a lambda, but executing it is actually on average 1.6 times faster, at least for this particular function. The reason for that, I am really honestly not sure. If anyone does know why partials are more optimized, then do let me know in the comments. I believe it's because it's not actually creating a whole function, it's just using a function and then creating a class to execute it or something. You'd think that would make it slower, really, creating a whole class rather than just a function. But then a function is an object. I don't know. If anyone knows, do let me know. But it is faster to run. It is consistently faster to run as well. So for something like this, as I said, 1.6 times faster. If you wanted to use partials for methods instead, then you could. So as you can see, I've set up our previous example inside a class. If we import partial method from here, we put partial method down here, and then we indent this to be a member of the class. And then I'm just going to create a quick instance test.double. I don't know why this is complaining at me. Oh yeah, we need a self. That would help. But now if we run that as a script, we can see that it runs the same thing. So we've now created a partial method within our class. So those are the basics of partial method. I do want to show one more thing, and this is one of the crazier things you can do with a partial. The partials are already very situational, I will admit, but you can do some wild things. And one of them is an optionally parameterized decorator. So what I mean by that is a decorator you can call with or without the brackets. So if we go into decorator here, and I'm just going to copy and paste this all in. So this is from the decorators video. I haven't copied it all. That's weird. This is from the decorators video I did last week. If you are unfamiliar with decorators, I recommend you go and watch that. So currently the only way that we can call this decorator is like this without the brackets. If we did do the brackets, then it would crash. You can actually see it's going to error here, saying that it's missing a positional argument call. However, if we wanted to make it so we could do that, we could say that func equals none by default, and in here, if func is none, and I realize now I need to import partial, then we can return a partial of timer with all our other arguments. So let's say we had an argument here that was verbose. And then we did verbose equals verbose like that. And then our verbose behavior, I'm just going to copy paste this from my notes. We just say, if verbose, we emit when it started. and then when it ended, like that. You could still run it like this, and it would run perfectly fine. You could also run it like this, and it would run perfectly fine. You could also run it with verbose equals true, and it would help if it actually printed anything. Why is it not printing anything? Oh, I'm running the wrong bloody thing, that's why. With decorator, there you go. So we have our started at and our ended at times. If I just go through again, so if you run it like this, we could see it runs perfectly fine. If you run it like this, we can see that it also runs perfectly fine. And that is just the power of partials. Now, the one caveat to this is you are limited to keyword arguments if you want something that is kind of a bit more predictable. You could probably do it with a function, or you could probably do it with arguments if you were to check if the function was a function, and if it wasn't, then do this. Otherwise pass things through, but that just gets a bit messy on a programming paradigm that is probably not recommended anyway. But yeah, this is just one of the fun things you can do, with a partial if you wanted to. Let me know in the comments what programming problems you've come across that are partial. Perhaps unsurprisingly, contextlib is a library dedicated to context manager utilities in Python. If you don't know what context managers are, I did a video a little while ago explaining them in their raw form. In this video, I'm going to be using just simply the contextlib to create context managers, as well as show you a number of other really useful utilities. I'm going to be showing you 5 today, and hopefully by the end of this video, you'll be able to use at least one of them in a program of your own. Of course, if you find this video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. With all that out of the way, let's get into it. So the first thing that I want to show is from contextlib import context manager. And you could argue that this is sort of like the flagship feature of contextlib. It allows you to create a context manager using just a function. So it is a decorator, so we can decorate it like that. And if we were to create, say, a function or a context manager that set the random seed within a context, we would first need to import random. That would help. And then if we were going to type it, we would need to, from typing, import iterator like that. And then we do def seed. And then I'm going to mirror the exact function signature of random.seed. So it'd be a, that's an int, float, string, bytes, byte array, or none equals none, which is quite the series of options to have. That's genuinely the signature. And then we return an iterator, in this case of none, and then we're going to pass. And then within this, we can do random.seed a, so we're actually setting the seed. And then I'm going to print that we are yielding. And then we just yield like that. And then we print resetting seed. And then we set the random.seed without any arguments at all, which sets it back to the default behavior. So what's happening here is, well, actually, you know what? I will do a practical example and then I'll explain it, because that will probably be a bit easier to work out. So if we did something like this, and then if we did maybe 2 of them, when we enter the with seed context, we come up here and then we set seed, and then 42 will be set to A. And then we set the seed to A. We then print our debug message, and then we yield control of the program back into the context block. So we then enter the context block here. We then do everything in here. We then exit the context block. We come back into this, and then we continue from the yield statement. So we then print resetting seed, and then we'd reset the seed. If we go ahead and do that, we can see that we have yielding. So that's here. We then yield back. So we then print our random values, and then we reset the seed afterwards. If I were to do that a few times, we can see that the random values are the same every time. If I were to print one of these, actually, if I were to just move this one out, you can see that the first one is always the same, but the second one is always different, because we've now reset the seed because we've exited the context manager. And that is, well, anyone that's familiar with context managers will know that this is what they do, but you may not have known that you can create it using a decorator and a function. However, our context manager is not perfect as is. If we were to introduce an error inside the context block and we print it again, we run it again, sorry, we get the yielding, fine. We then get the value, okay. And then we get the traceback. But you'll notice that it never prints resetting seed. And that's because we don't have any handling in place to deal with that. So the general convention, and pretty much I imagine what you'll see everywhere, at least this is how they do it in the Python docs, is you'll have a try with the actual logic, and this is where you put your yield, and then you have a finally, and then you'd have your kind of cleanup operations, whatever you wanted to call it. And now if we do that, we can see that we reset the seed, and then we raise the error. So context managers have their own way of handling errors. I should say that I have done a video on context managers before in their more raw form. So if you're confused about what I'm talking about, I'd recommend going and watching that, then coming back. But this context manager decorator handles all that for you. And the finally block here just means that even if there is an exception within the context, it will then come back in here. It will then see, oh, we need to run this code. It will run it, reset everything, and then it will go and raise the error or whatever it wants to do. If you handle the error down here, so if you were to do like a try except down here, we wouldn't have that problem, even if you didn't provide the finally block. It's just more, especially if you're doing a context manager with files or databases or something, and you want to make sure that something is closed, then you can do that using the try finally here. The other really neat feature about this context manager decorator is that you can actually use it as a decorator itself. So you can use this seed as a decorator. So as an example, if we were to have a def random numbers here, and then we provided, I don't know, n equals 3, or n, which is an int, equals 3 by default, and then list int, and then we do return random dot rand int 1 to 10, and then n numbers of those. If we were to set seed as a decorator here, and we can use the same seed as before, comment that out and comment that out. Actually, if I just comment all that out, that way it won't get in the way. And then we can print random numbers like that. What we get back is 215. If we do it again, we will see that the random numbers are the same. And that's because we've now decorated this function with a context manager. So this function is sort of within the context of the context manager. So for the entire duration of the execution of this function, the random seed is 42. And then you can see we're resetting the seed. So if we were to, if we were to print it out, well, actually, if we can print random.random, we can see that the seed has indeed been reset. Rand int 110. We can see that that second value will be different every time. And that's because the seed has been reset. Going back to the idea of making sure that everything is closed, contextlib does actually provide a decorator, or a context manager, sorry, that allows you to do that. I'm going to get confused with the two now that I've talked about decorators. So we can do contextlib import closing. And this closing essentially allows you, or it's a context manager that makes sure to close whatever has been opened in the context manager. And this is largely for third-party packages that don't have context managers of their own. Most Python interfaces do have context managers built in. So the open method, for example, will do. The URL open will do. But you can do this on things that don't have it. Although we are going to, and I will actually take that. I'll print f.read. We are going to use the open just for demonstration purposes to show that it works. But you wouldn't need to do it for this. You just need to be aware of it for any third-party packages that you might want to do it for. So if we do py closing like that, we can see that we've printed out the context of the file we just wrote, and we have closed the context manager. Now, it's very difficult to prove that, but I can show you what it's actually doing. So when it enters, it just takes the thing, and then when it exits, it just calls self.thing.close. So anything that has a .close method will have it called when the context manager exits. And this just means that if something doesn't have a close, you don't have to rely on explicitly closing it. You can just use closing and it will handle it for you. The third thing I want to show you is from contextlib import suppress. And this, as their AI AI preview is showing, will allow you to suppress errors in a way that isn't a try except block. So typically, I'll show you what you would kind of do otherwise. You do try that and then that and then that. And if I get rid of this, so we can try 1 divided by 0. In the case of a 0 division error, we can then pass it, and this will ignore or suppress the error from being raised. However, we can also do that using with suppress. And this will suppress within this block if this error or any other errors. I think you can pass in as many as you want. Yeah, you can pass in as many as you want there. If any of those errors show up in this block, the error will be suppressed and the context block will exit. So if we run this, pysuppress.py, we'll see that we get no output, we get no tracebacks because the errors have been suppressed. Now you can see that it takes up a lot less lines of code. In my opinion, it's also much more readable, it's much clearer what's going on. We are explicitly suppressing these errors, and Sorcery, the AI refactoring tool, will actually recommend using suppress instead of try except pass. That's how I learned about it. But it does come with a bit of a caveat. And to show that off, I have this suppress benchmark. So we have our try except code and we have our suppress code. We then also have some timings that are running these functions 1,000,000 times each. So do keep that in mind when you see the results. If we then run this, we can see that the try except ran in about 0.15 seconds and the suppress was 3 times slower. So suppress is 3 times slower than try except because it's just doing more work. I think it actually compares instances and stuff, which is why it's doing it. If it's only ever going to be called once or twice, it's probably not going to matter. But if this isn't a function that's being called millions upon millions upon millions of times, then this 3 times slowdown is going to start adding up. So whether or not you want to use suppress will really depend on your priorities. The final 2 things I want to show you are both very similar, so we're going to talk about them at the same time. And they are from contextlib import suppress, nope, that was last time, redirect standard out and redirect standard error, which do very much what they say on the tin. And we're going to import sys for something we're going to do a bit later. So if we do if name equals main 1 final time, like that, we can, with open help.txt, I wish this AI would shut up. It's getting really annoying right now. As f, we can then, with redirect standard out f like that, and then help pow. So this example is taken straight out of the Python documentation. What we are doing here is we are opening a file using a context manager, ironically enough. As f, we're then redirecting the standard out to this file for the duration of this block. So if I were to go and say like print hello world, even when the file is still open, we'll see that this gets printed to the terminal. But if I run this, we can see that hello world gets printed because it's outside of this redirection block, but the help pow ends up in this file because we've redirected it. And it doesn't have to be a file either. It can be an IO string object or any sort of IO object, I think. It can also be, if you wanted to send it to sys.standard_error, sys.standard_error, if you really wanted to. So basically any sort of IO based file stream, you can redirect the standard out into it. You can also do the same with redirect standard error. Now I will say that redirect standard error does not send tracebacks to a different place. Tracebacks are not written to standard error in Python. I don't know if there's a way, or maybe they are and there's some hook that just overrides it. I'm not sure. But if you had a program or a script or something like that that wrote anything to standard error, then you could redirect that as well. So we could redirect, or we can open error.txt as f, and then with redirect standard error, say just print hello world, and then we'd need to send that to standard error. And this is important actually with the standard out that I forgot to mention. If you are doing a print, you can redirect it using this file. So this file lives by the same rules. It needs to either be an open file or sys.standard_error or some sort of IO based text stream. In fact, actually standard error is a text IO, you can see there. But if we were to do that, we can see that we have this error.txt and then this hello world is printed here. this second hello world on the terminal is the one from earlier. You can also redirect using both. So I could redirect standard out as well. And then I could print, so actually if I print hello standard out like that, we can see that because we've redirected the standard out and the standard error to the same place, our error.txt has both in it. And you could use this to redirect the standard out to one place and the standard error to another. I forget what Python version, I think it was 3.11 that allowed opening multiple context managers at once. If you're on earlier versions of Python, you can do this just by doing that. Whoopsie daisies. And that'll do the same thing. Let me know in the comments which feature of contextlib is your favorite. Those of you that have been around a while, remember I did a video on Pydantic about a year ago, which is a library that aims to allow users to represent and validate data using incredibly powerful interfaces that are similar to data classes. In that video, I used version 1.10, but since then version 2 has come out, and while not an awful lot has changed, I thought I'd make an updated video showing you how to do it with version 2.0. So I'm going to be showing you not only a simple example on how to create and validate data using Pydantic, but I'm also going to be showing you an example of how you can use it to represent and work with API data as well, because it is really, really good for that. Of course, if you find this video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. But with all that out of the way, let's learn how to use Pydantic. To get started with Pydantic, we first need to install it. So we're going to do pip install Pydantic like this, and you can see they've done something very clever and made it Pi. I think that, oh no, it's spelled with a PE in normal English. So they've done something very fancy there. And we can see that we install Pydantic 2.7.2, Pydantic core, typing extensions, and annotated types. Pydantic is very type hint heavy, which is why it does all that stuff. And we can start creating a model. So we need to, from Pydantic, import base model. And then for our model in particular, I actually want to import datetime as DT. And then we can create a model just by simply making something inherit from base model. So this order is now a Pydantic model. And we can use this similarly to data classes, or pretty much exactly the same as data classes, really. So we can set an ID equals int, and we're going to set an item name is a string. We're then going to set a quantity as an int. We're going to set created at, and then we have, say, delivered at, which equals dt.datetime, or none equals none. So anyone that's used data classes or even attrs before will find this all very familiar. You know, you define something at a class level, you define its type. You don't necessarily need to define a default value, though you can if you want. And it's all, you know, it should all look very much the same. So if you were to then create an order in our code, so we can do name equals main, whoops. We can do O equals order, and then if we set, say, the ID equals 1, the item name equals test, quantity, yeah, that'll do. Equals, we'll set this to like 3. And then we print O. We get a perhaps unsurprising output, which has, you know, ID 1, item name equals test, quantity is 3, and everything is, you know, formatted properly. And you even get the date. Which one of these is the date? This one. This one's the date, the exact date and time I'm recording this video. There you go. Everything looks very normal so far. Everything looks very familiar. You might be wondering, if you've never seen Pydantic before, why you would want to use it over something like data classes or attrs. And there are a few cool little things that Pydantic does that that data classes especially don't do, and there are actually some things that attrs doesn't do either. So one of the cool things, attrs might do this, but it does type coercion. So we're going to get an error here. But if you do this, we can see that the type is actually set to an integer. It's not displaying in the same way as a test would. And we can actually verify this by doing print type O. Dot quantity. There we go. We can see it's a class int. So even though that we've passed in a string, our quantity, because the field is actually an integer, Pydantic has taken the liberty of converting it for us. I think I think in Atlas you have to manually tell it to do that. In Pydantic, it does it for you, which is really nice. One of the other particularly useful things you can do is validators. Now, Atlas does do this, dataclasses does not. But we could say, if we imported field validator, and this is one of the changes between version 1 and version 2. In version 1, this was just validator. In version 2, it is field validator. And this is a decorator, so we can set field validator, and then we pass in the name of the field that we want to validate. So in this case, it's going to be quantity. And we can set def validate quantity, and then we're going to set value to be an int. And you'll notice we are passing in the class, not self. So class is actually a, this turns into a class method technically. So you pass in the class and not the instance when you do this. And that's going to return an int. And then we can say if value is less than 1, we can say that quantity must be greater than 0. We can raise a value error. Otherwise, we just return the value straight up if it's fine. And now if we set the quantity to 3, we can see everything's fine. If we set the quantity to -1, it starts complaining. And it throws a slightly bizarre looking traceback, but you can see one validation error for order. It gives us the name of the field that errored, and the type of the error, and then the message of the error. And it also gives us some other nice details as well that I don't think version 1 did. So you can use this to validate fields as you pass them into the model. If we do something similar for field validator created at, because we wouldn't want this to be in the future, so we can do validate created at, and it's going to understand exactly what I want to do. Yes, it is actually going to understand exactly what I'm going to do. So we can actually probably do this instead. There we go, that's a bit clearer, because then we can use backticks to say that created at must be in the past. So it's now comparing it to the current time. If it's bad, it'll raise an error, and then we can see, we can do, say, if we put this one into the future, much like the other one, it will error. But you'll notice that we actually get an error for both. So it would tell us that firstly, that quantity must be greater than 0, and it will also tell us that created at must be in the past. So it accumulates all the errors together. It's not going to be that, oh no, I've messed up quantity, fix that, oh no, I've messed up created at. It tells us both at once, which is actually really nice. Weirdly, one thing it doesn't check by default is that assignments pass the validation checks. So if we just fix all this, and we can get rid of that. So if we do o.quantity equals -1 or -1, when we run it, we won't get an error, and we can actually print o.quantity to confirm. This is what we get. It sets it to -1, so we can bypass it that way. If we don't want that to be a thing, then we can pass a configuration. So you do that by passing class config into the model itself. This is anyone that's familiar with Django will recognize this. And then it'll be validate assignment equals true. I think I haven't put this in my notes. So we're going to see if that's right. It is. There we go. So we can now see that our value quantity is being validated when we assign it. And we can now see it will actually give us o.quantity or quantity equals -1. It will actually tell us where exactly the error originated. And it will give us exactly the same error as it would have done if you passed it into the constructor. So now we've talked a little bit about how Pydantic works, and I showed you the basics. I want to show you a more real-world example using an API. So the work that I've done with Pydantic specifically is mainly with APIs. They're really good with them because you can do so much. There's so many options that make it much easier to deal with. So if we pip install requests, there we go. Or you can use your preferred thing of choice. It really doesn't bother me. And then we import datetime as DT. We then import requests. Oopsie daisies. Oopsie daisies. Whenever I turn the screen recording on, I just lose the ability to type apparently. And then we're going to do from Pydantic import base model. And then we also got to import fields because we're going to be using that. And the API we're going to be using is the UK government, not that one, the UK government's bank holidays API. So we're using this, one, because it's a very simple API, and two, because it's really funny. So if we go over and we actually load it, we can see we get this JSON back, which is all very nice. We get our divisions, we get our events, we get the title, we get the date, we get the notes, and we get whether or not bunting is appropriate. Which is perhaps the most British thing I've ever seen in my life. And I had to use it. I just had to. But it does also allow us to show a number of things because it is a bit of a non-standard API. And we can use Pydantic's advanced features to compensate for that. So first, we want to actually fetch data. So we're going to do, we're going to data equals requests .get URL and then .json. So this will get exactly what we're seeing here in a dictionary. And then we want to start defining our models. And I say models because we're actually going to be doing a few. So you see everything is nested in here, where you can actually nest Pydantic models and Pydantic will just be able to work out what to do. So by that I mean we can do a class event, base model, and then this will handle everything in these events. So the title, date, notes, and bunting will all be handled in there. So we can do title equals string, date is a date time.date, notes is a string, and then bunting is a bool. We then, if we go one level up, we then have our divisions. So if I actually close these, we can see that we have 3 separate divisions. And inside the division, we have the division name and the events. So we can do class division base model. And then we could do name string. Or actually, we'll do division string and we'll come back to that. And we'll do events list of event. So you're now seeing we're already using another Pydantic model. And then we have the actual bank holidays themselves. So I'm just going to call this bank holidays. And then we will have England and Wales division like that. We have Scotland as a division and Northern Ireland as a division. And that's our entire API, pretty much. Now this won't work at the moment, and we'll talk about why that is in a second. But if we then do holidays equals bank holidays, and then we do just pass the data in like that, we will see that, we get a good number of errors. So England and Wales, it's complaining because the field is required. Now this is one of the not so useful errors that Pydantic provides, but the problem is that the input value uses kebab case, and in our Pythonic class name structure, we use snake case. Now this is quite easy to do. So there are 2 ways of doing this. I will show the second way later because the division has a problem with this too. But to actually change it for all of your attributes within a model, we can do class config again, and then we can set alias generator. And then this will be a callable. So for us, we want to make sure that our aliases, and this logic it feels kind of backwards. So what we're doing is we want to define the logic to convert this into this, not this into this. So we're going to be replacing our underscores with dashes. And that will convert our Pydantic model name or attribute into the actual name that's provided in the API. And if we do that, then we'll actually get a successful thing back, and then we can print holidays, and this is going to be just a disaster because there's just so much stuff. If we do holidays, say .division, dot events, what is going on? Events 0, and then we'll just do that. We get an error. Why is that? Oh, because it's not division, it's the name of the division we want. We can see that the first event is New Year's Day 2018, and that bunting is appropriate for New Year's Day. Remember that, that's very important. And yeah, that all works perfectly fine. Now, what I was talking about before when I said that there was something wrong up here is that we have this division and then division is inside it, which is how it appears in the API, sure, but it's not the best name for it, really. It's not the clearest. It would be clearer if it was called name, because we then have the division and then we have the name of the division under name. But of course, if we do that, it's going to complain because, you know, England and Wales.name, it doesn't exist. You know, it's called division in the API. And this is the second way of creating an alias, where you can set this value as a field and you can provide the alias name is division. Now, again, it's a little bit, well, I suppose it's not a little bit backwards when you think of it like this. It is the conversion from this into how it appears in the API. But now we've set alias to be division, and now Pydantic knows that when you get division back, it should be passed to name. And now it works just fine. So if I were to get print holidays.scotland.name, we can see that we get Scotland back. If we print division, the name division, we don't, because even though the API has set it to division, and even though it's an alias, we haven't set it as such. We've set it as name. So in the Pydantic model, it is name, even though in the API is division. So whether or not you would want to have that is entirely up to you. It really depends on the API. It really depends on how you want to wrap these things. But in this case, it can be used to make things a little bit clearer that the name of the division is division.name rather than division.division. So the final thing that I wanted to show you before we go is that using these Pydantic models, you can actually create properties on these. So if I create a property on event, and if we set def is passed self bool, and this will be true if the event is in the past. So if the event has already happened, then this will be true. If the event is in the future, this will be false. Obviously, the API doesn't provide that, but using the fact that this is a model, we can provide a property that compares it for us. So we can then set, is this in the past true? Because it was New Year's Day 2018. If we look at the last one, and I'm actually going to print the last one out. I don't know how far it goes. See that Boxing Day, Boxing Day 2026 is the furthest it goes. My goodness. This one actually does have notes. That's interesting. And bunting is appropriate for Boxing Day. Keep that in mind. But you can see that it's in the future. It has not passed, so our property fails. Or it doesn't fail, it returns false. But the property is not returned in the repr or the string representation. It still just returns what the API returns in this bit. And then we also have our property that we've done. You could also put methods on it if you want. You can, well, it's an object. Treat it as you want. You can do anything. Let me know in the comments if there's anything really cool about Pydantic you know about. In Python, it is not unreasonable that you're going to write a program that needs to work with JSON data or TOML data or YAML data, or maybe even message pack data, perhaps even structured data. And there are a lot of tools out there for each. So you have the JSON built-in library, you have the TOML library for TOML, PyYAML, Pydantic. There are all sorts of message pack libraries as well. But what if I told you that there was one tool that can do all of those things and it prioritized speed and ease of use over anything? Well, luckily for you, such a tool exists, and it's called Msgspec. In this video, I'm going to be showing you how to encode and decode JSON, TOML, YAML, and Msgspec data, as well as how to work with structs, and we're going to be comparing the performance against other alternatives as well. Of course, if you find the video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. But there is a lot to cover in this one, so let's just get on with it. So to get started with Msgspec, all you need to do is pip install it. So we could do so pip install Msgspec. The reason I put quotes there is if you want TOML and YAML functionality, you will need to install some extra packages. So we could do that using the square brackets, and we need just TOML and YAML like that. And that will install everything we need. I have everything installed, so it's just going to come up and say that. But as you can see, we have Msgspec, where is it? It's somewhere on it, 0.18.6.
and then we take TomlyW 1.0 and PyYAML 6.0.1 as our dependencies. So using Msgspec is really quite easy regardless of which standard you're using, because there's a consistent interface between the three languages. So if we do import Msgspec here, we can use msgspec.json. We also have msgspec.toml. We also have msgspec.yaml, and then we also have msgspec.messagepack. And I'm saying the word message so much that I can barely say it anymore, so sorry about that. But these are the four standards that it supports. JSON, you've probably heard of. TOML is typically used in configuration files. YAML, much the same. Messagepack is one that I hadn't heard of until Msgspec came along. It seems to me like it's just trying to be a condensed down version of JSON. So it's a bit smaller, but it's a bit longer to encode and decode from what I've seen. We're going to be largely focusing on these three, but if you're interested in Msgspec, you can do your own research into that. So if you wanted to encode a dictionary into a JSON file, so if you want to do the equivalent of json.dumps, that would be msgspec, or you could do data equals msgspec.json.encode, because we are encoding it into a JSON string. And then we can pass, say, a 1 and then B2 as our data. And I'm actually going to save this as a dictionary called D. Because that makes things a bit easier. And this data here, if I run this now, as you can see, a byte string. So this is, so JSON.dumps returns it as a string, I believe. Encode interprets it as a byte string. That doesn't matter too much, but you do need to make a few changes when you're writing it into a file. You see it does a byte string of a minified JSON file, as you would expect. If you wanted to write that into a file, then you would need to do with open, and we could just say output.json WB, so write in bytes mode. That's very important. As F, and then you would just do f.write as you would otherwise, and then we can do this, wrap that in brackets, get rid of this line, run it again. We can see we have this output.json file, and this is now just, you know, a normal JSON file as you would expect. If we wanted to then decode that, then we could do that. So if I just copy this and paste it here, and then we open it in read, I think it needs to be in bytes mode, I don't remember. And then we can simply just do msgspec.json.decode. So we're now decoding it into a dictionary, and then f.read. And then actually, if I print that to the terminal, and then do PyScript again, we could see that our data is exactly the same as we encoded it in the first place. And the good thing about this is that when I was showing you the TOML, the YAML, and the Msgspec things, they all have exactly the same interface. So if you wanted to open this, well, let's say if we wanted to output.toml, and we wanted to encode our dictionary as a TOML file, we could simply just change this to TOML, and then we have our output.toml file, and then suddenly it's in the TOML format. If we wanted to do in YAML, we could do that, and then suddenly we have this output.yaml, oh sorry, it's gone to output.toml. I didn't change that. Output.yaml, and it's a YAML file. And if we wanted to do Msgpack, and I think the file extension is typically Msgpack, we could do something like that, and it outputs into, you know, this Msgpack format, which is just a normal binary format. And that's the real beauty of Msgspec, because if you have a program that reads a configuration file and also works with APIs, which is not as far-fetched as it might sound, having one tool that can do them both with a consistent interface is really, really nice to have. It is also much faster than the built-in options as well. So I have benchmarks, and I'm going to set them going because they will take a while, and then I'm going to show you what they're doing. So we have this benchmark file here. So we load the data, and we have it in, you know, text data and then just the actual data format. And then these tests are a series of tests. So we have dictionary pairs that are all processed by this function down here, which is why it's a weird format. The top one is always the Msgspec one. So we have the actual code that's run, we have the setup and then the data. And then we have the non-Msgspec equivalent, which forms the name of the test, which is why it's the second one down. It's just the way it's implemented. So we have decoding and encoding tests for JSON. We then have OR JSON as well, which is the fastest JSON encoder and decoder. We then have toml using the third-party toml library. We then have toml lib and toml again. And then for YAML, we have PyYAML with standard loaders and then the C loaders as well. And once these tests are done, as you can see, it just repeats the test down here. It will print a table that you can see here. If I've gone all out for this, as you can tell. And it prints the test name in this column here, the amount of time it took this code to run in microseconds. So do keep that in mind, this is in microseconds. And this is an average taken per run. So this is not the total time it took the test to complete. This is how long, on average, one iteration took to complete. We then have how long the Msgspec equivalent took, and then we have the speed up as well over here. So in the normal JSONs, we could see that Msgspec is 2.8 times faster at loading and 7.5 times faster at dumping, but it is slower than ORJSON ever so slightly. So do keep that in mind. If you're only working with JSON, ORJSON might be the better option. We then have toml tests. You can see actually it's the same speed as toml lib, which is the built-in one. And you kind of get an idea how things are implemented sometimes, because looking into it, Msgspec just uses toml lib under the hood to load. It is actually slightly slower at dumping data than toml. So toml is really where Msgspec falls down a little bit. It is faster than the third-party library at loading toml data though. So potentially, but then you have toml lib. So if you're below 3.11, it is faster. Otherwise, it's really not. The YAML, you can see that it pretty much just uses the C loader and C dumper by default, which is nice. You don't have to deal with YAML's horrible interface or PyYAML's horrible interface. The normal loaders are very slow, as you can see, 8.3 times speed up here of Msgspec. But that is because it's using the C loader by default. So you can see that individually, Msgspec doesn't necessarily have much to offer in terms of speed, but as a collective tool to handle everything, it is really nice to just have one tool that is fast at everything, because everything is quick. Even if it's not the absolute fastest way to do it, it's also the API considerations as well, because PyYAML's API and PyYAML's documentation are atrocious, and Msgspec just makes it so much nicer to deal with. On top of all of that, it also has Pydantic style structs. So if we'll do all the imports we need first. So if you do from typing.Annotated, then we import Msgspec, and we do from Msgspec import meta struct and field like that, and it's thinking I want to do Pydantic there, and then we could just create a struct using these structs or by inheriting from structs. So we're going to create my favorite profile example, and then we're going to have a name, which is a string, age, which is an int, and then jobs, which is a list of string, and we can actually set that using this field to default factory equals list. So that works exactly the same as it does in dataclasses, exactly the same as it does in Pydantic. There's no surprises there. And if we were to just get away, it keeps thinking I want to do Pydantic code. And if I just set this up like this, so we have p dot equals profile, and then we can just pass in my name and then my age. And if we print p like that, we can see that it works exactly the same as a data class. This jobs has sorted itself out. It has all the string representations and everything on top of all of that. But if we then print dear p, there we go. One day I'll learn to type, I promise. We can see that it just has age, jobs, and name. It doesn't actually have that much to it. And I can't remember if data classes is this light, but you'll notice, especially compared to Pydantic, there is a lot less going on. And this becomes apparent if you want to encode or decode structs to and from JSON, toml, YAML, or Msgspec, because there isn't anything in the actual struct to do it. So instead, if I just get rid of that, you'll need to do, we'll do profile data equals Msgspec.json.decode, or encode, sorry, and then you pass the class to it. And then you can do that. And we can see that it's encoded in the same way as we did earlier. You could, of course, very easily, and I'm going to copy paste this in. You could, of course, do this. So you could create an encode method of your own, and then you could just say Msgspec.json.encode self,
and then just encode that, and that'll work fine. So it's not the biggest deal in the world. You could create your own base model to do that if you wanted to. Once you actually have this profile data, you can actually decode them back into these structs. So if I do p2 equals Msgspec.json.decode profile data, and then we pass the type to profile, and this tells Msgspec that you want to decode into a struct rather than a dictionary. If you don't do this, it will do it to a dictionary by default. And if we print p2, we can see that it's exactly the same as the original P because it's decoded it perfectly fine. What makes this more than just a data classes clone, though, is that you do actually get validators, but they work quite strangely. So this is why we have annotated up here. So say if we wanted to validate whether age was a positive integer, so it has to be, well, not negative, so 0 or greater. We could use annotated, and then we pass int, and then we, not field, we use meta, and then say this meta has a number of arguments that we can give. So we are using the greater than one, or GT, and we pass it 0, so we want it to be greater than 0. And what this is doing is it's using the annotated, and I don't fully understand how annotated works. It's magic as far as I can tell. But it's an annotated type of type integer, and then this meta type is run when the constructor is run. And then it runs this to make sure that our thing is greater than 0. So if I just comment all this out for a second, if we run that as is, we can see it still works perfectly fine. If I'd then change this to -1 or -1, that hasn't worked. Why has that not worked? So it hasn't worked because I've just learned something new. When I was testing this, it came up with this validation error as I was expecting, and I presumed it worked in the constructor. No, it only validates in the decoder. So we've got this profile data here, which you can see we've encoded from a normal thing as -1. If we then try and decode that back into a profile, the validator then kicks in and we get this validation error. So the validation, while it's there, is not as strong as Pydantic's. Although in Msgspec's defense, I'm not really sure you're supposed to be using profiles like this. Of course, I have a benchmark for this as well, which just performs a very simple check between Pydantic, which has pretty much what you've seen before, and then Msgspec. The only difference is that we pass this keyword only equals true argument to match it more up to Pydantic's general or default behavior. And then we just run the test down here, and then we print, we do some decoding with the various APIs, and then encoding with the various APIs as well. So here's the decoding here. And as you can see in our table down here, that Msgspec is 5.7 times faster at decoding this very, very simple example. I will hasten to point that out. And 6.5 times as fast at encoding. I will put a link down in the description for Msgspec's official benchmarks, which go into a lot more detail, especially when it comes to JSON serialization and deserialization libraries, as well as other libraries to do validation. So I think it compares Atras, Pydantic, maybe dataclasses, and a few others as well. Msgspec comes out very much on top of all of those. Apparently, Msgspec JSON encoding and decoding using structs is actually quicker than OAuth. I haven't tested that myself, but feel free to test it out and let me know what results you get, because I'd be interested to know. Let me know whether you're thinking of converting to Msgspec from your... Descriptors are a hugely important part of Python. In fact, a huge chunk of it is built on descriptor logic, like properties, methods, the superclass. So why does nobody really know what they are? Well, it's probably because their use case is generally quite advanced and their purpose isn't particularly obvious just by the name. However, once you know what they do and how they work, you start to see that they are so useful, and you start to see actually more how Python is built. So in this video, I'm going to be explaining what descriptors are, and I'm also going to be showing 2 perfect use cases for them. Of course, if you find this video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. With all out of the way, let's demystify one of the most mysterious parts of Python. At their base level, descriptors are classes that implement at least one of the methods in the descriptor protocol. So that is the $get, the $set, or the $delete methods. And these methods control how classes work when they are attributes of other classes or instances. And if that doesn't make sense to you, then don't worry. We're going to be going over some use cases of descriptors. To give you an idea of how difficult this can be, this is actually my third take at recording this video. So it's not easy to explain either. But we're going to start with the first of our two use cases, which is a strongly typed, lazily evaluated class-based configuration system, which is a lot of buzzwords, but it should hopefully make sense when we actually get into it. So we're going to create a file, not called that. We're going to call it config.py. Not, oh my God, not called that. We're going to call it config.py. There we go. I managed to gaslight myself there. And then we're going to create a setting class, which we're going to pass for now, and a config class. And this config class, we're going to have settings in. So we're going to have, say, test, for example, is going to be of type setting and is going to have a key, in this case called test, and then a default value, which we're going to call test. And this will simulate getting an or a variable from an environment variable or maybe an AWS parameter, something like that, where a settings value has a key and a value. So our test will be the key, and if the value cannot be found, then we have a default as well. So to do that, we need to do def init self, and then we have a name, which is a string, and then we have a default, which is also a string, and that is going to return none, and then we have self.name equals name and self.default equals default. And that's easy enough, but if we were to create our config class now and print config.test, that was from a previous previous take, we will see that we just get the setting object back, which is not particularly useful. Admittedly, we haven't actually created any logic to get the variable, but if we were to set a property, say of value, or if we had a fetch method or something, then we would need to call it here in order to be able to get that information. And that would defeat the whole point of doing this, because it would then be eagerly evaluated. What we want is for this instance to just magically become something else. And that, in its essence, is what descriptors do. So we can define our def dunder get, and then we take that as self, and then we have an object, which is of type object, and we have object type, which is a type or none equals none, and that is, in this case, is going to return a string. And don't ask me why this can be none. I've never seen an instance where this can be none. The Python documentation just always uses this signature, so that's what we're going with. And we do actually need to import OS. And we're just doing this for now. We have os.environ.get self.name, otherwise we get self.default. So this will get our self.name, or maybe this should be key. I think this should be key, actually. No, I'm looking at it. So we have a key, so we get our environment key. If the environment variable doesn't exist, then we get the self.default value instead, which in this case is test. And now if we run this, we can see that we get test back. And if we print type config.test, we get a class of string and not the setting instance. And that's because this dunder get pretty much overrides the class, or I suppose instance behavior, when it is an attribute of another class or an instance. So we have this dot test here, and this dot means it's dot accessed. Test is here, we go to the settings instance, and then that calls this dunder get. Now by default, this will just do self. I'm not sure if that's actually defined by default or not, but that is the default behavior. We are instead overriding that behavior to return, in our case, a string, and then run this logic os.environ.get. And then because this is a string, if we were to highlight over config.test, we can see that statically it is always a string. So that is our strongly typed criteria satisfied. We can also prove that our lazily evaluated criteria is satisfied as well by printing getting here. If we print that, we can see that we get it twice. We get it once when we actually print the variable, and again when we actually ascertain the type of it. So we expect in this particular instance to get it twice. If we were to get rid of all this, we could see that nothing prints at all. And that's because just creating the instance does not run this done.get. This done.get only runs when we access the variable, and as such in our config system, we only get the environment variable when we actually want it. And so our lazily evaluated criteria is satisfied as well. Stepping away from descriptors themselves for a second, if we did want to enable the ability to get config options eagerly, we could do something like from functools import cached property, and then we could have a property like I was saying earlier called value, and that is self, and that returns a string, and that just has this logic like that. And then we can simply just return self.value out from there. And now what this will do is it will cache, it will just call self.value, and self.value is a cached property that has this logic in it. So now you can either do .value here to eagerly access the setting, and that will set test to just a string. Or if you didn't do that, then you have a descriptor, and then the value would then be called when you accessed it later on. Configuration systems like this are a really good use for descriptors, especially class-based descriptors, as I guess I'm going to call them. But they're not the only use for them, because we haven't really talked about what happens if config was an instance. And there's a better way of doing that, or there's a better way of showing that, and that's by showing that you can do validators with them. So if we create a validator.py, and then we create a person, and this person is going to have a name and an age. Simple enough. But it's also going to have an age class attribute here, which is an age validator that we're going to define ourselves in a bit. And then it also ideally needs at least a type declaration for a private attribute. You only need to do this if you are doing strong typing, but I generally recommend that people do. So we're doing that. And then we can define our age validator up here. And of course, this will be a descriptor. So we have our done.get with the same signature, and then we just get the done.age from the object. So this object here is this person class. And because we actually know that in this instance, we can set this to person. So this object will be the person instance. The object type will be the person class, which is important to note. In our config system back here, this object type was the config class. I didn't talk about it then because we didn't really need to know about it. But in here you have the person instance and then the class. You can also do def dunder set, and the AI is kind of spoiling what I want to do here. And that will take self, and then it will also take an object, which in this case is also a person, and it will take a value. I'll just let it complete, which in our case is an int. Generally speaking, this can be anything depending on your exact situation, but in our case, age is an integer, and so this value will be an integer, and that returns none. And we can use that to just set this done.age attribute here. So you can think of descriptors in a way as properties, and in a weird way, we have just created a property because we can do the same thing as properties, and believe it or not, properties are just descriptors. So actually, we are more or less implementing a property here, albeit a very simplified version of one. But of course, we don't have any of our validation logic, so we can implement that now and say if value is less than 0. I prefer the phrasing age must be positive. And now, if the value that we pass through is less than 0, we get this value error when trying to set age. And the reason this works is because we have this class attribute called age, which is an age validator. And then we have the instance attribute that we're getting that will actually just grab the class attribute. So self.age will just grab the class attribute if there is one available. And then we set it to age, which is an integer. But because age is an age validator, it looks up here and thinks, oh, we have a done.set, and then it runs this instead of whatever the default behavior would have been. I'm not actually sure what the default behavior would be if it wasn't a descriptor or if this wasn't here. In terms of code, obviously, it would just replace one thing with another. I don't know how that would look in terms of code. But if we were to run this down here, so if we did if name equals main, and then we do a person, and then we just print the person.age for prosperity, I guess, and we run that, you can see that because we set the age to -10, it doesn't like it, because we then run into this value error when we try and set it, saying that age must be positive. So, okay, we set positive age. But now we have the person.age, we could set the person.age equals -10, right? Well, no, because when you set it from here, it calls the set on this validator, which then just runs this validation script and then runs this as well, and then sets it if it's fine. So we can see when we print this person.age, it's 10 up here, but then if we try and set it back to -10, it complains. So validators are another really cool and useful use for descriptors. I do want to show one more thing off before I go. So I want to show the def set name dunder. Now this is completely optional. You don't have to do this. We have the object again, and then we have, no, we don't actually. We have an owner, which is type, and then we have the name, which is a string, and it returns none. And then we can use this to create other things. I'm not 100% sure where exactly in the stack this gets called, but we can use this to set a private name to be an underscore and then the name. And we can use this to create more dynamic, more generic descriptors. So instead of returning object.dunderAge, we can instead do get attra object self.private name, or we can do something that I here with the set attra and then object self.private name value. And this name here is set to the name of the actual attribute. So in this case, name will be age, private name will be dunderAge, and that matches up to this. And we can now change this to whatever we want. So we can change this, and we'll show it works first. There we go. We can change this to, actually, you know what? To show this off even better, we're going to change this error message to be self dot. We'll just set the private name for now, whatever. We can set that, and we can again show that it's working, and we have that down here. If you were to set the age to be years, so for example, when we had self.years, and then we print person.years, and then we print person.years down here, we can see that it's now dunder years, or not dunder years, underscore years, and that's because this set name has seen that this attribute is called years. It's set our private name accordingly, and the rest you can see. Of course, this does throw up some typing conflicts, so we are returning int from here, but getAttra won't actually know that we want to return an int at this point, because it won't know about object.dunderAge. So if you wanted a more generic abstracted thing, then you could do something like this. And I'm not going to cover this in an awful lot of detail, but we have a generic and we have the ABC meta, and then we set the dunder set as an abstract method. And then what we can do here is we can set the set logic of age validator to be what we want, because the get is probably always going to be the same no matter what validator you have. And we can use type vars and cast to bring type safety into it. And we can extend the validator however we want. We could even extend age validator. You can see that it's expecting an int, and it's all type safe and everything. Again, I'm not going to go into a huge amount of detail on the typing of this because descriptors are complicated enough. If you do want to see this, I will leave this in the GitHub repository down below. So if you want to take a closer look at how to do all this, then you can. But for now, I'm just going to go back to the slightly nicer. Well, that's the slightly nicer one. That's not much nicer, actually. Let's go back to the config. There we go. That's a bit more friendly looking. So that is hopefully descriptors demystified. They're not actually as complicated as people think they are, certainly as I thought they were. Once you understand what they do and what they're for, they're actually really easy to visualize. And it's important that you do kind of understand this, especially if you want to get better with Python, because vast swathes of Python are built on top of descriptors. Like, huge amounts of Python are built on this logic. So it's a really good thing to know. Let me know in the comments what you plan to use descriptors for. Every now and then, especially in testing, you may come across a situation where you need to do something on disk. However, sometimes you might not want to actually save that result. And this is where temporary files come in. Operating systems all have their own way of dealing with temporary files. For example, in Linux, anything in /temp is considered a temporary file. And of course, you can open and work with temporary files in Python as well. However, just using the open built-in with /temp and then your path is not the most secure way of doing it. I'll leave a few links in the description talking about the security risks in more detail. But thankfully, Python provides inbuilt mechanisms to open and work with temporary files a lot more securely. And that is what we're going to be looking at today. So we're going to be working with the temp file module today, and I'm going to be showing you how to open and work with temporary files, as well as how to create temporary directories. Of course, if you find this video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. But with all that out of the way, let's get securely creating these temporary files. Because it's part of the standard library, we don't have to import anything, which is quite nice. So we could just do from temp file, and today we're going to be looking at named temporary file as well as temporary directory, and I'm also going to import from pathlib path as well, just to help out some things. So we're going to start with named temporary file first, and what this does is essentially just creates a file in the right place with a name that's incredibly difficult to guess, and then performs all the cleanup operations for you. So you could do with named temporary file, and then we'll take a look at some of the arguments in a bit. And then we could set that as f. And then here we could just do print f.name. And then to kind of show it off, I'm going to do temp path equals path f.name. And then we're going to print temp path.is file. And then we're also going to do temp path.exists outside of this block. If we do that, we can see that this is the name of our temporary directory. So on Mac at least, it does it in /var/folder/1_ and then comes up with this crazy name /t and then this crazy name afterwards. We can see that it is a file because this is returning true. And we can see that after the context manager exits, or after the context block exits, it doesn't exist because named temporary file cleans it up for you. And one of the things that it showed on here was suffix. So if you wanted to say .txt, for example, then you could create a txt file in there. And you'll note in the suffix, you do have to include the dot. If you don't include the dot, it won't do it for you. So do keep that in mind. There are also a few other options. So you have prefix as well. I don't actually know what prefix does. I guess it would just prefix it, but okay, yeah, it literally just prefixes it. Oh, it changes. Is the prefix temp by default? Let me see if we can. Oh my god. Let's see if we can find out. Oh, I don't know. I'm not looking at that right now. I think the prefix is temp by default. And if we get rid of this, so if we make it just T, yeah, there you go. I think the prefix is temp by default. Okay, so that just changes that. Have the suffix, as I say. You can then choose whether to actually delete it or not. So you can set delete equals false. You can put it in a directory, and we'll talk about that in a bit. You can also give it a new line character, I guess. You can give it an encoding mode, a buffering mode, and you can change the mode that you write to. By default, it opens in, I think, write plus binary. I think the write plus means it appends. Don't quote me on that. But on top of we'll just leave that like that. On top of that, you can also do with temporary directory. If we set this as D, we could do print D. And then if I do much the same thing as I did here, not like that though. And if we do path D instead, and then is directory, and then we see if it exists afterwards, we get this back. So yeah, it puts it pretty much in the same place. But we get true because it is a dictionary, And then once again, the directory is deleted at the end, and it's then false. If you wanted, you could swap them around. We'll actually do a separate example, I think. So you could do with temporary directory as D, and then if we used the multi-context block, name temporary file, and then we'll just set dir equals D as F. If we then just printed f.name, we get, actually if we print D as well, we get the directory down here, and then we get a temporary file within our temporary directory. So that is what the dir flag does. You would probably want to create a temporary directory and then create a temporary file within that directory if you were doing that. Again, the directory has a few arguments. So you have the suffix, you have the prefix. You can also put this temporary directory in another directory, so you could chain them together. Ignore cleanup errors, which is false. And again, you have your delete parameter here to say if you don't want to delete it, you don't have to, though it is heavily recommended that you do. These are the two main ones you're likely to use. There is temporary file as well, but to my knowledge, if I just get up the help, it doesn't create like a file actually on the disk, or at least name temporary file ensures that the file will be on the disk. I don't think temporary file comes with that assurance. So let's see what else there is. I've only used those two in the real world. So you have, is it not going to give me a... Okay, import temp file, and then just do temp file dot. And then you have all these, like make temp, for example, is one that's in here. This is also not secure, so it's not recommended you use that. And I imagine these two aren't secure either. And have some gets here. Spooled temporary file. I think that is that for streaming data? Specialized to switch from bytes IO to string IO, or string IO to real file where it exceeds a certain size or when a file number is needed. Yes, that does. I'm not sure where you'd use that, but that's a thing there. And then, yeah, there's not much else in there. Yeah, name file and temporary directory are certainly the two that you would use the most. Now, the reason I'm making this video is because I actually had to use both temporary directory and name temporary file recently in the real world. I'm having to use a lot of things I've never used before in the real world in the last few weeks, to be honest, including descriptors, which is where that video came from. But this involved testing something in the command line interface, which is notoriously difficult to test. And it actually needed files to exist on disk in order to work. So it was a function that made a subprocess call out to Alembic. For those that have never heard of Alembic before, it works well with SQL Alchemy and is essentially a database migrations system. So if you use SQL Alchemy for anything, you would probably use Alembic for migrations if you were using it. And essentially, I just needed to test that worked because we had an entry point as part of a script. And to test that it worked, I wanted to check that the command line interface was actually being called. And of course, it would need all these other files to work. And so I created a PyTest fixture called Alembic INI, which then did all this. Did all this for you. And this is where I'm going to show how to actually work with these temporary files as well. So as you can see, we have the pytest.fixture and it was called alembic.ini, and it returns an iterator of temporary file wrapper. That is important because that means that any test that uses this fixture will have these files available, and then when the test ends, it will pass back into here, and then the files will be deleted. So PyTest fixtures are really good for that. So we create a temporary directory as D. We create a name temporary file with a suffix of .ini, and then we set the Alembic config environment variable to that path, just so Alembic knows where it is. You can then set some content. So in this case, we actually had to use a format string. And then you can actually just write to this file as you would. So you can write to temporary files. This ini.flush just sets the I'm not actually sure what you call it, the pointer or the buffer. It sets it back to the start of the file. It is exactly the same as doing this. So just seek to the very start of the file. That's what that does. Whether that's a byproduct of something else it does, I'm not sure. But let's see. Or not, because I'm not going to get anything useful out of that. And then we have just a file called env.py, an empty file that we create within the temporary directory. So this file will also be destroyed once the temporary directory is destroyed. And then we yield the name of the file back out so we can pass it as a config parameter. And as I say, when your test is complete, so you might have a test like test alembic, I don't know, test invocation, there you go. And then you have the alembic.ini fixture like that. When this runs, it'll create all this. And then when the test ends, so once we've asserted that alembic ini is a thing, the test is over, it comes back into here, it exits this context block, and then all the files are destroyed. So if you do absolutely need to work with files in tests, then this is the way to do it. Ideally, of course, and this is starting to get a little bit off topic, if you're in a test and you need to like test some file operations, if you can avoid file operations on disk, do. So if you can override, say, path.exists or path.readbytes to just return a set value that you do in the code, then do that instead. But yeah, if you absolutely need to work on disk like I did here, then this is how you do it. Let me know in the comments how you plan to use this in your projects. Generics are a very powerful component in Python's type system, but not many people know how to use them. In short, they allow you to create generic classes where you can use a specific type structure as a template and then specify more detailed types in specific situations. And this allows you to have one interface that supports multiple types. You can also get really clever with it and actually create a class that is able to introspect its own type based on the variables you pass to it. So in this video, we're going to be learning what generics are, and we're also going to be covering a simple use case as well as a more complex real-world example. Of course, if you find the video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. But with all that out of the way, let's take a look at the power of generics. To try and explain generics as best I can, I'm going to go through two examples. The first of which is a much more illustrative example than an actual useful example. And the second is a much more useful example, but also quite an extreme example to really show the power of how you can use these things. But first, I want to do a quick primer on type vars because they are going to be necessary to understand what's going on. So if we create a type vars.py, yeah, that's fine. And then we could do from typing import type var and then t equals type var t. And what this means is that this can be any type, but it's quite special in the fact that it inherits, quote unquote, types from other places in the signature. So it's sort of a dynamic type in a way that is used to do static typing, which is an interesting way of doing it. But the easiest way of showing this off is to create an echo function, which takes a variable of, we're actually going to use value of type t, and then it just returns the same type. Because it just returns itself, it will take a value of type t, and then it will return a type, it will return a value of type t because it's just returning itself. And now if I were to say x equals echo 2 and y equals echo string, so the type system is able to work out that this number 2 here is an integer and this string is a string. If we hover over x, we can see that x is considered an integer and y is considered a string because it can see what type is being passed in from here, and we're saying, okay, that must be type t. So when we call this, t becomes an int. When we call this, t becomes a string. We then expect to return the same type out. So this also becomes an int or a string, and we realize, okay, we are returning an int or we're returning a string. And that's the simplest example to show off what type vars do. You can also, if you really wanted to, bind them to something. So if we were to say bound equals int, then this will complain because the value that we pass in to echo must be a subclass of int. So we can pass another int in here. Weirdly, we can pass a ball in here and that'll be fine because balls are subclasses of ints. That's not strictly necessary to know for generics, but it's probably very helpful to know if you're doing some more advanced stuff. So if you move on to our illustrative example, and we're going to call this fruitbox.py, and then we're going to do from data classes import data class. We're just doing that to save time. And we're doing from typing import generic and type var. And then we set t, which is a type var of type t. And then we're going to have some items that go in a box. So the example we're going to do is we're going to have a box, which is a generic type, and then we're going to be able to put items in it. And it will be able to say, using the generic type system, which type we want to put in it. So we can do a data class, and we can do class apple, and we'll just give it a name, which is a string of apple. And then a data class of, well, use banana, because that's my favorite fruit. And then we'll have a class called box, and this is going to inherit from generic t. So this is the quote-unquote old way to do it. It's also, as far as I'm aware, the latest. Also, as far as I'm aware, MyPy only supports Python 3.12 generic types in the latest version, which is unreleased at present. If you were to do it using the new system, you could do box t like that. Actually, we might see. Are we going to get away with that? No, we're not. See, PEP 695 generics are not yet supported, but that's how you do it using PEP 695. I will leave a GitHub link in the description with the old way of doing it, and then other files with the new way of doing it as well, so you can compare the two. And if we were to say create an init and then have self and then return none, and then we do self.items equals an empty list, and this is going to be a list of type t. And then we can define add self.item t, and then we can define, no, not len, def remove. There we go. So now we can add and remove items to the box, and notably, the item will always be of type t. Now, of course, we don't actually know what type this is yet, but we could say, if we do if name equals main, there we go, that box is a box of type apple, and then we can instantiate it like that. And what this is now saying is that we want our box to only contain apples. So now apple will be t, or t will become apple in this case. So by process of elimination, we could say that self.items is a list of apples. When we want to add an item, we want to add an apple, and when we remove an item, we want to remove an apple. So we could do, let's call this apple box, and then apple box dot add. I cannot type today. Apple. There we go. And the type system is perfectly fine with that because we're adding an apple. If we were to have a go and add a banana to the box, the type system would complain because argument 1 to add a box as an incompatible type banana expected apple. If we were to change this here, we would see that it would now complain about an apple being added to the box. And this is because the generics allow you to specify the type as you create the class to be able to create more generic and therefore dynamic types. So if we set this back to apple, and we go for another example, we can set banana box equals banana box, which we need to define. So if we define banana box as box banana here, and we could just pass this because we're inheriting from box, but notably, we are setting the generic type within our inheritance. So we're now saying that instances of banana box will always be a box and t will always be banana. So it will always contain bananas. And then we don't have to define it down here. And if we were to do banana box to add banana, it would have worked fine. If we were to do banana box dot add apple, it would complain because it expected a banana. So those are the basics in how generics work. They allow you to create more generic classes in that they can work with any type. But this does, unless you subclass the generic type, force you to actually specify the type down here, which is fine sometimes, but it is a little bit annoying if you don't necessarily have to do it. There are ways to create a generic type that will be able to automatically infer the type that it should use based on the way it was constructed. And that is what I'm about to show you next. Before we move on to the next example, I just want to say that it is quite an advanced example. It is probably one of the more advanced uses for generics you'd come across. I wanted to talk about it, one, because it was the example I had in real life, and I like to put real life examples in these videos. And two, because I wanted to show the sheer power of generics and how you can use them to do crazy things. But I just wanted to jump in and say, if you don't fully understand it, then honestly, don't worry about it. So to save on a bit of time, I have created our generic class already. So a bit of a run through about what this does is very similar to the example I showed in the descriptors video, except it's not a descriptor. Don't worry. I haven't done all that in it. But it's a generic class called envar. And basically this value down here, when you create an instance and then call the value, it will get an environment variable of self.name, or if it can't find it, it will use self.default if provided. If a converter has been supplied, then we can return the type of t, and then we can return the converted value. So this will allow you to convert, because environment variables, keys and values must be strings. This is a mechanism that allows you to convert them to ints or bools or something like that. Or, and if there isn't a converter, we just return the value. And then we take self.name, self.default, and self.converter as variables. The converter is a callable that takes a string or none and returns type C. So this will be the type that we want to convert to. And that will be, you'll see how that's used in a little bit. Down here, we also have a function that can convert it to an int, and then we pass that in here. And if we were to look at value right now, we would see that Python doesn't know what the type is. It knows that it will be a type based on envar, but it doesn't have enough information to be able to infer the type. If you were to give it a type like int, then value would be recognized as int because we've already set up everything. So we return type t, we pass type t in here. If we set this to be an integer, this will return an integer. But there is a way to make it understand that by introspecting the function's signature, and that is by using overloads. So if you've never used an overload before, you can specify multiple possible function signatures for a specific function using overloads, and then you can have a master function of sorts, which will be this, that actually implements what we want to do. So to do that, we can do overload, and you can use them on methods, and you can, crucially, in our case, use them on class init methods. So there are 3 overloads that we want to do. So we want to do an overload of def init self and a name, which is a string, and then that will return none. And then we don't need to implement anything, so we can just use ... And then we also want to do an overload def init self name string a default, which will also be a string, or none. And we'll just leave it at those 2 for now. Between these 2 function signatures, we have this default mechanism down, because in this function signature, default will be none. In this function signature, it'd be string. So we have all this here. If we were to look at this now, oh, sorry, I haven't actually done everything we needed to do. There's one more thing we need to do, and that's actually to type hint the self parameter, which is not something you would typically do. But if we were to say set env_var as string or none here, and say env_var string here, what we're saying is that if a default isn't provided, then the name may or may not be an environment variable. And as such, this the envar will be string or none. If we do provide a default, there's no way that we can return none out of value, because if the string isn't there, we'll use the default, which is a string. So we can say that self is envar of type string. And now if we look down here, we can see that this without a default is registered as string or none, and this with a default is registered as string, because it will always be a string in that situation. As far as the converter goes, we can go even further and specify a third overload. So we want to do overload def dunder init self. We'll leave that alone for now. Name string default is string or none in this instance, because we don't care what the default value is. And then we can specify a converter, which will be a callable of string or none, and it will return C. And then the callable is optional, so we can say or none, and then by default it's none. And now we've satisfied everything down here as well. And that matches up with this function signature here. So we have a callable that takes string or none, and in this case, C is int. So that follows on from our type var example, where we pass int in here, and T gets set here. We provide int as a return type here, and that gets set as C here. And you can actually set env to use the generic type of C. And then it will complain because I've put it on the wrong one. That was good. I meant to put it up on the overload. So you wouldn't need to put it down here, but you would want to put it on the overload. And now this function returns int. So you can see we take a string or none, it returns int, and value is an int. If we were to change this to bool, which works out the box, weirdly int doesn't. I spent such a long time, I think it was last night or the night before, trying to make that work, and I just couldn't. So if anyone does know how to make that work, do let me know. But if we set this as bool, then we can see that value is now a bool. And we can now provide a converter to our environment variable, and the static type system will know what the type will end up being, because whatever we do with this converter, it will always be converted into a bool, because the value from this function, as well as the self.default, will be converted. So we can only ever return a bool out of this, and now the type system knows. So yes, this is perhaps a much more complicated example than I would normally give, but I did want to show the sheer power of generics and just what you can do with them, and that you can manipulate the type system, especially using overloads, just by setting what the function signature expects. And it's just a little bit of magic that you now know how to do. Let me know in the comments what you plan to use generics for now. I've seen properties described before as Python's most powerful decorator, and I'm inclined to agree. It is a shortcut to a very advanced part of Python that allows you to get incredibly creative with how you work with class attributes. For example, it's probably the closest you can realistically get to private variables and protected variables with established patterns. It's also capable of allowing you to set computed attributes that don't have to be manually set up every time, as well as allowing you to set custom logic when setting an attribute, including validating it. So in this video, we're going to be covering some of the use cases for properties. We're going to be seeing how they're used, but we're also going to be taking a look at how they work and the insides of properties, at least as far as pure Python equivalents are concerned. Of course, if you find this video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. But with all that out of the way, let's get the complete lowdown on properties in Python. There are a few different use cases for properties, and I'm going to show you the two most common today. So the first is managing private attributes, similarly to how you would do in maybe C or C#, where you'd have a private attribute, and then you would have a getter and a setter method to then actually fetch or set the value. We could just do that in properties in Python. So we can do class say profile, and of course we're going to do my favorite example, self, and then you have name, string, age, oh my god, age int, and then we'll have jobs. I'll just have job string. I can't be asked to do anything more than that. Self.name equals name, self.job
equals job, and then we're going to have self._age down here, which is a private attribute. I'm doing air quotes. You can't see that, but I am. So this is not intended to be accessed by the user at all. But we can specify a property which will actually fetch this variable. And if you were to do something like this, it would give you a read-only attribute of age. So people could, if they knew what they were doing, still access _age if they wanted to. But if you wanted to set an interface where you say, okay, we don't want the age to change, we just want to set it as a read-only attribute, you could do so with this. Once you've defined an attribute as a property, you can also use this to create setters and deleters. So a setter is done by the name of the function and then .setter. And then you have to have the name of the method the same as the name of the property. Otherwise, it will complain at you, saying that the type system just won't know what to do. I'm not really sure why that happens, because in normal Python, that's not how things tend to work. But I'm guessing because properties are implemented in C, it does some weird fancy stuff, probably. But you could just use this to set the value if you wanted, or you could use it as a validator. So you could say if value is less than 0, then raise age cannot be negative, like that. And then if this condition passes, you then set the value to _age. So now you've set an age that cannot be set to less than 0. Unless, of course, you set the age, the dunder age up here. But again, intended interfaces and all that. You then also have a deleter, which I've actually never used in the real world personally. But this is called if you were to call del on an attribute. So if I just do this, for example, and I'll explain it once I've got the example code on here. So if you do if name equals main, and then we do all this, it kind of knows what I want to do. I am 25, not 22 though. So we create a profile with my name, my age, and my profession. We then print my age here. We then set my age to 23. Let's set that to 30. And then print that. And then we del the age, and then we print that. So this is what I meant with the deleter. It's called whenever you call del on the property. And if you were to run that, that was planning stuff, ignore that. We can see that the age no longer exists. Because we've deleted the property from this. Weirdly enough, you actually get this error saying profile object does no attribute _age. Did you mean age? That's what I tried. So yeah, that's a weird behavior. I'm not sure how commonly people really use that. You can change this to do whatever you want though. So you can say self.age equals 0 if you wanted to. And now if I were to print that, when you delete the age, it sets it to 0. So this may be useful if you had things that could be reset or unset, or if you had maybe something in a database, if you're using properties to run an ORM, then you could use del to delete a record, for example. There are a few use cases. I've never really used deleters in the real world though. The other use case for properties is to use them as replacements for methods if the particular calculation or computation would have no input arguments. So if we come to this file here, we can do import datetime as dt. And if we set a slightly different kind of profile, we have def init self, name string, and then we set the birth date rather than the age. Birth date equals dt.date. And we set self.name equals name, and then self.birthdate equals birthdate. And then we have a property down here that can calculate the age. And this will be self, and it will return an int. And this calculation would be that divided by 365. And now we have a property that can be accessed just like a normal attribute, but that isn't set. It's taking information from elsewhere and performing a computation on it. So if we do if name equals main, and then do that, let's set it to my actual birthday, 1998, September the 22nd. If we print calc age, we can see that the age comes out as 25, which is accurate. But we haven't got any private properties around. We don't even call this as a method. We just, assume that it's an attribute. But this is then computing the value without having to store it elsewhere, which is really nice for lazy evaluations. It's also nice if you wanted to do something dynamically. So if I were to change the birth date for whatever reason, to say 2000, it would then say that my age would be 23 instead. So those are the two main use cases for properties. There are probably others, but those are a bit more specific. I want to cover cached property very quickly while I'm here. I have talked about it in more detail in a different video, but it fits here, so I'm going to do it now. So we could do from functool. Oh, no, that was bad. I misspelt that in a very specific way, and I'm going to have to blur that out. From functools import cache property. I'm sorry. And then if we say a print calculating age, and we do cached property here, now we are caching the property, and if we were to call this more than once, we would see that the age is only calculated once. Because much like if you were to use from functools.cache on a method or a function, then this will cache the result of the computation in a dictionary somewhere. I'm actually not sure where it stores it. It's some sort of global state out in the middle of nowhere. And then when it's called, it will see, okay, I've run this before. I will then output it. What's important to note is that it works in exactly the same way, and as such can't be used in exactly the same ways as normal caches. So it takes all the input arguments, and then if the function name, or in this case the property name, and all the input arguments match what's already in the cache, then it will return the same output. So same inputs, same output, deterministic. With functions and methods, you can of course provide other inputs, and then if any of those inputs are different, the output will be recalculated. With a cached property, you can only pass objects. The object's instance is the only thing that's passed into it. And the cache property decorator does not take this into account. It does not more comprehensively track the object's state. It will just make sure that the object is the same. You might be able... I didn't actually try this. I've just thought you might be able to change this with a dunder-eq, perhaps. I don't know. Let me know if you want to try that. But if I were to change the birth date up here, for example, so if I were to change this back to 1998, it would... Oh, hang on, because I'm creating a new instance there. I need to do .birth date equals 1998, like that. And you can see, even though we've changed the birth date, it's now outputting the incorrect information because it's cached self and it's not tracking the rest of the information. It's not tracking the state of the instance. So that's all there really is to know about properties. As I mentioned in the intro, the video is not done yet. If you're not interested in the implementation, you could just drop out now if you want. But I'm going to be showing you approximately how it's implemented. So some caveats: properties are actually implemented in C, so you can't get exactly the same behavior out of it. What I'm about to show you is an emulated version that is in the Python documentation. What I've done is I've type hinted it and I fixed it because the implementation of the docs doesn't actually work. I don't know if it's a direct emulation of how C works and it just doesn't work the same if you do it in Python. But here it is. Ooh, here it is. There we go. So yeah, it's all very strongly type hinted. And properties, as you can see, are descriptors, everyone's favorite topic. If you don't know what descriptors are, or if you're confused by them, I did do a video a few weeks ago talking about descriptors. That will be in the cards. I also did a video on generics very recently as well. That will be in the cards as well. There's all sorts of videos going on. So I'll link that. If you're confused about how that works, I'm not going to go over that here. But essentially a property takes, or it can take, a getter, a setter, and a deleter in its constructor. And that's because properties are not only decorators, but can also be used, if I go back here, they can also be used like this. So you could pass the getter, the setter, and the deleter in like that. So that supports that. If you use it as a decorator, the initial argument would just be this fget here. And that takes the object and the return value, as I've called it T. Maybe it would be better to call that R, but never mind. It also takes an optional doc string, although it will automatically get the doc string if needed. So if you don't pass your own doc string, it will get the doc string from the fget and then set its own doc string to that doc string. From here, it then uses this dunder set name to then set the name of the attribute that is used later. And this dunder get, I've added a few overloads. So if object is none, then we are calling the descriptor on a class, and we don't really want to do anything special, so we just return ourself. So we're actually returning the property object back out. So if I were to do, say, print profile.age like that, and then print script, you'd see we get the property object back out. And that's because we don't really want to do any calculations because there are a number of side effects with doing stuff with that. So we just simply return self. Otherwise, we check to make sure that fget is set, which is not a guarantee. So we just raise an attribute error if not. And if it is set, then we just call the getter function with the object. The dunder set works very similarly. We take an object and we take a value. If the setter isn't set, raise a thing. Otherwise, we call the setter. And then the deleter, again, exactly the same thing, except we just take the object. And then these methods down here are similar to these methods here. So age.setter and age.deleter. So as they're decorators, they simply just take a function. So in this case, the fget, and that would be this. Well, this would be the fset. So if I go to the setter one, I'm going to close that because I keep clicking on that. It takes an fset, and then we just set the self.fset equals fset. This is actually what I had to change. In the Python documentation, it actually creates a new property instance and then sets everything up and then returns that new instance. But if you were to run it in the script, it actually breaks because then it doesn't understand what the getter and the deleter do. It's weird. So that's the bit I had to fix. But this is also a lot simpler. As you can see, we just do the same with the getter and the deleter. And now if we were to change this example to use our property, so from import property, so you change property up here. You would then have to change this to be like a dunder and then this to be a dunder. So similar to how single dispatch and multi-dispatch would work. And now you'll see that it works in exactly the same way. So we then get the age, we then set the age, we can delete the age or set it back to 0, and then we return our impl.property object down here. And everything is fully type hinted. So this will understand it's a literal 30. This does actually work if it's a property. It actually understands that it is a property even, I've just realized. That's really strange. There must be something with like the way the setter and the deleter are defined that actually figures it out. But the type hints are all the same as the property would be. So it will register this is an age. It'll register this is a property. Or sorry, it'll register this is an integer, not an age. And everything works hunky-dory. So that is a complete guide to properties. If you're a fan of the itertools module, then boy, have I got a treat for you. Recently, I found a third-party library that adds a lot more of these functions, specifically 151, which is an awful lot. Now, a good number of these functions are just very basic variations on the things you get in the standard itertools library, but there are some really cool original things in there as well that I want to show off. So in this video, I'm going to be talking about a slightly unconventional 7 of these functions that I think are really cool and give a good idea about what the library is all about. Of course, if you find this video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. But with all that out of the way, let's find out all the weird and wacky ways that we can work with iterators. Before we do anything with itertools, we have to install it. So we can go into our terminal and do pip install more_itertools and do that. I'm using version 10.4, which is the version with 151 functions in it. By the time you're seeing this video, there might be even more. Who knows? Well, the first of our 7 functions today is the bucket, and it's not technically a function, it's a class, but whatever. It allows you to bucket elements in an iteral based on some factor. So in this case, we're going to be bucketing our fruits by their colors. So we can have a series of buckets. That is a bucket. And it takes our iterable, in this case a dictionary, and then we pass in a callable that will then bucket the element.
So we want to take in the fruit, which will be the key in this case, and then we want to get the value out of it, and then this value will be used to put in a bucket. Well, that would be the name of the bucket, and then the element would be put in that bucket. So if I do print list buckets, and I'm doing this as a list, I'm casting it to a list because the buckets and the elements within a bucket are all like generator types. So I'm just doing this so we can show them off. And we can see that we have the red, yellow, purple, green, and orange buckets, which makes sense considering those are our colors. If we were to print out so if I do list buckets, and then we can just access this like a dictionary. So if I were to do all of our red fruits, we can see that apple, cherry, date, and raspberry are red. If we were to access all our yellow fruits, see that we have banana, lemon, mango, and pineapple. The second thing I want to show you is windowing. So itertools does have an element of windowing already. It has pairwise. What that will do is if you have A, B, C, D, E, it will return A, B, and then B, C, oops, and then C, D, etc., etc. So it slides over one element at a time and gets the amount of elements you want, which in pairwise is 2, obviously. In triplewise, you could probably work out that number is 3 instead. So we could do for triple in triplewise fruits, print triple, and then we can get rid of that for a second. If we do that, we could see that we get apple, banana, cherry, and then we get banana, cherry, date, grape. So we're sliding over the iterable one step at a time. And instead of 2 elements at a time, like pairwise would return, we're getting 3 elements at a time. If you want more than 3 elements, you can use windowed. So if I do window in windowed fruits, and then if you put 3, it will do exactly the same thing as triple. But if you want, say, 6, then you could do that. And then you have a window with 6 elements at a time, and it slides again across each one. You can, I'll just look up the signature. Yeah, you can provide a step. So if you want a step equals 3, for example, and you can see that we're moving across 3 at a time rather than just 1. This third one is probably my favorite one of them all, and it is collapse. And you can see that our fruits list has become really messed up. There are lists inside lists inside lists all over the place. And trying to flatten this using any other flattening solution would only normally flatten one level of nesting. But collapse allows you to flatten any amount of nesting into a completely flat list. And to show that off, you could just do print list collapse, because it does return it as an iterable, not as a list itself, fruits. And then if we do collapse like that, our list is now completely flat, which is really cool. Now, the fourth one I want to show you is sample. And you may think at this point that random has a sample, and it does. In fact, we're importing it up here. But it does have some limitations. So here we have the list of fruits that we've had this whole time, and here we have a list of fruits that have the letter E in their name. We don't know at this point in time how long this iterable is going to be. And this is where random.sample has no idea what to do, because it needs to know, as I'm going to show this. So if you just get 3 and we print selection, if we do sample like that, we see that we get an error saying population must be a sequence. So a sequence in Python is something that supports the len method effectively. So something where the length is known. In this case, it's not known because it's just a generator. However, if we were to comment that out and uncomment the more itertools version, then we have a fully working sampling system. So that time we got lemon, raspberry, lime. That time we got grape, pear, and cherry. And we get 3 random ones every time. So the main difference between the two is that random.sample does need to know the length of the iterable beforehand. More itertools.sample doesn't. Now you could say that you could convert eFruits into a list or a tuple or something like that before you sample it. And if you think that's what you want to do, then go for it. More itertools just provides another option. You don't have to use it. Our fifth one is probably the simplest out of the whole lot. What I've done is I've updated our list of fruits to have some duplicates in it. So we've got cherry in there twice, we've got lemon in there 3 times, and we've got pineapple in there twice. What unique can do is essentially remove the duplicates as you're iterating through it. So if we do from for fruit in unique fruits, if we just print fruit and then do .upper to show that we're actually processing it, unique like that, We get apple, banana, cherry, grape, kiwi, lemon, orange, pear, pineapple, and raspberry. Note how there aren't any duplicates in that list, and that's because we have phased them all out. So this avoids the need for us to cast the iterable to a set beforehand, but it also maintains the ordering, unlike set. If you really didn't want to use this and you wanted to maintain the ordering, you could use dict.fromKeys to do the same thing, but dict.fromKeys is significantly slower than set. And realistically, this is going to be faster, perhaps than even both of them, because you don't have to do any casting to any types at all. The sixth and final one I'm showing you is numeric range, and it's the only one that doesn't use our fruits list. Fruits tend not to come in numbers, typically, so we're using numbers instead. Numeric range with integers works pretty much the same as range. I don't know if it just uses range under the hood or not, but what makes numeric range special is that it can actually support floats. So in this second example, we are starting from 1.75 and we are ending at 7.0. And if I were to run this first one works up here. The second one starts at 1.75 and it uses a step of 1. If you wanted to change it to use a step of 1.75, then we will. And then it won't actually include 7. So we could say maybe 7.1. Then we get 7 down here. Now we're using a step that's a float as well. However, what makes numeric range really cool, and the real reason I'm showing you, is that you can do this with date times as well. So if I were to import date time as dt, and then if I just copy paste this code from my notes in, we start from the 1st of January 2024, and we end at the 1st of January 2025, and we are creating a numeric range from the start to the end, and if you pass a time delta as a step, we can advance whatever we want. So in this case, we are advancing 7 days and 4,053 seconds to be particularly specific to kind of show it off. And as you can see, we are advancing indeed 7 days, 1 hour, 7 minutes and 33 seconds each step. And we can do that until we get to the very end without exceeding the end range, which in this case is actually 9 o'clock in the morning on Christmas Day. That's probably when a lot of people will wake up on Christmas Day. Actually, that's kind of freaky that I've done that. But there you go. But I wanted to show this off because this is really cool. I've only ever seen this done in pandas before, and being able to do this without having to use pandas and all that comes with it is actually really nice to have. And the final one I'm showing you today is a bit of a wild card because it is a function that can turn any other function in more itertools, and indeed any function that takes the same signature, into a decorator. So you can create a decorator out of any of the other functions. So if we had our fruits and we got the colors back and everything, if we had a function that was get all yellow fruits, and then we pass in fruits, and then we simply return that. If we just print this for a second, lists, oh no, we don't want to sample it yet. No, you're spoiling it, AI. You're spoiling it. If you were to run the correct one, that would help probably. We get banana, lemon, mango, and pineapple, which is correct. However, if we wanted to sample this instead, then we could create a sampler which had make decorator, and then we pass sample in like that. And now suddenly sampler is a decorator that we can apply to this. And then we do need to pass a number in. So sampler does take a k value. K would be 3. So the only one you're actually missing when you have sample is the iterable. So this function here becomes the iterable in a sense, i.e. the return value gets passed to the first parameter of this function. And then you can pass in any other functions or any other parameters you want. So 3 would pass in k. We could pass in weights or counts or strict if we wanted to as well. Now if we do that, we get a random sample of 3 of these. If we wanted specifically to create a decorator that only ever sampled 3 things, we could go even further and say random, let's call it sample 3. Sample 3, and then we could use the fancy decorator syntax to decorate the function and then call that with 3. And then if we sample 3 like that, then again, we get 3. And actually, if I do 2 to show this off a bit better, you can see we're now only getting 2, even though the function name is sample 3. So I'll put it back before anyone gets really angry. But I wanted to show that off as a bit of a wild card. It is one of the wilder ones out there. And to be honest, more itertools has a lot of these really wild ones, as well as a lot of really simple ones like unique. There's a whole broad spectrum of what you can do with this. And well, yeah, 151 functions is certainly not a small amount. And this includes being able to do all sorts of mathematical operations as well. I haven't really shown any of them here, but you can do all sorts of math operations. You can do other grouping things. You can do combinatorics. You can do the lot. It's pretty mental. Let me know in the comments which of these 7 is your favorite. Yes is the simple answer to that question. I ran a poll in my community tab and 2/3 of you agreed with that conclusion. The metaclasses are indeed the hardest thing in Python. So I thought I'd provide a detailed overview of what they are and how they work. Now naturally, like a lot of things in Python, the more difficult the concept is, the more important it is to the core of Python, and metaclasses effectively make up everything in Python. And this is because everything in Python is an object, objects are all made out of classes, and classes are all built using metaclasses. So as far as the Python API is concerned, metaclasses are as low level as you can get. With that being said, the use cases for them in general Python programming are fairly limited, which is good and bad in a sense because you don't necessarily have to deal with the complexity all that often, but trying to explain them in the concept of something that metaclasses are best at is quite difficult to do. In this video, we will talk about the basics of metaclasses, how to create custom metaclasses, a use case where you shouldn't use metaclasses, which would be very important, and a use case where you should. With all that out of the way, let's tackle the hardest thing in Python. Before we dive right into creating custom metaclasses and all that, I do want to talk about the basis of metaclasses, and that is the type built in. So you may have seen, I'm in the wrong window. You may have seen a number of times where you use, say, type to get the type of a value. So you could do type 5, or you can print type hello. And if we were to run this, we would get class int and class string. This is a very common use for type. What you may not have known is that type is actually responsible for creating every class in Python. And you can actually create classes dynamically using the type built in. So if I were to, and I'm going to use my favorite example, the profile. If we were to create a profile and we would say type, we would then give it a name, profile. We then give it a series of bases. You can either leave this empty for now. I'm going to use object because that seems a bit more proper. And then you can pass a series of attributes. So I'm going to say my name is Ethan. My age is 25. My job is a software engineer. And you can actually pass in methods as well here. So if you wanted to do the string representation, you could do that and do lambda self.name is self.age years old. And now if I did p equals profile and then I printed p, we get the string representation back. And if I were to print type p to show it off, and if I were to print, I've got some other stuff in my notes. If I just copy paste that as well to print some of these attributes, then we see that it is indeed of type profile, and all these attributes are successfully set to the class. And we haven't used the class built in once here. Now, of course, if you did want your class to inherit from another class, you could do that. So if we created a class using the boring class method way base profile, and then we just set x equals 5 for a quick little explainer, we could set this to base profile here. And if we printed p dot x, we see that x is indeed 5 because we have taken this base class, we've created a profile class based on that class, we've inherited from it, and now we've inherited all its attributes as well. So what's important to note here is that the class keyword is just syntactic sugar for this type, and that is because type is a metaclass. In fact, it's the big boss of all metaclasses. All metaclasses must inherit from type in order to work, because type contains all of this information, all the methods necessary, all the attributes necessary to be able to create classes. And this profile class here is pretty much exactly the same as this profile class here. So I've just recreated it using the class syntax. We have the same initializer, we have the same string method, we're inherited from the same things. If I were to create a class using this, and we print that, not that, that, we get the same string back. Now, of course, using type to dynamically create classes is not necessarily the most useful thing in the world, but it is quite important to know, because when you actually create a custom meta class, you can refer back to that. So we're going to do that now. So if we get, we want to do that above here. We do class profile meta, and we are going to inherit from type. And we're going to do def init, and this is going to be class, not self. We have a name, which is a string, bases, which is a tuple of type of any length, and then attributes or namespace or DCT or whatever you want to call it, which is a dict of string to any. That's going to return none. And then I'm just going to copy paste this in here. And it's just going to be a bit of a logging thing. So this, if I just do from typing import any there, not and, there we go. This is called whenever you create a new class. So we can see that this print statement says creating class of name, name, and then we're just doing some debugging to show the name, the bases, and the attributes. And you'll notice that this signature is very similar to this signature down here. So you have the name, the bases, and then all the attributes. It's the same thing. And that's because when we call super.init, we're actually just calling this directly. And to actually set profile meta as our meta class, we come in here and we do meta class equals profile meta. And by default, the meta class would be type. But in this case, we're providing a custom meta class. And now if we were to run this, we haven't actually set anything to run. Oh, we have set anything. There's something to run down here. If I get rid of this for a second, then we get creating class of name profile, and then we have our information. So name equals profile, bases is the base profile, so that's what we did before. The attributes does look a bit different because the class keyword does a little bit of extra magic in the background. So it adds the module, adds the qualified name, and it has your functions here rather than attributes themselves. But it does very much the same thing as just calling type directly. I just want to add a quick note about why they're different, because I noticed that I misspoke here slightly. So the reason they're different is because in the original example, in the type built-in example, I set the name, age, and job attributes as class attributes. And in this example, I've set them as instance attributes by accident. So that's why they're different. If I were to set them as class attributes here, they would appear the same in the dictionary. So it's just worth keeping in mind that no matter what you assign to a meta class, it will always appear on the class as a class attribute, not an instance attribute. Now, if you wanted to, you could override how creating instances of that class works as well. And you can do that by doing def dunder call. And this also takes a class. So this is taking the class that we want to initialize. And we just take args any, quargs any, and then we return any for now. And then I'm just going to copy paste what's in here. So now we are creating an instance of class.dunderName. And then we just print the args and the quargs, and then we get super cool. We can then uncomment this and see what it prints out. So now down here, we're passing Ethan as the name, 25 is the age, software engineer is the job. And we can see that here in the args. If we were to pass any keyword arguments, so if I were to do job equals instead, that would come up here. So this is just the arguments provided to the class constructor. And then, of course, we just get the string representation down here. You can do dunder new as well to control how the meta class itself should be created. I don't really want to go into that because this is not a complete uber complex overview of everything. But I will say that if you were to do that, the first argument would be MCS for meta class. Or actually, I've seen it before where you can do meta class like that. I think both are pretty much accepted. But yeah, we're not going to touch that for now. Before we move on, though, I just want to talk about typing considerations, because meta classes can be a bit weird with that. So if we go down here, we can see that P actually registers as type any. And then if we print P here, we just get a variable type any. And that's because the call is returning any. So whatever is returned out of the call, the type checker will actually use down here. it is a very easy solution to fix this. We just need to turn this into a generic meta class. So I've done a video on generics if you want to see them, and that video also cover what type vars are. So I'll leave that in the cards. Type var t, like that. And then we just need to change this to t here. And then we need to get this to inherit from t. And this is using the old syntax. You can use the new syntax if you want, perfectly fine. But now we've created a generic meta class, and this is of type t. And this mercifully is enough for it to work. For some reason, there's just a bit of magic that goes on at some point. And we can see that p is now profile. I am wary of overcomplicating this video, but I did want to cover that type safety because I knew that a lot of people would be interested in that. Now, one of the keys to fully understanding metaclasses is knowing when and when not to use them, because there are a lot of places you could use metaclasses, but the vast majority of which are better served by some other simpler way of doing things. And I did want to show an instance of that off because that is a very important part. And one way you can do that is by using the singleton pattern. So for those that don't know what a singleton pattern is, very simply, it is a class that only allows a single instance of itself to exist at any one time. You could either error it out if you try and create another instance, or you could do what we're going to do here and just return the original instance when you create the class. So to do that using a meta class, you would do class singleton meta, and then you would pass in generic t like that if you wanted type safety, and then you would give it a type. Don't forget the type. And then we can have an instance of t or none equals none. And then we can use the dunder call to override the instance creation logic, and that needs to be a class, and that signature looks fine. And then if a class instance doesn't exist, then we just want to create a class instance using super.dunderCall. If it does already exist, then we think, okay, we can just return that back out. And before we turn this into a meta class, let's see what it does if we don't have that meta class logic in place. We can see that DBM1 and DBM2 are false because they are different database managers. And in this case, that's actually not ideal because you'd be creating two separate databases in memory, which is a bit confusing. There's extra overheads. I just wanted to use the database manager as an example here. If we then turn this into, or if we then applied the singleton meta class to the class, we now see that DBM1 is DBM2 because we create the first instance as DBM1, then we create the second instance, we see that the stored instance is not none, and then we just return that same instance back out. So that is how you would do that in meta classes. However, it's not the simplest way you could do it, because as you can see here, you can do it just as easily with a base class, and it's actually a little bit easier to understand because you're not adding that extra complexity of a meta class. You're also not having to do these weird type hacks to make everything type safe. It just knows, it knows that DBM1 is a database manager. It knows that DBM2 is a database manager. And you can just use the dunder new, which happens at the same level as this dunder call. I think, if someone knows for sure, do let me know. I think dunder new is actually called first. No, it would be called second, wouldn't it? Because this super.call would then call dunder new. So this happens a little bit later down the line, but it does the same thing in the end. At this point, you might be thinking, well, if a lot of meta class use cases are better served by a base class or maybe by a class decorator, depending on what you wanted to do with it, what can you actually do with a meta class that is useful in the real world, that is objectively best as a meta class? And I can give you one answer to that, and that is class properties. And I will explain what I mean. So if we do class properties.py, and then we do import random, there's a lot of setup to this. So we'll get to it. Fruits, can't even spell, that would help. Apple, sure, we'll have all them, why not? And then if we were to have some sort of configuration class, I've talked about class-based configuration classes in a different video. We could create a class property by using class method and then the property. And then we could say fruit here. This then takes a class, returns a string. And then we can put in some logging, which will become apparent why we're doing this in a bit. Just to better show off the problems with this. And then we can turn random dot choice fruits. And then if we do if name equals done domain, and then do print config.fruit. So what this is doing here, we just have a series of fruits. We then have a configuration class. We have a class property that we can call like this, and this will choose a fruit for us. And on the surface, it works just fine. It chooses the fruit, it waits a second to simulate actual work, and then it chooses a fruit, in this case, cherry. However, it is deprecated, so this doesn't say it, but this will. Class properties are deprecated in 3.11 and will not be supported in Python 3.13. We're using 3.12, which is why this still works. But why is it deprecated? Well, it's because it's buggy as hell. So if we did help config, if we ever wanted to find help, and this is how it was found, it happens in a few other situations as well. We would choose the fruit, we'd then choose the fruit again, we then choose the fruit again, we then choose the fruit again, and then we'd get the help. Why exactly this happens, I don't fully know. It's something to do with the way the descriptors are set up, something to do with the way that, well, help has to like scan and access the object to find all the documentation for it. And I guess in doing that, it just triggers all this stuff, which is not ideal, especially if you want to do other stuff that triggers this. One way you can fix this, and we're going to uncomment this, is by converting this into a metaclass, or specifically moving this functionality into a metaclass and then having a metaclass here. So if we did class config meta, and that inherits from type, and then we take this logic out of here and we put it in here, and then we can actually just pass this out completely. And then metaclass, just pretend there's something else in there that you need. Metaclass equals config meta. We now see that config.fruit is still accessible. And now we see choosing fruit, which it does. And then it prints the fruit. But you'll notice that it didn't choose the fruit 4 times before going to help. It just went straight in. And this is the difference between metaclasses and classes. And it's a very important thing to note that anything you create here within the metaclass is created as a class attribute, a class method, or in this case, a class property of the class that you're attributing the metaclass to. And I don't fully know why this bug doesn't happen when you use it in metaclasses. I have a feeling it's something to do with the order of operations. So this property gets assigned to the metaclass, and then the config effectively just inherits it in a way, rather than actually creating it at the time. So it's already created ahead of time, something like that. That's my theory. I don't fully know the reason why. But that is one instance where metaclasses genuinely work very well, and something I've had to do in the real world. I had to do something very similar to this when I built a type-safe, lazily evaluated configuration system using descriptors and all sorts. I actually had to use metaclasses in this way because there were attributes that I needed to calculate lazily using other attributes that are attached to the class further down the chain, so they couldn't be attached directly. They needed to be a property because I didn't want it to be called as a method. But then I ran into this bug with the help. It was a big slog. But I found out in the end that these class properties can work using metaclasses. So this is actually in use in the real world. And from the research I did when I was investigating that bug, it seems there is quite an audience for a feature like this. But that is a brief run through of metaclasses. If you didn't understand everything in this video, that is perfectly okay. Metaclasses, in my mind, are pretty much the hardest things in Python. As I said at the start, there was a poll that kind of confirmed that really. So it's just a case of finding a use for it and practicing with them. If you do have any questions, do leave them in the comments. If you have used metaclasses before in the real world, then do let me know. As I'm sure we all know by now, Python 3.13 released earlier this week. And there were so many things to talk about, so many huge changes. I didn't really get the opportunity to talk much about the typing changes in my release video. And so I thought to rectify that situation, I want to make a separate video talking about the major changes. So in this video, I'm going to be talking about the defaults in typevars. I'm going to be talking about the deprecated decorator. I'm also going to be talking about the read-only and type-is forms. Of course, if you find this video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. With all that out of the way, let's talk about the major typing changes in Python 3.13. So the first thing I'm going to talk about is the new typevar defaults. I'm going to be first showing off an example of an app that has a context in it without any defaults, and then I'm going to be showing what's changed and how that can help. So if we do from typing, import generic and then typevar, and then say you have a class of context, which will definitely be our context object, and then we had t, and we're just going to leave that as typevar t for now. And then you had a class of custom context, and that definitely has all these attributes to it. And then we have a class of app, which has a generic type of t, and then it has a context, which is this type t. So this t is the context type. If we then did if name double equals main, did app equals app, and then we did reveal type app.context, the first thing you'll notice is that this will complain, or MyPy will complain that you need a type annotation, because there isn't enough information currently for MyPy to be able to infer what this context should be. And if we reveal the type of this app.context, it is of type any. Now, prior to 3.13, you can fix this by doing app context like that, and now it stopped complaining, and app.context is context, and then you could set your custom context like this, and app.context to be custom context. However, if we get rid of this again, if we now set a default to be context, we'll no longer get that error, and app.context will see that it's supposed to be of type context. So you now don't have to specify a generic type to get app to understand what you wanted to do. And this is really useful, say if you had a framework with this app in it, and this context was almost always going to be this context class, but you wanted to provide the ability to overload it, and you wanted to provide a generic type to enable type checkers to work around that. You could do that, and if you wanted to do custom context, you still could do the custom context syntax like that, and that context would be custom context, but getting rid of that means that it would just default to the context. So that's a really nice change. The second thing is the warnings.decorated, warnings.deprecated, almost said it right, decorator that was introduced. So if I do that, from warnings import deprecated, and this deprecated decorator does two things. It first emits a runtime warning, or it emits a deprecation warning, but it emits it at runtime. But it also will let type checkers know that something has been deprecated, and then they could take the appropriate actions. So if you had, say, a hello world function that then printed hello world, and I always like it like that, there we go. And then say there was this newer version of it called hello, and then you could have an entity passed to it. So you could suddenly now say hello to everything. And for backwards compatibility, let's say this just has world as a default, and then prints hello entity. You could mark this first one as deprecated by using this deprecated decorator. You need to provide some sort of message. So we could say use hello world instead, like that. And now if we were to call this hello world function down here, then Pylance, this is Pylance is doing, would notice that, and it would say the function hello world is deprecated, use hello world instead. MyPy and Pyrite I don't believe are capable of doing this. I haven't actually tried it with Pyrite. Let me have a look. Pyrite warnings deprecated. Does this understand? Is an unknown import symbol. No, it doesn't know. And then if we do, of course, hello world, then everything will be fine. But both will still work. But you'll see on this first one, we get a deprecated warning actually at runtime, telling us the same thing to use hello world instead. So you could put anything in this message. You could put a version that something will be removed, or you could put the replacement in like I've done here, or you could realistically just put anything in there you wanted. It doesn't really matter. The third thing that I'm going to show is arguably the least useful, I would say, out of the four things we're talking about today. And it's also the one that doesn't work in either MyPy or Pyrite. So I don't really know what the deal with that is. But if we have read-only.py, it is a new update to typedict, or a new thing that typedict can use to set dict entries as read-only. So we could do from typing import type, oh, if I could type dict and then read only. If we were to then have a class user type dict, and then they had an ID which we wanted to be read only, and we would say that was an integer, a name which is a string, and an email which is also a string. And we'll see we do actually get the typing error from MyPy saying it's not valid as a type, and then the Pyrite will actually complain as well. I don't know why I did it like that. Saying that read-only is an unknown import symbol. So neither of them work, I don't know why, but I have double checked and it is definitely the right one. And this read-only, when it's implemented in the type checkers, will tell the type checkers that you cannot change that entity, or more realistically that you shouldn't change the entity, because read-only doesn't actually do anything at runtime. You can still change it, of course, but the type checker will throw a fit. Now, because it doesn't work in type checkers yet, I can't actually show you a proper example beyond this because I don't think they'll know what to do. Actually, Pylance might know what to do. Let's have a go. So if we were to say user equals, and an ID equals one, name John, and that. If we were to say user ID equals 2, okay, nothing's going to happen. I was hoping Pylance might have caught up, but this would throw a typing error if it was implemented in type checkers, but it's not, annoyingly. And finally, the last thing I want to show you is the type is, which is actually something that I'm very excited is in this. So type is replaces, quote unquote, the type guard. It sits alongside it. The type guard isn't being deprecated at all, but it provides behavior that type guard probably should have done initially. So if you do from typing import type guard and type is, because I want to show the old and new behavior. And if we have a class called dog and we want to do def bark, and it'll print woof. And then if we had a class cat, there we go, the arrow knows what I want to do. That'll meow. And if we had a type predicate that was is dog, passing the object, type guard dog, and then this will return is, oh, the AI has just decided it's going to completely stop working. That's good. Object and then dog. So this is basically what's known as a type predicate, which is where you have a function that returns true or false depending on whether or not something is a type. And you can use type guards in these situations. And if we had another function called speak, animal, and that was either a dog or a cat, and that returned, oh my, I just cannot type today, and then we did that. So if the dog is an animal, then animal.bark, else animal.meow, and you'll see here that we get an underline error because item dog of dog or cat has no attribute meow. And that's because typeguard only works with the positive case. So when we use typeguard, we can see that animal is a dog because the type predicate has passed. And we now know that everything referencing animal in this block should be a dog. What it doesn't do is it doesn't handle the negative case at the same time. So you could have a separate type predicate that checked if it was a cat. So you could do elif is cat, and that would probably work. But with else, it still says it could either be a dog or a cat. If you didn't want that behavior, you could use type is, and now suddenly everything's fine. So this else, it knows that it cannot be a dog, which of course is the logical course of action. And I don't know why type guards could never do this. But if you highlight over animal now, it is a cat. There were some other typing changes as well, but generally a lot smaller. So
typing on is protocol function that you can use to check if something is a protocol, for example. But these were the 4 changes with peps assigned to them, and as such, are the only 4 that I'm going to talk about in this video. But do let me know in the comments if there are any particular typing changes. While it may seem like I spend all of my time talking about and using Python, and that is largely true to an extent, I do dabble with other languages occasionally. And every now and then I come across a feature that I really like and really wish that Python had. One of these features comes from a language called Rust, where you could write tests within your documentation to ensure that not only the code works correctly, but that your documentation is correctly written. Now, this is part of the standard functionality of Rust and something you're actively encouraged to do. What I didn't know is that Python indeed actually already has this feature in the standard library. And on top of that, it's had it for more than 2 decades. This module is called doctest, and you could probably imagine both in the name and the description I just gave what it does. So in this video, we're going to be talking about how you can write tests in your documentation, but we're also going to be talking about how you can incorporate that in your unit tests as well. Of course, if you find this video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. But with all that out of the way, let's bring our tests into our documentation. So I already have an example on the screen here of a string to ball utility. And what this does is it takes a value of a string and then converts that into some sort of falsy or truthy value, depending on a few extra characteristics, or it can handle a few more cases. So we have false, F, and 0. All of these will return false. And true, T, and 1. All of these return true. And it would do that in any case. And then we have this value error if something else is provided, and so it can't reasonably convert it. You could set this to just be true because it's probably a truthy value, but I needed to do that because I need to show something in particular. And we'll see that we have this doc string here, and this is done in NumPyDoc. I do quite like NumPyDoc. You don't have to use NumPyDoc, but it does owe itself to this in particular because the example section normally relies on you using this syntax, and this syntax will get converted into code blocks in the documentation. And this is what doctest looks for when it's looking for these calls. So these 3 arrows, if you don't know what come up if you open the Python interpreter, so you've got these 3 arrows here. So this is saying that on an input line, you would call string to ball, and if you were to call it with a true value, it would return true. And we could just do quickly ball, say 1 is true. So this return value here is what is there. String to ball false would equal false, etc, etc. What isn't on here at the moment is how you could do tracebacks, because I wanted to talk about that a bit more specifically. So we do have this raised value error down here. If we were to create another example, string to ball, and then we would pass hello world into here, because the way it looks for tracebacks is quite a specific syntax. So it will look for this first line in a traceback block here, and then the AI is going to fill it in. So you could just do this ... so you don't have to do the full stack because you can never know. And then you have the actual error that would occur. So the error type and then the error value in full, that would be returned. And it does need to be in this syntax for doctest to be able to pick it up. You can run these tests in multiple ways. So you can run them manually, or you can run them in test suites. I'll talk about doing them manually first. So you can do if name equals main, import doctest, and you do doctest.testmod. And this will test the entire module. And now if we run PyCarbura, that's what I just named this little package I've got, and utils, there is no output at all. And that means that everything was fine and everything passed. If we change this to true, which it shouldn't be because false shouldn't equal true, it will now return an error saying that the failed example was this, it expected true but got false. Now we can see, oh, my documentation is wrong, I need to change this to be false. If you do want the output in all situations, then you can do py that and then pass -v to it, and now it will say all the tests that it tried to do, and it will say they're all okay, and then it will say that they all passed. So if you wanted to see the output, you just pass -v to the script with this test mod in it, and it will work fine. If you wanted to run this just in a script for whatever reason, and you wanted to see the output, you can actually print this, and you'll get, let's see, utils.
and it will print a test results object with the number of failed tests and a number of attempted tests. So there were 3 in total that were attempted, these 3 examples here, and then 0 of them failed. If you don't want to use test mod, or if you want to test specifically a function, then you could do test.run docstring examples, and we'll get rid of this for now. You pass the function, and then you have to pass all the globals, or at the very least enough globals, but you could just pass all the globals in. And now when you do that, again, it will do the same thing. If there is a failure, then it will tell you, it will give you the expected and then what it got. You can't print anything out of that though. So if you were to try and print, it just always returns none. All of this says it always returns any. But if I did a print like this, we'll see we get a red underline saying that it doesn't ever return a value. If you wanted to run these dot tests in unit tests, you could do quite easily. I'm going to show you how to do it in both the unit test module and in PyTest. Spoiler alert, doing it in PyTest is way easier than doing it in unit test. So I've got this test.py file that I've created off camera, and I've also added a dunder init.py just to make the package a proper package. If we open this, we import doc test and we import unit test. We then import the individual modules from the package. And then I'm just doing some extra type checking stuff just so I can make it a bit clearer what it's doing. And then we have this def load test function here that is called automatically if the file that unit.test, unit test domain is called in, sees that load test is a part of it. So you have this test loader here, the test suite here, and this pattern that I don't really know what it does, and we also don't use, so that's fine. I don't use unit test, I use PyTest mainly. But you just need to add some extra tests to the test suite, and .test actually has this .test suite helper class to help you do that. So all you need to do is provide the module, and then it'll add all the .tests in that module, and you need to do that for every module. I was originally planning to do this a lot more dynamically, having something that could scan a package and find all the modules, but for some reason that's not working today, but it doesn't really matter that much. The intent of this is probably a bit clearer anyway. So if we run this using py and then test.py, we get 3 tests ran in 0.02 seconds, and we can see that all 3 pass. Now it does do a single test per function, so it's not a single test per test. If you have multiple tests within a single function, then they will all be run as part of the same test, and if one of them fails, the whole test will fail. So if I do true here, we'll see that we get a failure here and that the other 2 passed. So that is that. If you wanted to do the same thing in PyTest, all you would need to do is PyTest --doc test modules. And PyTest is smart enough to go through, it actually uses the doc test API under the hood, but it will go through all the modules that are currently loaded, and it will look for all of the doc tests, and it will run them all in the same way. So you see that the utils file only has the 1 test. And if one fails, then it will give you the standard doc test error as well. It also gives you some line numbers here, which is interesting. I've never seen PyTest do that before. But it will give you a failure if it fails, and then obviously if it runs as you saw, it passes. Let me know in the comments if you plan to use this in your own project. Enums, or enumerators, are a simple but very useful part of Python. They provide a very easy to use and understand way to bring more structure into your program. And the more common use cases include adding the element of choice or tracking your state. But if you take advantage of some of the different variants of enums, they can be used to do some really powerful things as well. So in this video, we're going to be talking about what enums are, the different variants, and how they can be used. Of course, if you find this video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. But with all that out of the way, let's, for a change, talk about one of Python's simpler aspects. Actually, creating an enum is very simple. So all you need to do is to from enum import enum, and then whatever enum you want to create, you just make it inherit from enum. So we can do class game state as an example, and we get it to import from enum, and everything's fine. This is now an enumerator. And the enumerator values that you put on it, you define as class attributes. And you typically define them in uppercase. This is just the standard, it's not necessary. But you would do, for example, playing equals 0, paused equals 1, and game over equals 2. And these indicate different states. So the game could either be playing, paused, or in a game over state. And then if we do if name equals main down here and print game state.playing, then we just get this back. It's not particularly helpful. If we get the type, we'll see that this is actually an enum value itself. And you could use this in an if condition to say, if the state is game state.playing, then do this. If you wanted to print out something or do other things with the name and the value, then you could do, if we do game state.paused.name to get just the name of it, and then print game state, and we'll use game over dot value to get just the value. If we do this now, we get the enum type, which is printed. We get the name, which is just paused, so that's this side, and the value, which is this side over here. And you can use .name and .value to just get these values. You don't have to use dot notation when accessing an enum. You can, if you know the value, instantiate the enum using that value. And if you know the name, you could also use dict accessing. So if you had the name or the state as a string, for example, you wouldn't have to do some weird get attrib thing. You could just access it like a dictionary. And now we get GameState.paused and GameState.playing as you would expect. Now in this particular example, we've used 0, 1, and 2 as the values. In some instances, this one included, the actual value of the enum is immaterial. It doesn't matter. So you could, if you wanted to, use auto. And now if we set this to use auto like that, instead, it will just use an appropriate value. In this case, I believe it still will use 0, 1, and 2. And we can actually verify that. Oh no, it uses 1, 2, and 3. There we go. So it starts on 1 if you do it like that. But it just makes sure that all the values are unique and that you don't make any typos, and that if you change anything, it all works fine and everything. If the value does matter, so if you are ever going to instantiate it like this, you can see we've actually got GameState.playing down here, then you probably do want to set values, because if we were to change this order of operations around and say paused was the first state, then doing game state with 1 now uses paused, not playing. So this behavior is actually changed. So if the value does matter, you want to explicitly set it. If it doesn't matter, i.e. it's just a series of choices, then you can use auto. Ordinarily, enums are fairly dynamic, so the actual type doesn't matter. I could set these values as strings if I wanted to. I could set them as objects if I wanted to. But if you did know what type of value your enum was going to have, you could unlock some extra functionality. So if I create this file here called categories.py, and then I copy paste this absolute monstrosity. So this is a real world example for those that have used the OpenTrivia API. These are all the categories that you can select. And yes, they do start from 9. And so in this case, the values are necessary. But you'll notice that every single value here is an integer. It's not dynamic at all. So we can import int enum and then set this is int enum here. And what this allows us to do, and this is not necessarily useful in this exact situation, but if we were to print category.generalKnowledge plus category.geography, say, and then run that, we would get a total of 31 because we've taken the general knowledge, which is category number 9, and then geography, which is category number 22, and we've added the values together. If this was a normal enum and not an integer enum, it wouldn't be able to do that because it doesn't know for sure that all the elements are integers. So in situations where you would want to potentially do value comparisons, or maybe you would want to add multiple values together, then you would want to use int, and then it accesses the value directly rather than the enum itself. You could add this functionality if you did a dunder add here, but this int enum does it for you and assumes, okay, you want to add these enums together. That means you want to add the values together. You can also do this with strings as well. So if I were to create a file called colors.py, if I were to paste this in, we have an enum with all the all values of string. And if we were, again, to add them together, then it just adds them together like that. We do also have all the string attributes. So we can do a case fold. We can check if it's an alphanumeric character. We can check if it's a digit character, because we know that the values are strings. And so when you access the enum, it just goes, okay, you want the value, and then we can do these things on the value directly. I should say, if it was a normal enum, you could still do this. So you could do, you obviously wouldn't have them on, I need to import that. You wouldn't have these things on the enum itself, but if you were to do .value, you could still do them. Because string enum came about, I think, in Python 3.11. In enum was a bit earlier. But if you're using an earlier version of Python, you can still do this just by explicitly calling .value. Another enum type, and the final one I'm going to show in this video, is the flag. And I'm going to do a little bit of copy pasting here because this example is quite involved. But if we would have some run flags here, and this is sort of emulating a CLI in a way. So you have no run flags, which is the default. You can have a verbose mode. You can have a build mode, which would build whatever you want to run before you run it. You have a dry run, which runs it in a mode where nothing changes. And then you have a debug mode, which, for example, say activates both verbose mode and dry run mode. And ideally, it doesn't enforce this, but ideally flags would need to be binary characters. And this is the way that I just prefer to do them. So 1 left shift 0 is 1, and then you've got 2, 4, and 8. And this just means that you can activate multiple modes at once, and it won't get confused about what's activated and what's not. So if you were to activate verbose mode and build mode at the same time, you'd get a value of 6. If dry run was set to a value of 6, then that would activate dry run mode when you wouldn't want it to. This is why you can do this. And then this pipe character is what's used to combine multiple flags together. So again, debug mode, we set verbose mode and dry run mode turned on. The function here, which I'm going to copy paste and then walk through, is simply just a run function, and it takes it takes the flags as run flags, and then by default, we have no run flags. We just want to run it as normal. We create a logger, and then the first thing we do is we check to make sure the verbose mode is enabled. And this is the syntax you would use to do that. So this is a bitwise AND operator, and it essentially makes sure that all the bits for verbose mode are on in flags itself. And if that's true, then verbose mode is enabled. It could mean that other modes are enabled, and this is why we use this binary, power of 2 numerical system here for the values. And actually, auto might do this power of 2 system. I haven't checked that with flags. But this is why we do it. So if it's true, then we set a login to debug. If we have the build mode on, then it just does some extra stuff. So you're building, this might take a while and it sleeps. And then it will run it. And then literally the only difference between dry run and not is the logging message here. And then we run it. We simulate running it at the very least. And then we log to say it's complete. So if we, what I'm going to need to do is I'm going to need to do if name double equals main. And if we run just in normal mode for now, do run flags, and then we get an info log to say that it's running. So verbose mode isn't active, so it hasn't done this. It's not running in build mode either, so it hasn't logged any of this. It's just run this. Dry run mode is not active, but they only have debug logs. And as verbose mode isn't active, it's not printed them, so it just says running and incomplete. If we were to change this to be flags equals run flags.verbose, it comes out with a little more information. It tells us that it's not running as a dry run because debug mode is now active. We can then combine this in run flags.build, and now it will have this debug mode, and it will build it before we run. So we've now activated some extra functionality. And then we could simply do debug mode here. And now you'll see it's turned on the verbose logging, and it's running as a dry run. So it's activated this logging here because the dry run mode has been activated. And this is what this can do. So you can actually set these within the enums itself. So you can have shortcuts that activate multiple modes at once. So that is a basic rundown of enums and all their different types. Discord bot tutorial on this channel. What is this, 2019? The world of Discord bots has changed considerably in the last few years and has been pretty inconsistent, pretty changeable for a long time, but it's now stabilized very recently, and I feel like it's a good time to make another video about it. Especially since the library that I use for Discord bot development has recently announced that it's gone stable. This video is going to be somewhat of a crash course in Discord bot development. We're going to be covering a lot of areas, so we're going to be talking about how to create your bot's account, how to actually get the bot up and running. And there is an awful lot to cover here, so let's just go straight into it, shall we? To actually create a bot, you need to come to the Discord developer portal. You can use this URL up here. I'll also put it in the description just so it's easy to get to. Make sure you're on the applications tab, and then you click new application over here. Give it a name. I'm going to call mine carbohydrate because I am very original. Click create, and it will give you an application. If you come over here to the left, you'll see bot, and you'll notice that it also gives you a bot. So you could change your bot's username. I don't think this has to be the same as the application name. You could change the icon and the banner if you want. We're not going to do that here. You might want to come down here and look at privileged gateway intents. You don't need to worry about these fully until your bot is on 100 or more servers, so I'm not really going to talk about these. But you probably want to turn them on. But make sure you do come back and learn about these once your bot hits that limit. You want it to be a public bot for now. And then you actually want to get a token. And to do that, you hit this reset token button. Yes, do it. And you'll want to do this every time you accidentally leak a token. So I'm intentionally leaking this token. I will reset it before this video goes out. But this is the only time you see it. So you want to copy it. And then we actually want to come into our editor very quickly. And we want to put it in a .env file with this format. And we'll talk about what this .env file does in a bit, but I just want to put that in there for now, so it's there. We then come back to add it to our server. We then go to the installation tab over here. We deselect user install because we want to do it as a guild install. We have Discord provided link, and we want to select the scopes to bot. We want to select the permissions down here as well. I'm just going to set mine as administrator, though you will select the permissions you want the bot to have. Save changes, click copy, and then we put that in the browser. From there, you just need to add it to your server. So when this eventually loads, there we go. I will add it to tutorial video, which is a server I created specifically for this. Click continue, click authorize, make sure the actual things are correct. Once that's finalized, you'll get this success screen, and then you can come over to Discord, and we'll see if you go into general. This is all my testing. We have the bot joined, and if I go back into video, the bot is over here as well. Again, this is a test bot that I was using to make sure that everything worked. So now that's all we need to do on the Discord developer portal. So we're going to go over to our code editor, and we're going to install the libraries that we need to install. So we are going to be using a library called Hikari. And Hikari, I'm using Hikari over Discord.py because I prefer the syntax, and also it's a bit more extendable and customizable. It's designed to be a fairly low-level wrapper around the Discord API, and then you can have different extension libraries, or I'm not really sure what they're called, but you can install different libraries to do different things. So you can choose your command handler, for example. So there's actually multiple ways of creating commands. So if you don't like a particular part, you could just uninstall that part and then reinstall something else. There's also other libraries such as advanced handling of components. We're not going to talk about that in this video, but that's something you can do. You can also install it with speedups as well. I might be wrong about this, but I think speedups only works if you're on Mac OS or Linux. If I'm wrong about that, do correct me in the comments, but I believe that's true. We are then going to install our command handler, and in this case, I'm going to use Crescent because the syntax, I just prefer it over the others. We then also want to install python.env, which will allow us to read the .env file up here and be able to load that properly. And then we also want to install UV loop as well. This is optional, and this definitely does not work on Windows. this is a slightly faster, it might be more than slightly faster, implementation of async.io. And we can set async.io to use UV loop and it'll be quicker. But again, it's completely optional. So if we install those, I've already got them installed. I believe we are using, oh, it would help if I actually passed it in. We're using Hikari 2.1 and Hikari Crescent 1.1. So we are only going to be creating a simple bot today, but I do want to show off a directory structure for how you could create a more complex bot, or at the very least, how you can keep it all organized. So we're actually going to create a folder, not a file. We're going to create a folder called carbohydrate. This will be just the name of your bot. And then inside that, we are going to do a dunder-init.py. And here we're going to do import.env and then just .env.load.env. And this essentially just loads everything in our .env file into the environment variables. So that's where this .env file comes in. So if you have any other sensitive information, so any other API keys that you're connected to, you'd want to put them in here. You could also put settings in here as well and have them loaded in. And that's just a really nice way to keep things separate. If you do upload your bot to GitHub, remember to not check out or not check in this file here. You don't want this file on the repository. Just keep that in mind. We are then also going to create a dunder main file. And this will be the file that actually runs the bot. And I'll show off how to do that in a second. So if we do import OS, and then we do import Crescent and Hikari, and we want to actually create a bot. So Hikari.gateway.bot, and then we want to do os.environ token. So this is our Discord bot token. And we want to do intents equals Hikari.intents.all. You only want to do that if you selected all the intents previously. There are other options if you didn't do that. You then also want to create a client, which will be the crescent.client. And this wraps around the bot and provides the command handler. From there, you can do if name equals main, and if os.name does not equal nt. So if we're not running this on Windows, we want to import async.io, not like that, and UV loop. And then we want to set async.io.set event loop policy, UV loop.event loop policy. And this is the optional step. You don't have to do this at all, but it's just used a slightly faster async.io event loop. Or maybe more than slightly faster. Again, I don't know. And then we're going to just do a bot.run on this. To actually run the bot in this configuration, what you'd want to do is you want to be in the root directory, and you want to call Python with the module carbohydrate. So this -m allows you to run a module directly, and this will call the module name /dundermain.py. So this is actually our run file. If you run that, we will get a number of log messages. It's not rendered quite correctly because I've got this very zoomed in, but you get this. Normally, let me zoom out a bit, and that might, there we go. You get this nice little colorful banner and some information. We're actually getting a warning saying that we haven't run this with optimization flags. I'll talk about that real quick, but we get a lot of logins saying everything's fine. So if I zoom that back in, whoops, I didn't want to do that. We could actually run this with optimization flags using -o or -oo. I made a short talking about this a little bit. I'm not going to talk about in too much detail what that does. It's just a Python flag. I recommend going and looking it up. But it does help speed ever so slightly. You definitely want to be running it in production, I would say. So now we've done that, we can create our first command. And to do that, we simply just do @client.include, and this is a decorator that will include whatever we put under it into our client. We then want to create a crescent.command, and we can set the description to be pong because our command is going to be a ping command. ctx crescent.content, and that is going to return none because it is simply just going to await ctx.respond pong like that. So a few things to talk about. this is a command registering. It's a simple command, so we can register it as a function. Typically, Crescent use classes, but we'll create another function with it. We get passed in a context, and this context has a lot of different things attached to it, including all sorts of information about the state of Discord at the time. I believe it has the author of the message in there as well, but it also has this respond function, which just sends a message back to the channel the command was invoked. So you don't actually need to know the channel. You just need to know to respond to it. This just takes a string like that. If we were to then run this bot, and if we were to go back to Discord, all the way back, here we go, and then we were to run ping like that, it also creates slash commands. We get pong back. And that's because we have used the command and we've responded to the context. So that is more of a simple command. You'd only really want to do this if your command doesn't take any options, because there is a different syntax for commands that I'm going to show. I'm also going to show it in the context of plugins. So plugins are how you can organize commands into a more structured interface. So you don't have to put every single command in this file and watch it grow to 1 million lines long. You can have them in plugins. So you can organize and structure your bot and make it a lot more maintainable. To do that, we will want to do client.plugins.load folder, and this will be carbohydrate.plugins, and we are going to create a directory here called plugins. So this load folder will load everything within this directory and then inside this directory. And in here, we are going to create a plugin called dice for a simple dice command. If I just bring it up on my notes, there we go. So for this, we want to import random, Hikari, if I can spell, and then Crescent. And we want to create a plugin to be crescent.plugin. And then we actually do, if we're doing static typing, then we do want to pass the bot instance here and then none here. We don't need to worry too much about that at this stage. But if you want type safety, you'll need to do this. So we have plugin dot command, include, not command, and then crescent dot command. So this will include it in the plugin, and then we have our actual command definition. We're going to set this name equals role, and a description equals just role. We're actually going to make it a bit more complicated than just rolling one dice. And then we're going to create this as a class instead. And the good thing about this is that you can define objects, you could define input parameters to the command as class attributes, and then you could just define a callback which serves as the logic. So we want to create an option to change the number of dice that we roll, and we can do that using crescent.option. And we want that to be a number, so we want it to be an integer. Description, number of dice to roll, that looks fine to me. We want the min value to be 1, and we'll say the max value is 20. That seems like a good max to me. We then want to change the number of sides that each dice can have. So again, we can do crescent.option. And this is going to be another integer. Number of sides. Each die will have. There we go. We'll say min value is 1. Max value is 100. We can actually set a default here to be 6. So this is now an optional argument because it has a default. We don't need to provide this when calling the command. And then we can have a bonus, which I'm just going to copy paste from my notes, which is just a fixed number to add to the roll, which again is optional because it has a default of 100. To actually define the logic for this command, we need to do an async def callback, which also takes the same context as before and returns none. And then I'm actually going to copy paste this logic and run through it, because this is just Python logic now. So we get dice between 1 and the number of sides, and then we roll that many dice basically. And then we respond with a message with admittedly quite a complicated format, but this essentially is all just Python stuff. We use the ctx.respond once again to respond to the message. If we then turn that down and then we run it again and go back to Discord, if we then do /roll, And we can set the number to be, I don't know, 10. And we just do that, and it rolls 10 dice. If we set the number to be 3, and then we can access these other options. So sides, we want to do 20, and then say the bonus we want to be 5. We can do all that as well, and it's now rolled 3 20-sided dice and added 5 as a bonus. One quick tip when creating commands like this, sometimes Discord can be really annoying and not actually register the command. If that happens, just press Ctrl R to reload Discord, and then it should load at this point. You can check what applications, also you can check what commands are currently active by using this menu down here and then clicking on your application here and then seeing this. And you can actually send these things. Let me do it in the pings as a better example. You can actually send the commands through that message or through that interface as well. And we haven't done an awful lot here today, but as you can see, protocols are a very widely used part of Python. In fact, you've probably worked with them in the standard library before and not even realized. They simply provide a way to say that a certain class should have either a certain set of attributes or a certain set of methods, or both. We've actually talked about protocols a little bit before in the descriptors video where I talked about the descriptor protocol, which indicated that descriptors must have a .get, .set, and .delete method, or more accurately, at least one of those. While that example is a predefined protocol in Python, you can actually create your own using the typing.protocol class. And that is what I'm going to be showing off in this video. Quick little thing before we get into it though, if you are interested in seeing any of these videos earlier than anyone else, then consider becoming a member on the Carbarian tier using the join button below. With all that taken care of, let's learn how to design our own protocols. Python actually has a number of protocols built in already, as I alluded to in the introduction. And the first example I'm going to show you is actually how to essentially build one of those. So we are going to be building from typing import supports int. And this will check if a class has the int method attached to it. And if it does, then it can be converted to an integer, and as such it supports int. But if we were to do this ourselves, we would need the protocol, and then we would simply just do class supports int protocol, and then define this int here with the self, which is the signature that we would take. It then returns an integer as we would expect, and then we can use this ... syntax, or you can use parse if you want. But typically speaking, I've found that at least in PYI files, ... is used quite a lot to show, as it's essentially just a placeholder. So I'm just going to do it like that for this. And that's literally all it is. It is just a case of making a class inherit from protocol and then defining what attributes and methods, because you can put attributes on here as well, the class should support. And you can use these especially when it comes to type hinting. So if we do the def convert to int, and then we take just a value that supports an int, and then we can return an int. And now we can say that any value we pass in here will be convertible to an integer, at least as far as the type system is concerned. So if we were to do if name, not if annotations, if name double equals main, and then we did convert to int 1 or 1.0, integers and floats can both be converted to ints just fine, and as such, or they both, specifically they both define the int method. An int will literally just return itself, but a float will return a truncated version of it. If we were to do this again and then provide a list does not define the int method, as such cannot be converted to an int, and it will raise an error in the type system. However, if we try to do that in here, then it will get past that, and it will give us an error, but it will give us an error at the time it's converting, which we can actually prevent. So we could do if not is instance value supports int. We could do raise type error values not of instance supports int. And you'll notice we get an error if we do that. And that's because this protocol isn't runtime checkable, as they call it. So in order to make a protocol runtime checkable, you can import the decorator from typing and then just simply decorate the class with this runtime checkable. And what this does is essentially it allows you to use them in is-instance checks like this one. So now we can use this to check if value has a dunder int at runtime, not just in the type system. And if it doesn't, we can raise an error much earlier and say type error. So instead of getting, well, we get a type error before, but now we get a different error, a custom error here that says that a list is not an instance of class. And we probably want to do name actually in there. There we go. So or actually you could probably do cannot be converted to an integer. Whoopsie daisies, I've messed up. And now you get a bit of a custom error. So those are the basics of protocols. I do want to go over a few more examples to really kind of drill it in. And the first one we're going to do is sendable.py. And this one is going to, again, from typing import protocol. And then we're going to class sendable of a protocol. And we're going to have a method called send. And this is going to take a message of string. And then it's going to take an optional anonymous argument, which will default to false. And I just wanted to do this to show that it can take arguments and keyword arguments as much as you like. And then if I just copy paste the example, because it's not that spectacular, it just takes the object, takes the message, and then sends the message via the object. As you can see, we have this anonymous equals true. We can get rid of this, and now the behavior is changed, and then you have the same type ins as before. I also want to use this example to talk about some limitations of protocols. So you can't have like partial protocols or protocols that accept arbitrary arguments. So you can sort of make it work at the actual function defining stage by doing something like quargs and then have that as any, and then do typing any. And then if we were to have a message, say, and it had a send argument, and we had that, and say that this message had an anonymous flag on it instead of the protocol itself. This would work as far as this is concerned. We don't get any problems with this yet. Even though anonymous isn't really recognized as an argument, that's fine so far. We're not getting any errors. If we were to try then and create this using send to and then message hello. So if we create a message, or maybe like a channel or something, not a message, that's probably better. So if we were to send to like a channel, and channel had this send, the protocol wouldn't match, because while the message is fine, anonymous and quargs don't really match up according to either MyPy or Pyrite. And there isn't really a way around this. There are some issues in GitHub. So there is if I just bring this over and then zoom this in a bit, we have this Pyrite one, which is the one I found first. How to write a protocol that has a method that accepts arbitrary arguments, with a similar example. And then the solution is largely just to, where is it? Essentially just to type hidden sort of nothing down here. And we have a similar one in MyPy. And the discussion was, or the consensus was pretty much that this shouldn't be fixed and that the type checkers are doing it properly. So that's just something to keep an eye out for with regard to protocols. So one final example I wanted to run over is how protocols can be useful to avoid having to import things all over the place and potentially avoiding circular imports when it comes to type checking. Of course, one way you can do it is by using the from typing import type checking, but protocols are another way you can do it. And I think quite a clean way of doing it, especially if a class is enormous or whatever. So let's say you have this setup app, and this is based off a real world example that I have, heavily changed to kind of anonymize it a bit. But you have this configuration, and then you have this app creation logic that accepts the configuration, but this is in a different file. And maybe it's in some like common library somewhere completely on the other end of the earth that doesn't have the ability to import config, or maybe there are circular imports for whatever reason. if we go into this create app here, we can see that we can define the config attributes that we need. You'll notice that we only need the service name and whether or not to configure malware when creating the app. So in a config situation, you're only going to need certain things in certain situations. In this case, we only need these two things. So we can create a protocol that ensures that our configuration has these two attributes on it. And if it does, then everything works fine. And that is also an example of how protocols can assert the the attributes are present on a class, as opposed to just methods. Of course, you can mix and match, so you can put both attributes and methods on the same protocol, make sure it has all of them. It's entirely up to you. Let me know in the comments if you've ever used protocols before. If you've ever written a class in Python and thought, God, I wish I could just not have to deal with this boilerplate anymore, then this video is just for you. And that's exactly what data classes let you do. You create a class with its attributes and it creates the initializer, the string representation and all that for you. If you've ever used something like attrs or Pydantic in the past, then this will look very similar to you, and that's because data classes are actually designed based on attrs. They are a simplified version though, so they might not be quite as fully featured as you might like, so have a look and see what you think. In this video, I will show off what you can do with data classes, how they're designed to be used, and I'll also show off a really cool extra functionality that attrs doesn't have. Of course, if you find this video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like it. If you want to see future videos before anyone else, then consider becoming a member using the join button below. With all that out of the way, let's take a look at arguably one of the most useful things in Python. Before we start, I just want to say that VS Code is being a bit weird today. It's flickering a little bit, and I don't really know why. So sorry about that. It's not too bad, but I did want to mention it because I think it is probably obvious. But to actually use data classes, we just need to do from data classes import data class, not default factory, data class, and then fields. And we'll be talking about what these do in time. And then for our specific example, I want to do a bit of a setup. So do from enum, import enum and then auto, and then I want to do a gender enum, which has male auto, female auto, and then we'll go the Google route and say user specified. If I could spell it, there we go, which is auto, and that just helps me explain something a little bit better. To actually define a data class, you define a normal class, but as you can see from the AI, you use a data class decorator. And you could define it like that, or you can define it as a parenthesized one if you want. It doesn't matter. There are options you can pass to the decorator, but we'll talk about those in a second. So either one is fine. I'm going to do it with because I actually prefer the look of that. And I'm going to be doing my favorite example, which is a profile. And we're just going to have name, which is a type string, age, which is a type int, gender of type gender, and then we're going to have jobs of type list string. And then it is actually going to spoil a little bit here. But if we just go to this first one for a second, well, these first two really. So you define on the top level as a class attribute, your attributes, and then you have to define their type. So type hints are mandatory in data classes. And this will create a dunder init function with these arguments to the constructor. And this is a theme of what data classes do. They auto-generate pieces of code for you, so you don't have to deal with the boilerplate yourself. So if I were to do this using just a normal class, I'll do class profile like that, and then I would do a dunder init, and then I would have to do like name, string, age, int, gender, etc., etc. So I have to do like that, and then I would have to do self.name equals name, self.age equals age, etc., etc. So this just removes the need to do that. One other thing you get with data classes is default factories. So these are particularly useful for lists, especially in like tuples and dictionaries and stuff like that. And this helps you avoid the immutable values as default trap that you can fall into. So in Python, if you were to define, we'll just do a function. If you were to define a function that took, say, a list, and its default was an empty list, this is actually not something you want to do, because this is created in memory and then assigned to LST. And then if you were to use .append on this, for example, the default would actually change, which is not ideal. It can lead to unexpected behavior. Data classes have a way around that,
where you can use the default factory equals list, and now to create the default, it will call this list function, which is actually really nice. So that just provides a good way of doing that. You can still do just normal defaults. So for the gender example, we could do gender.userSpecified as the default. And now this would say, I don't know why that's complaining. Auto has, that's weird. It wasn't complaining earlier. Oh, I haven't set this as an enum. That would be why. So if I set that as an enum, there you go. It's not complaining anymore. That was a big flicker there. But yeah, you could just set a normal default like that. You can also set a default here if you really wanted to. And then to create a data class, if we just come down here and do if name equals main, we could do profile equals profile, and then my name, which is Ethan, and my age, which is 26 now. And then we can print p, and one of the other things, or print profile, sorry, one of the other things that data classes does is it auto-generates, that was a lot, it auto-generates a string representation for you. So it does it based on all of the different fields within the data class. So we have name, age, gender, and jobs defined here. So we have name, age, gender, and jobs defined in the output. We can change this behavior, but we'll talk about that in a second, because I do want to talk first about the options that you can pass into data classes. So there are a number of things you can do. So init is whether or not you create the dunder init. Repr is whether or not you create the dunder repr. EQ is whether a dunder EQ is created. So if I were to do, say, another one of these and say profile 1 and profile 2, we can now check if profile 1 equals profile 2, and it will know what to do. And what it does by default is it checks, okay, does profile1.name equal profile2.name? Yes. Does profile1.age equal profile2.age? Yes. And then it goes through. And if all four match, then it will return true. If I were to change this to 25, we'll see that it returns false. So that's what the EQ does. The order is very similar, but it does the dunder LT, dunder GT, and I think LT and GT as well. So you'll be able to do things like profile 1 less than profile 2, if that was something that worked for you. That's false by default, because in a number of situations you're not going to want that, and you probably won't ever want that as a complete thing, because the data class decorator sets this for all of the fields. You can set this for fields individually, and we'll talk about that in a bit. Unsafe hash is related to the data class's hashing ability. So the data class will create a hash automatically, or will create a dunder hash method automatically if it's safe to do so in the data class. So I think it would be safe to do so here. So we could do hash profile 1, and then we'll see if it does or not. No, it hasn't. So it's actually detected. I wonder if it's the enum. No. What else can it not do? Does it do that as well? Oh, that's weird. I don't know. Should do the hash by default. Okay, so quick check of the documentation. It will only do it if everything is immutable within the data class. So we can change age and we can change name. I think if you were to set it to, let's see, there's a frozen one as well, isn't there? Yeah. So if we were to set frozen equals true, which does actually make the data class immutable, it means you can't change everything once it's been created. I believe it will do this now. Yeah, so it actually does try it now, but it can't do a list, so we can just undo this for now. And there you go, it can do a hash. Unsafe hash, what that does is it will try and create one even if things are mutable. So sometimes it might work, but the hash could potentially change. And it's not recommended, but it will let you do that if you want to. Frozen, we just demonstrated it will make everything completely immutable. So for example, you wouldn't be able to change profile1.name equals like John or something. And we'll actually get a type error saying it's read only, but we'll also get a runtime error saying that we can't assign it to name. You then have match args, which is more objects generally rather than data classes specifically, so I'll leave that one alone. KW only means that arguments will only be able to be provided as keyword arguments. So if we set that one, keyword only equals true, we'll now get errors down here saying that it needs to be, there's too many positional arguments. So we can then do name equals and then age equals, and it'll be fine with that. And then the final few slots, which will create a dunder slots attribute on the data class, and a weak ref slot, which is to do with weak references. And most of those things you can do in a field as well. So if you go to the jobs down here, we see that most of these things are here. So init on a field means that, if init is false on a field, it won't be included in the initializer, but others will. Same in repr. So if you didn't want, say, the jobs to be included in the string representation, you could set this to for false. And if I were to print profile1 now, then jobs wouldn't appear in the string representation. You then have hash, so whether or not you want this to be included in the hash or not. So if the data class was frozen, we can then set this to hash equals false. And now the unhashable list type won't be included in the hash for profile1 here. And it will come out with, it will come up with a different hash every time, actually. That's supposed to do that? I'm not sure. I don't pretend I understand the hashing logic in Python, but that's how that works. You then have compare, which, if true, means that field would be included in equality and comparison methods, so ordering methods like GT, EQ, LT, etc., etc. Metadata, which I don't really understand the purpose of, to be completely honest. It's just some random metadata on the field. If anyone does know what that's used for, then do let me know. I can't really figure out a use just looking at the docs. And you have KW only, which means that this particular field will be keyword only. So if we set keyword only equals true, and then if we try and do, if we set the gender equals like male, for example, and then if we were to get rid of that, and then we got rid of this, you'll see that we end up in an error with too many positional arguments again, and we could set jobs equals here because it's keyword only. And that's what you can do with a field. Of course, you can set the default and default factory as well. I think default is something you can do in a different signature, but of course you can just define it like this. The other way that you can define all keyword only arguments beyond a certain point, so if I were to get rid of this, if I had to get rid of all these actually, is to use the KW only, I guess, constant. And then if we set it here, set underscore and then set that as a type of keyword only, then now gender and jobs must be provided as keyword arguments. So if we were to set this, then it'd be fine. And that means that we don't have to provide a field for each and every one if we don't want to. Some people really don't like this syntax. I do prefer it to needlessly having to define field every single time, but some people won't, so that's entirely by choice. Some of these things are only available in certain Python versions, so slots is 3.10, for example. I think this keyword only thing was either 3.10 or 3.11. So if you are using data classes in an old version of Python, then do make sure that what you want to do is actually included in the version that you're trying to use. So that was a very rapid rundown of more or less everything that is included in data classes. There are a good number of things in here. Other alternatives that you might like are the attrs module or the attrs package, which is a bit more fully featured and is backwards compatible, I think, all the way down to 3.6. I've always tended not to get along with that very well, but that's an option if you want it. The other option is also Pydantic, which is a similar thing, but it's just much more feature-filled. I've already made a video on Pydantic if you want to look at that as well. Before we finish up, there is one more thing that I want to show with data classes, which is actually something that attrs doesn't have, and that is init vars and post initialization. So if we create a file called postinit.py, and I'm going to use a very minified real-world example of this. So we're going to do from data classes, import data class, and then we want init var as well. Then we want to do class responder, which is the name of the class in the real world example. This is basically just something that can respond to a query in an abstracted format. We are only going to care about a few things though, and that is the cache TTL, which was a field. Oh, we do actually want to import field then. There we go. With a default of 300, and it had a repr of false. And this cache TTL stands for cache time to live. So there was a few cache arguments, a few caching support connected to a Redis cache, and it used this argument to tell Redis how long the cache entry should last. And by default, that was 300, so 5 minutes. However, if the cache time to live was set to 0, it would say that the cache was disabled. So there was a property elsewhere. It was like cache disabled self, and then that returned a bool. And then if the cache TTL equals 0, the cache was disabled. This is not the easiest thing to communicate to users, especially at a glance. It's just not obvious that cache TTL would be 0. When you think about it, logically that does make sense. But if you're looking for a way to disable the cache explicitly, you might not think to do this. And this is where you might come up with something like a disable cache argument, which is say false. And that would actually need to be a bool. And actually looking at it, this would need to be type hinted to an int. There you go. So now you have this disable cache, which is a lot clearer to the user. But then if disable cache is true, and you set it down here in this property, but then the cache time to live was still 300, that doesn't make a whole lot of sense. But if you set the cache TTL to 100, but the disabled cache was false, this would still disable the cache even though this was false by default, and that doesn't make an awful lot of sense either. So you end up having to synchronize these two arguments, and it all gets very complicated. However, with init vars, this becomes a lot simpler, because what you can do is you can set this as an init var, and now the disabled cache is no longer an attribute of the instance. When you create the responder, it won't have a disable cache attribute to it. It's just not a thing on it. You can actually come down here. If we say r equals responder, if we were to print r dot, you see we can have cache disabled and cache TTL. It's not even there. So with that in mind, you might be thinking, what does this do? Well, it is provided as an argument to def dunder post init. We can do disable cache, and this is a bool like this. Return none. And this post init doesn't have to have any init vars to be used. It can just be post init itself, and then you can just use it. But this is called after the dunder init, and allows you to have or run any extra operations you want to run without having to create a whole custom init to do it. So this is basically just a way of bypassing having to create a custom init. And what we can do in this situation is, if we've disabled the cache, we can set the cache TTL to 0. And now this is like a shortcut. So you can pass whatever you want to the cache TTL, but if you pass disable cache equals true, it'll override this value to 0. So now you only have one value that determines the cache state, and it's now in a state that makes sense. So if we were to do this, just say disable cache equals true, and you'll remember that the cache TTL is 300 by default. If we were to print that and then print that, we would get 0 and true, because this is now overridden that value. And it doesn't matter what you pass to cache TTL, because this is always run after it. And disable cache works as expected, and we only have one argument tracking the state, which is a lot easier to maintain. Let me know in the comments what you plan to use data classes for now that you know. Typing.Annotated is one of those weird things in Python, because it bridges the gap between actual functionality and types. It allows you to assign metadata to a type, which can be literally anything, and that can be fetched at runtime to perform special operations. The use case we're going to look at in this video is attribute validation, but you can also use it for things like dependency injection and lazy evaluation as well. So really, it's a good one to know about all around. Of course, if you find this video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. If you want to see them earlier than anyone else, you can join as a member by using the link in the description below. With all that out of the way, let's find out what typing.Annotated is and all the crazy ways in which we can use it. I'm doing something a little bit different today. I'm recording this on my PC instead of my Mac as a little bit of a test. to see how it goes. So let me know what you think. Definitely not using Arch, by the way. But to start using typing.Annotated, all we have to do is from typing import annotated. Whoopsie daisies. And then for my use example, I actually want to do import any from there as well. And then we want to do from data classes, import data class, and then field. And we are going to do my favorite example, which is the profile. Hey! And we're going to have name, string, age, which is going to be int for now. We're going to come back to that with annotated later. And we're going to do jobs, list, string, and then for posterity, we're going to do field. Default factory equals list. If you don't know what data classes are, you can look at my video from a few weeks ago, I think, that goes into detail about how these work. But this is a pretty simple example that has name, age, and jobs. In a different video, I forget which one, maybe the descriptors one. I know I've done so many at this point. We talked about how to use it for validation purposes, and we made sure that age was a positive integer. And what I may or may not have mentioned in that video was that you can actually use annotated to do the same thing. And that's because annotated has a bit of a superpower about it. So to use annotated to do that, we can simply do annotated like that. And then this takes two arguments. So the first one is the actual type itself. And that'll be an int. And this int will be used by the type checker to make sure that age is indeed an integer. The second argument is metadata. And this metadata is completely ignored by the type system, but can actually be looked up or accessed by the code. So you can put something in here maybe to run, say a validator, for example. And we could do a simple validator that's just a lambda function that takes an argument, which will be the age, and then do age is greater than 0. And now we can run this to actually make sure that age is greater than 0. And to do that in a simple way, we could do, we can have a set attra down here, which takes name and value. And this controls what happens when you set an attribute on a class or a data class. It works on both. We can do if fields self.dataclass fields.get name. So we are actually getting the field, and this is a field object. And then we can check if metadata, and I'm going to get rid of this sidebar actually for this, is getAttra field.type, which is the type annotation, so it will do this. And then if it's annotated, it will have a dunder metadata attribute. And we can set none if it doesn't have it. And so if it does have a dunder metadata attribute, we can see, oh, it's an annotated type. We probably have some metadata in here. And then we can just do something like assert metadata 0, because it will get, you can pass multiple things in here. So you could, if you wanted to, pass multiple validators. So we could say lambda x is less than 100, for example. We don't want to do that in this example, but you could do that. So it would give you a list of all the different metadata entries. So we want to get the 0th one in our case. And then because this is a function, we want to pass the value to it, which is the value that we're setting for the age in our case. And then if that fails, we can just have like invalid value. I'll copy paste it from my notes actually, because it's just a lot of typing without much meaning. It's just a nice little error message. Have on the metadata. So if it's not correct, it will say invalid value passed name field value. Fantastic. And then we want to make sure that we call super.setAttra name and value, just to make sure that the rest of the logic gets played out after that. So we just add a check in here to check for annotated types essentially. And now we can come and create our class down here. So P equals profile. My name is Ethan. My age is 26. And I have a job as a software engineer. Oh, very fancy. And also probably rather expected. And then we can print P just to make sure it's all working fine. And that was that was a lot that went on there very quickly. I forgot I had that arch thing up. We can do pi validation.py, and it works fine. Everything works as you expect. If we set this to say -26, it will now complain at us, and it will show that it's this value here that is wrong, and it will give us the message invalid value passed to age field -26. So that's actually run through this check, looked at this annotated, seen this metadata, run this function. This function has then returned false because -26 is not greater than 0, and then we raise an assertion error down here. This also works if you were to set an attribute retroactively. So if we just set p.age equals -26 or -26, then it will do the same thing. So we get the print when it's constructed because we pass something valid, but then we set p.age equals -26 down here, and then we got an assertion error. And that's coming through the done.setAttra. An example of this being used similarly in the real world is Msgspec. So I did a video about this recently as well. But Msgspec uses it, where is it? This Msgspec.meta thing. So you have your annotated type here, that is an integer. And this is actually the same example. So it checks for a positive int, and then you have this Msgspec meta greater than 0. And this does its own checks in a slightly more comprehensive way than the way that we looked at. I didn't want to overcomplicate it too much. But this is the primary way, and maybe the only way, I'm not sure, that Msgspec does its validations. Pydantic does validations in the same way. You can use annotated, you don't have to, but they recommend you do. And it works in a very similar way to how it works here in Msgspec. I was originally going to code some more examples like I normally do, but a lot of annotated use cases are quite advanced, and to be honest, they all work in roughly the same way because you just check for the metadata field pretty much however you do it. So I'm going to show some more use cases that are in the real world of annotated. So another one is dependency injection in FastAPI, which uses annotated down here. So we have this annotated type to this commons. It is a dict, and it depends on common parameters. So this depends class, let me zoom this in a bit actually. This depends class takes a callable as an argument, which is this callable up here, and then calls it, and then this becomes the value of commons. I don't really fully understand how dependency injection works. I was actually going to make a video about it, and then it didn't really work, so I canned it for now. But yeah, you can use annotated for dependency injection. You can also use it for lazy types like Strawberry does. So Strawberry, this is a GraphQL library and has been my work life for the last 7 months, basically. So I'm starting to get very familiar with this. I want to do a video about it at some point. But this has two classes here, one in post, one called post and one called user, that are dependent on each other. And it uses annotated to then use a type hint. So you can actually use the type checking up here to avoid having a circular import. And then you can use the strawberry.lazy, which will then lazily import that module and then call this type when it's actually needed. So this is a way that you can get around circular imports by using annotated, which is also really cool. Let me know in the comments what ideas you've come up with how to use this. I want to see some more use cases.